Moss presents Intro to Node.js version 2. So super excited to be back to teach this course. Apparently this is a really popular course because a lot of people want to learn how to develop in Node.js after working on a front end. And so when Mark invited me to update it, I couldn't resist. This is one of my most favorite technologies. I use Node.js every single day for many reasons, whether it's trying to buy a RTX 3090s card with a bot, or doing some work at the company that I work at, and everything in between. So super excited to talk about this technology, and I cannot wait to just be part of everyone's journey as they're learning how to develop in Node.js and level up. So a little bit about myself. Obviously, my name is Scott Moss. Right now, I'm a senior engineer at Netflix. I also do courses like this. So you might see a lot of my courses on Front-End Masters. Recently, I've started a YouTube channel where I've been giving videos and tips and things like that about how to break into tech. So I'm kind of just doing a lot of stuff right now. And I also just had a new baby. So I'm like a new dad again, and that feels like a full-time job. So I'm super thankful to be here to talk about this. Now, one thing that I want to just put up front, because when I talk to people who want to learn Node.js, there's always like, well, I know JavaScript, so therefore I must know Node.js. Yes and no. So I just want to say this up front. If you do know JavaScript, this course is definitely for you because Node.js is a runtime that uses JavaScript as its language. So you pretty much know at least the language to use in Node.js, which is going to be beneficial. But there's still just so much more to know about the environment that has nothing to do with JavaScript. So yes and no, JavaScript will be helpful. If you don't know JavaScript, that's totally fine. If you come from a back-end language like Ruby or Go or any other OS level language, this course is also going to be for you because you'll understand how these languages interact with the OS. You'll just learn how to do it in JavaScript now and the ecosystem behind that. So whatever side of the fence you're on, this course is going to be great for you. And what I want to do is just send out this link right here. So you can look at this link for a website that I have deployed, which is pretty much the follow along with all the notes and like copy and paste code that you can have as you follow along with me on this course. You can see the URL right here. So check out that URL if you want to follow along, or you can obviously just watch my screen and we can go for there. But yeah, there is going to be a lot of copy and paste stuff in there as I'm live coding if you just want to stay ahead and be up to date with that. Obviously, this course is from Front-End Masters. I really love the team here at Front-End Masters. I've been teaching courses with them for years now. I mean, they're basically family. We all hang out and do stuff together. So I love working with them. They kind of just, let me teach it the way that I feel is great, and it all just works out. So really appreciate them. And definitely go check out any other courses that they have on there. The catalog is just growing. They literally recorded more this week that I know that I'm going to check out personally. So definitely check them out if you want to see what else is out there and stay up to date. Cool. So the format of this course is basically going to be, it's kind of going to be like a sampler platter. If you don't know what that is, it's like if you go to a restaurant and they have like all these different dishes and you don't know which one to get, so you just order a plate that's got like a small sample of all of them. That's basically how we're going to do this course, because there's just so many things you can do in Node.js, and I want to show you all the different things versus focusing on one thing, because there's actually a lot of really good courses on Front-End Masters that focus on one specific thing in Node.js. So after this course, you could kind of branch off to take one of those as like an elective, dive deep onto APIs or databases or DevOps or whatever. But in this course, we're pretty much just going to have like an intro to like all the really sweet things about Node.js. What is Node.js? Well, Node.js is JavaScript, kind of like what I said before, but more specifically, it's a runtime built on Chrome's V8. So if you've never heard of Chrome's V8, it's the engine that sits inside of Chrome that actually compiles your JavaScript down to machine code so it can be processed, because JavaScript actually has to be interpreted and executed on a machine. V8 is the engine that does that. So some really smart person decided to strip V8 out of Chrome and stick it on a machine, and that allows you to run Node. And that's basically what we have here, and everything is built on top of that. So just like on the front end, JavaScript and Node is also going to be based off an event loop, which if you don't really know what that means, we'll get into it a little more, but just know it is that JavaScript is single threaded, as in it's only going to be able to process work, an amount of work in like one little isolated instance, and then everything else kind of runs in the background. This allows Node to be able to process things much faster than a lot of other OS level languages, as long as those tasks are not CPU bound. So if you're not doing things like arithmetic or AI or machine learning, Node.js is probably a perfect tool for you because it can handle things and put them in the background and continue to stay open to handle incoming requests and things like that. So that's why it's a very popular tool, because it kind of allows you to scale a lot faster for like smaller tasks like APIs, which are like 90% of like backend apps these days anyway. So that was a whole lot, but we're going to cover a lot of that stuff. And like I said, here's just some of the use cases that I think are really, really good for Node.js. Some of the things you see in the wild, some of the things that I've used personally myself. So things like APIs and servers, which we are going to cover today. We're going to be going over that and how to do that. Databases. Yes, there literally are some databases built in JavaScript, and it kind of blows my mind how people get away with this, because I've like looked at source code. I'm like, first of all, I don't even know how to make a database. And second of all, the fact that you did it in JavaScript is just even more amazing. But yeah, I've seen databases built in Node. CLI, so a command line interface. If you've ever used Git, you've ever used anything in your terminal, your command prompt, that was a command line interface. We're also going to be covering some of that as well, so you'll be making your own CLIs. Build tools and automations. If you're a front-end developer, you're probably familiar with something called Babel, maybe even TypeScript, Webpack, Rollup. All those tools are built and executed in the Node runtime. So if you've never used Node as a front-end engineer, but you've used those tools, well, you have been using Node this whole time, because those tools execute in Node before your app actually gets deployed to the browser. That's what Node is doing. Basic scripting. You want some automation set up to do some shortcut Git commands. You want to have some basic commands in your terminal that don't exist. You can do that. Simple automations that open up a browser and buys a pair of sneakers for you. Stuff like that. And like I said, GPU shopping for bots, because no one can buy a GPU right now. You could pretty much do all this stuff in Node and more, and we'll be covering a lot of it. So I'm super excited. So let's jump right in and get started with Node.js. So the first thing obviously is we need to install Node.js, and there are a few ways to do it, and it also depends on the machine that you're on. So for the Windows folks out there, if you're not running WSL or WSL2, which is like a Linux environment embedded inside of Windows, if you don't have that, then I do recommend going to the official Node.js installer on the nodejs.org website, where it'll detect your operating system and it'll allow you to download it. Mine says Mac because I'm on a Mac. If yours was Windows, it would probably say Windows. So I recommend installing it that way. And if you aren't on Windows, or anyone else who's not Windows basically, I do recommend using something called NVM, or Node Version Manager. And the definition is in the name. It's literally a tool that manages different versions of Node on your machine. And the reason why I recommend this is for a few reasons. One, it's very convenient to be able to switch to different versions of Node, because different versions of Node have different features, different language support, and things like that. So you can apply your app to different targets. Great for testing, great for determining what version you need on a deployment platform. It's just very useful. And then also on a Mac, at least in my experience and working with others, when you install from the official source, sometimes you have permission errors with the folders where Node actually gets installed, and you just kind of have to like sudo everything, and it just gets really crappy. So to avoid that, Node Version Manager just does a workaround and doesn't install inside of that folder that causes those permission errors. So yes, I highly recommend NVM. And if you go to if you click on that link that I have and you go to their repo, if you scroll down, you'll see a nice copy and pastable curl thing here that you can paste and run, and it'll pretty much get you set up and good to go. So if you don't have Node installed yet, I do recommend installing it. If you do have Node installed, we are going to use a specific version. And the one that we're going to use is going to be the latest LTS, or was it long-term support or lifetime support? It's one of those. It's the one that they plan on supporting On the long run for now, although it's not the absolute latest, 16 would be the latest, but it's not the latest LTS. So we're going to use the latest LTS, which right now is 14.7.0. So if you don't have that version, I would at least recommend downloading version 14 at the minimal to make sure you have some of the things that we're going to cover in this course, because we are going to be using some of the bleeding edge things, because I want this course to be somewhat future-proof, and I don't want to teach outdated things in older versions. So yes, I highly recommend downloading at least version 14 here to be able to keep up with what we're doing. If you do download version 16, you should be more than fine. There's nothing wrong with that. I just want to support the long-term support version of Node.js. Okay, and once you have NVM installed, you could actually just run this command right here, nvm install --lts, and it's just going to install that latest version for you, so you don't have to figure out which one it is. If you don't put that LTS flag, I think it will install version 16, which again is also fine, as long as it's at least 14. So whatever you want to do, install that latest version so we can get going and making some stuff. The first thing I want to talk about is how we can actually execute a Node program, because there are a few ways. In fact, there's several ways, but we're really only going to talk about the important ones. So the first one is called the Node REPL, and REPL stands for Read, Evaluate, Print, Loop. It's basically an interactive shell that's going to be in the execution context or the runtime of your choice. In this case, it's going to be Node. So we'll have an interactive shell inside of our terminal where we can just write some JavaScript in the Node runtime. Very similar to where if you open up the console in a browser like this, and you were able to interact. This is a REPL, right? So I can come in here and I can do stuff like this, right? So we're gonna do the same thing, but outside of the browser using Node.js. And the way that you can do that is if you just go to your terminal, and I need to open up mine. There we go, here's my terminal. I'm actually going to go over to my folder. Am I here? Oh, I'm already in here. Okay, so I'm gonna make this bigger. And what you can do is you can just run the Node. First of all, just to double check you have Node installed, I recommend running which Node if you're on Mac, and it's going to point to where you have Node installed. You can see that I used NVM, so it's installed in this NVM folder. If you installed it from the actual Node source, you might see something like user bin if you're on Mac, and you'll see it installed there. On Windows, I have no idea what it's going to say when you installed it, but just make sure that you have it. You can also just type in Node version and see what version of Node you have, just to make sure it's there. If you're getting an error when you type in the Node command, then it means it's not installed properly. So go back and follow those instructions. So once you do have it installed and we want to execute on that REPL, where you want to turn it on, you can just type in Node with no arguments, and you should see something like this. Welcome to Node.js, followed by the version that you're on, and then you can do something like called type help for information. But now we're in this prompt here, and it's pretty much a console just like I showed you in the browser. So if I wanted to make a variable like this, you can see I have it, and then I could actually just type it in, and before I even hit enter to execute this, it's giving me that autocomplete, like, oh, there's the value of that variable. So as you can see, this is a great place to prototype different things, try out different features in JavaScript. I like to use the REPL when I'm doing something quick. I've even gotten to the point where like I'll use the REPL for a calculator versus opening up the calculator app on my computer, because it's just faster just to go on a terminal and type in Node and do math than it is to like go on a calculator and click things. So I use it for a bunch of random stuff all the time. But you probably won't be using the Node REPL to build any applications, as you can tell. I mean, this isn't source code. This code isn't being written to a file anywhere. You can't check it into Git or GitHub. So yeah, you probably couldn't build an application in a REPL, although I'm sure if you were to go search the internet, someone's probably done this before. But that's probably not going to be you, and I do not recommend trying to build an app in the REPL. It's just a playground to get some stuff going. And then to exit the REPL, at least on the Mac, I can hit Control-C, or there we go, press it again, and it will exit for you. I think you can also just type in exit maybe. Let's see if that works. Nope, exit does not work. That's some other REPL. I get all these REPLs mixed up. So yeah, I just hit Control-C to exit that, and that way I'm not inside of that REPL anymore, and now I'm back inside of my terminal environment here. So like I said, you don't want to be running a program inside the Node REPL for all the reasons that I stated. So the real way you want to do it is you want to put your code in the file, just like you've done your whole life, your whole coding career, and we want to execute that file against the Node runtime. And this is where it really gets interesting, because you're going to find out that your VS Code or whatever text editor you're using doesn't really know what context your JavaScript file is going to be executed in. Is it going to be executed in the browser? Is it going to be executed on Node? Maybe it's executed on a mobile device, because JavaScript is basically universal. It can be executed in many different runtimes. So this is where it's very helpful for you to understand when your JavaScript code is going to be executed and what environment it's going to be in, because that's going to determine what features you have access to and what you're able to do inside of that code. So let's start with actually creating a file, and then let's try to execute that file with the Node runtime. So just make a new folder on your computer. I already have one here. It's just a blank folder. I'm going to open it in VS Code. There's nothing in it. And I am going to I'm just going to make a file here inside of this folder. I'm going to call it index.js. And then what I'm going to do is, let's try to do something we would normally do in the browser. I'm actually just going to do an alert here. And I'm going to say hello. Right? This would totally work in the browser. We know if we went to the browser right now and we typed in alert, this definitely works. Right? And like I said, Node.js is JavaScript. So if alert works in the browser and that's JavaScript, then alert should also work in Node.js, because that too is JavaScript. So let's give it a try. So I'm going to go to the terminal, or I'm going to go back to my editor, type in alert, go back to my terminal, and then to execute this file in the Node.js runtime, I just type in node, just like we did with the REPL, followed by the path to that file. So I'm already inside of my files directory here, so it's going to be relative, and that's just going to be index.js. And then I can type and I can enter. And immediately I get an error here. So you can see that I get this thing called reference error, alert is not defined. And these are the differences that I'm talking about. This is why it's very important to understand where you're going to be executing your JavaScript code, because the same JavaScript could work differently depending on the environment that you're in. I could take this same file and add it to a script tag in a browser app, and it would work totally fine. I mean, you probably should have an alert on your site unless you want people to go, running away screaming because it looks like spam, but it will work, right? But it's not going to work here in Node because there is no alert. Node doesn't have a user interface. There's nothing visual to Node. It's running on your operating system in the background. There is no CSS. There is no DOM. There is nothing visual about Node.js. It's a OS level language. So we don't have access to something like alert. And even if we did, what would you expect it to do? Would you expect to see a notification pop up on your computer? Because actually that would be pretty dope, and someone should make that if they haven't already. But no, it doesn't do that. So these are some of the differences that we're going to discover. So let's actually do something that we can do in Node that does also work in the browser, and it's going to be our favorite friend, console.log, right? Console.log is pretty much my, I can't live without console.log. So I don't know how much y'all use console.log, but I cannot live without it. It's basically how I debug everything. I have solved many crises with console.log. So let's try to see if it works here in Node.js. And you can see we do get that message, hello. So the console.log works just fine here. So this is where it gets tricky. It's like, well, what works in the browser and what doesn't work in the browser? What works in Node and what doesn't work in Node? The answer is, it depends. If it's usually something with UI facing, anything with the DOM, anything like that, like querying a DOM, elements, things like that, it's not going to work in Node because there is nothing there. And then on the flip side, if there's usually something to do with like file system or any OS level things like networking, it's probably not going to work in the browser. So I can tell you right now, I don't think anyone remembers all the different things that work. It's more about just, you do this enough, you do a lot of trial and error, you understand which each environment has access to, and you can figure it out from there. Besides, the computer will tell you when you're wrong, so you don't have to guess. It'll literally just, as you saw, will tell you if this doesn't work here, and that's when you'll know. The question was, Node.js was originally created from Chrome's V8 runtime, and that's what it runs on. But if the Chrome team decides that, hey, we're going to make something called V9, what's going to happen to Node? Is Node going to stay up to date with that new engine that Chrome is doing? So there's like a whole board, there's a whole group, a working group of individuals who are responsible for what's coming to Node and what's happening with Node. In fact, there's a lot of history there, a lot of controversial history. At one point, the community split off from Node and made this other thing called IO.js, and then it came back. It's pretty crazy. There's a lot of drama there, but it seems to have settled. It seems to have stabilized, and it seems that they're actually doing really good by getting these versions out. Because for a long time, we were on version like 0.12 for years. They didn't even release version 1, and it took them a long time to do that. So anyway, I think what they're going to do is that they have a process of what makes sense to bring into Node and what doesn't, because they can't bring everything. Because a lot of the optimizations that happen in the browser are browser-specific optimizations and have nothing to do with Node, and vice versa. Node has probably a lot of more security issues that they have to work around and different things like that that don't mean anything to the browser. So I think when it comes to stuff like global JavaScript features that are independent of an environment, like modules or syntax, you can expect those things to come back to Node.js, which is why I wanted us to download version 14, because we do have some of those new syntax features. But when it comes to like environment-specific features, do not expect those to be able to be used inside of Node.js. The question was, what are the differences between version 1 of this course and version 2 of this course? Version 2 is going to be using the absolute latest version of Node, and compare that to the version 1 of this course. So much has changed from the module syntax, as you'll find out, to how you even execute different files and how you test different things. So new tools, new syntax, new execution patterns, and really just me. I've grown as an engineer since I've taught this course last, and I have different opinions. I have different ways about building things. And I want to share those with you all, and hopefully they're valuable to you. So a combination of all of those. The question was, what's my opinion on Dino? I feel like Dino has a lot of potential. I do see some of the shortcomings of Node. So if you don't know what Dino is a new runtime created. So it's a JavaScript runtime, or technically it's a TypeScript runtime that's very similar to Node.js. So it's an OS level language like Node.js, where you can build things like CLIs and servers and stuff like that. But they do things differently as far as like how you import and use packages, how you bundle them. It basically takes some of the best packages that you would have to find, research, and install yourself in Node.js and makes them available by default natively inside of their runtime, so you don't have to do that. So things like testing, things like bundling, you kind of get that for free, whereas Node.js, as you'll find out, you got to go shopping for that. You got to figure out, well, what's the best testing library? What's the best, framework? What's the best server thing? Well, Dino kind of figures all that stuff out for you, and it has a more modern approach about how to build applications, and it's benefiting off of the community and all the patterns that have developed over Node over the last 10 years. So it's just like a combination of like everything that was great about Node that the community had to make, and then let's just put it into this thing and call it Dino. So I do think it has a lot of potential. I don't think it's like, it's going to replace Node. Like Node is everywhere. Like there's so much stuff built on Node that I find it hard that something's going to come and replace it. But I do think there's room for Dino if you're going to go out there and build something greenfield, something brand new, and you don't want to go shopping for all of this stuff. Yeah, Dino could be it. The only limitation there is like what's available for you. The biggest, I would say one of the biggest features of Node.js is the fact that the community is huge. It's like a double-edged sword. It's like, yeah, you got to go find everything, but there's a lot of stuff that you can go through, and it's very helpful. So I think if a community can develop around Dino and everything goes well there's probably potential, but I would say for now, Node.js isn't going anywhere, but Dino does seem promising, and I've actually used it, and I try it all the time, and I like it. The question was testing in Node.js, where sometimes we have to test browser-specific things like the DOM in Node.js, and can we do that in Node? And the question is yes. And I know that sounds confusing because I just said there's no browser-specific stuff in Node, and that's still true. But because Node has a thriving community, people have developed mocked implementations of the DOM. They have developed virtual implementations of the DOM. to where your browser-based code knows no difference. It's the same to it, so it can be executed. In some cases, it can be rendered if it's like a JavaScript framework on the server. So yes, you are able to run a lot of that stuff on the server, and at least the functionality of it. You shouldn't expect to like visually see something, because that still has to be processed by a browser, even if Node is the thing that's sending it to the browser and processing it and taking a screenshot or something like that. But yes, you still have to go through a browser if you want to see a visual output. But as far as testing the logic, testing the DOM and things like that, yeah, at the end of the day, the DOM, when it's rendered, is just a string. So yeah, Node can handle strings. So yes, you can totally test DOM things in Node.js. Let's kind of talk about the environment of Node and really, I scratched the surface about some of the differences in the browser versus Node, but I really want to dig in a little deeper here and talk about some of the globals that we get access to, which are going to be super helpful for us when we're developing our apps inside of Node.js. So like the browser, Node.js does come with some practical globals for us in our applications. Not as many. Like if you go to the browser, you just like, anyone ever just did like window and then hit dot and just go through this list? That scroll bar is barely moving. There's a lot of stuff on the window. So they're not gonna have this much stuff on the global in Node, but yeah, there are some globals in there that we will be talking about. So some of the ones that I wanted to mention was literally this thing called global. So if I go to Node and I say console.log global, I mean, it's literally called global. And I execute this in the terminal, we get this strange looking object with some crazy stuff on it. This is just what the terminal, or this is what Node is representing it as when we log it. But at the end of the day, it's just an object with some familiar properties on them. You've probably heard of clear interval and clear timeout, set interval. Those are, those exist in the browser, and they work pretty much the same way here as well. Then you might see some other stuff like queue, microtask, and set immediate and things like that. And that has to do with kind of like how the event loop works in Node.js, which is something that we will talk about a little bit, but we won't really go into detail about the event loop because I don't think it's that important when you're learning Node.js. I do think it is important when you're trying to get the best out of Node.js though. And you can actually look at other courses we have in For the Masters where we talk about that. So yeah, you have something called global here that's got some really nice things. And then if we go back to our documentation website, there's this other thing called __ dir name, and then the equivalent file name. And these two globals are very helpful because they give you the current directory name or the current file name that you're executing in. So what does that actually mean? Well, if I go back to my code here and I console.log dir name and file name, and I run these, you can see for the dir name, it's literally the path to the folder that I'm in. It's the directory name relative to the file that got executed. And then the file name is the file that you wrote that variable in. So this is very helpful because as you'll see in Node.js or any OS level based language, you're going to be interacting with files quite often, whether it's you're uploading an image, whether you're writing to a configuration file or reading a configuration file or environment variables. Like there's so many times you're interacting with files, especially if you're building a build tool like Webpack. You're literally only interacting with files. So getting these paths right is going to be crucial to you being able to develop those. So these two globals are extremely helpful. We have something called process, which I would probably argue is the most helpful thing inside of Node.js. And this is when you start to understand the power of Node.js compared to like a browser, which is also powerful in its own right, but you can see this how different they are. So if we go to our handy log over here and we check out the process object and we log this, I hope I'm not gonna, wait, do I wanna log this? I wonder if it's gonna show anything that I don't wanna show. I don't know, let's see. There's a lot of stuff on the process. Okay, so the process basically is, it's like the object where everything about the environment is stored. So you'll see like, what platform you're on, the version of Node, different internal things. One of the most important things that you'll see is going to be environment variables, which is somewhere on here. Oh, here we go. So that's what I didn't want to show, is those environment variables. So you're going to see like global environment variables that are exposed on your computer, which is super helpful when you're deploying like a server or something like that, because you don't want to have your secrets out in your GitHub repo and really tick someone off at your company. You want to put those somewhere in an environment and have them be injected in. And you do that, you access those environment variables through the process. So if you've ever like written some React thing somewhere and they had you put like process.env dot something, you didn't really know what that was. That's what this is. You're reading the process from the environment that the build tool that's processing your React is running in. So yeah, that was pretty meta. But yes, your build tools run in Node and they process your front end before the browser sees them. And because they are in Node, they have access to the process, which gives them access to the environment variables. And that's how you're able to embed different environment variables inside of a front end app before it gets deployed to a website. That's it. So yeah, a lot of cool stuff here on the process, and we'll be talking a little more about that later. And then you have these things with modules. And we're going to get to modules because right now modules are in a exciting phase in Node.js, and we're going to be using the latest version of the modules. But I do want to talk about the few here. So we have exports, we have module, and we have require. And these are globals that are going to be used for, I would say, the old module syntax inside of Node.js. And like I said, we're going to talk about it more, but it's nice to know what these are, and we're gonna dive in. But yeah, you're going to see these a lot in Node.js. They get injected into the environment for you. You don't have to worry about importing them or anything like that. They're just there, available, and they're used so you can create your own modules and expose them and share them and deploy them, publish them, whatever you want. So yes, we're going to check those out as well. And then, like I said, there's really just a lot of stuff in the global space that we didn't talk about. I put a link here to the documentation website that goes over all the stuff, because just like the browser, you don't need to know everything that's on the window, just like you don't need to know all of this stuff. You probably won't even use half of it, to be honest, especially if you're using like the new module syntax. You won't even use a lot of this stuff. And you most likely be using packages that you install, which we also are going to cover. So any questions on globals and global objects and variables inside of the Node.js runtime? Now we're going to move on to modules and why I think they're really exciting, and kind of how they got here, and really just how modules are just consuming JavaScript in general and not just Node.js. So let's move on to that. So if you're following along, I'm on the modules page now on the documentation website. And let's kind of think about if we were making a website right now, a JavaScript-based website, how would we share, or how would we include JavaScript in other JavaScript, right? So the obvious answer might be, well, script tags. Well, if you have a script tag, you can put one script tag before another, and as long as there's something on the global or something somewhere, the script tag after the previous one has access to the code inside of there. And that's what we did for a long time before modules came along. So you'll see something like, if you all might be, if you're new to programming, you probably haven't seen this, but if you've been around a long time, you've probably seen something like window.app equals window.app or an object, because in every single file you would put something like this to declare your global app that you have to share across many JavaScript files that you were including. And then we moved on to something like bundling, where we would take all the files and we'd use something like Bowser or Gulp, and we would combine them into one file. So we didn't really need to do this anymore, because everything was combined into a single file at the end of the day, even though they were written in separate files. And then something came along from Node, and that's when we had something called like universal module syntax. And basically what that did was it transformed all of your files to be encapsulated in like their own closure. So you could think of it like this. It pretty much looked like some type of function that was like immediately invoked, and all your code was protected inside of here. So because it's inside of this function, it doesn't leak out to the global space. And at the end of the day, that's basically what a module was. It was this transportable piece of code that was shared across other JavaScript files, and that way they don't conflict with each other. There's no There's no conflicting, there's no global space leaking, nothing like that. And you're able to access different things by like returning it. So if I return something here, I get access to it here. So that's basically what these tools did. So some of the first tools were like Browserify, if you ever heard of that. The Webpack came along and all this crazy stuff. These tools are what's called bundlers. And these bundlers created modules out of your code. They allowed you to use modules. So that's kind of how Node.js got to where it is with modules. Where we are now with Node.js is that we have two different types of modules. So we have the, for lack of better words, the common modules, because it's literally called common.js, but it's also very common to see these modules where you'll see things like exports, require, and literally the word module. You'll see that a lot. So what does that look like? Well, let's make some modules. So if we go back into our file here, and we have a piece of code here, let's call it action. It's a function. Right now, this is just a piece of code. It's just a function. It doesn't really do anything. I'm just logging hello. And I could run this in the browser. I could also run this in Node, and it would work the same. It doesn't do anything. I'm not even calling the function. But the difference is, if I wanted to share this action function with another JavaScript file somewhere else in my application, in the browser, by having this just in the file right now, it's going to be attached to the global, so I can access it via window in the next JavaScript file. But in Node.js, there is no window. And nothing gets attached to the global space by default because all of your files inside of Node.js actually get encapsulated in their own little module, so they don't leak. It's not going to get attached to the window by default. So what you have to do here to be able to expose this piece of code, that way it can be used in another module, another file, is that you have to explicitly say, I want this piece of code to be a module. I want it to be usable somewhere else. I want to export it. So with the common.js syntax, you would see something like this. You would see module.exports equals, and then whatever you wanted to export. So in this case, I want to export the action function. And what this allows me to do is in another file, and I can call it app.js. I can say const action equals require, which is another global. It's a function, and it takes a relative path to another JavaScript file that you want to bring into this JavaScript file. So relative to the app.js, I want to include index. And I don't have to put JS here if it's a JS file. You're going to find out we're probably going to use a different type of file that we do have to put an extension. But if it's for common.js and it's a JS file, you don't have to put the extension. You can just exclude it and it will work. So now inside of here, I'm able to have access to that action function and I can call it. I'm going to save both of these files. I'm going to go over to my Node, my terminal here. I'm going to run Node. Instead of running it against the index.js file, which just creates the function and exports it, I'm actually going to run it against the app.js file, which requires the index file and executes it there. So it's kind of like creating a dependency tree, like a graph almost of dependencies. So I'm going to run it against app. And as you can see, it does execute the action function, which caused the log there. So we were able to share this action function here to this app.js by using this module.exports. So module.exports can pretty much export whatever you want. I could have wrapped this in a function an object if I wanted to. I could have done however I wanted to export this. You might also see, not so common anymore, you'll see some people do like exports.action, which is the equivalent of doing something like module.exports and wrapping it in an object. You don't really see this anymore, so I don't recommend doing that. I recommend just always using module.exports at the bottom of your file somewhere and then exporting the things that you want to be export. And the things that you don't want to be export, you just don't include them here. And that way they're private to this file. Like I said, this is called common.js. And this is what's been the standard for Node.js for quite some time. It's what ships with Node.js. It's the default module syntax for Node.js. But we're going to use the newer one because that's the future of Node.js. It's the future of the browsers. It's the attempt of all the browser people and the Node.js people coming together and we're like, okay, how do we simplify this? How do we make it to where JavaScript is truly universal across environments? How about we start with the modules? How about we get on board with the latest module syntax that's been adopted by the JavaScript ecosystem for quite some time now? And that's going to be called the ES modules or ECMAScript modules. So that's what we're going to be using in this course because we have access to it on version 14. So that's what we're going to do. In fact, I think it was introduced in maybe version 10. Don't quote me on that, but it's been here since version 14. So in order to do that, a couple things we have to do. First, we have to tell Node.js what version of modules that we want. And there's a few ways we can do it. We can be explicit by using the .mjs extension. I know, another file extension, I get it. You know, I was kind of skeptical to .jsx and then .tsx and all this stuff. Like, why can't I just use JS for everything? But yes, MJS, which is module.js, is an extension that you can use. And by doing that, you're going to let Node know that, hey, I'm using ES modules in this file. So use that instead of the .js. Another way you can do it is you can actually go into what's called a package.json, which we will talk about. And you can just say, I want to use type, you know, ECMA, ES modules or whatever in here. And it will still allow you to use the .javascript extension, .js extension, but also opt in for the ES modules. We're going to keep it simple and just be explicit. That way we don't confuse ourselves. We don't, you know, we're not in a place where we're not really sure what modules are being loaded. We'll just use .mjs for all of our files going forward in this course so we know what's being used as far as the modules go. So to get back to our code, so we looked at what this looks like if we were to export using CommonJS. Now let's look at what this will look like if we were to export using ECMAScript modules or ESM. So we still have our function here. We can get rid of this. And instead, we could just put the word export in front of it. Not to be confused with exports, which is CommonJS. Exports is a CommonJS thing that allows you to do exactly this. Exports, and you would get rid of this const, I'm sorry. You would say exports.action. But the word export, without the S, not plural, can be placed before like a variable declaration like this. And it's now going to expose this variable to be able to be imported in another file. So we're going to save that. But this also creates what's called a named export. And the reason it's called a named export is because when you import it over here in this file, I have to import it by the name of the variable that comes after the exports word. So in this case, it was called action because that was the name of the variable from index. And this should still work. So we replace the require function with this import keyword. Because it's a named export, we have to wrap it across, we have to wrap the brackets around it to actually get the name. And then we use the from keyword followed by the relative path to this file to the module that we want to import. So now we'll do that. And then lastly, we need to rename these to MJS. So we have to say MJS, and this has to be MJS. So once we get that, we can save them. We can save it. We can go back to our code. And now I can run node against MJS, and we still get the same result. We get hello. So this is the syntax that we're going to be having going forward. I think this is really helpful because browsers are now adopting ECMAScript modules. You can actually write modules in the browser now, which are really cool without a build tool. So you don't need something like Webpack or Rollup to write JavaScript modules, although you still need those tools if you want to, you know, make a PNG a module or a CSS file a module. For sure, you still need those tools. But if you're just writing JavaScript and you want to have some nice modules, you can just do that natively in the browser now. And now that you can do it in Node, I mean, the code is truly universal. If you wrote JavaScript that didn't really depend on any environment-specific thing, that didn't need a polyfill, you could theoretically just write one code and have it execute everywhere, depending on what the code was. I don't know how useful that would be, but you could totally do it. So yeah, very powerful stuff here. Any questions on these modules? So the question was, if I'm using CommonJS in a project, could I gradually switch over to module.js? The tough answer is it's not as simple as, it's the graph nature of how dependencies work, right? So if I have a MJS file that I just created because we're switching over to ECMA modules, but it's being consumed by a file that was already there that was CommonJS, well, now they have to interact with each other. So what runtime is going to be executed when that happens? So and then you also have like third-party modules or packages that you have to install that may or may not also have those modules, ECMA modules or common JS modules. So it's really hard to determine which one. And it also depends on how you opt into the module.js. If you explicitly go into the package.json and say, I'm using this explicit type, I'm using ECMA modules, then Node.js is going to assume the entire project is that way. Whereas if you only use the MJS file, then you're opting in just for that file. So to give you an example of what that will look like, so let's say we change this back to JS. And then instead of putting export here, what I will do is const action, and I'll go back to module.exports equals action. In fact, I'm gonna keep it the same, so I'll do that. I'll wrap it so it's named. We'll save that, and then we'll go back and run it. And you can see I do get the same result here because I'm entering the app from a MJS file. Here we go. I pointed it to an MJS file, so that's the entry point to the file. And then the MJS file was able to interop with the common JS file, specifically because I knew that imitating a named import in common JS meant that I had to basically export an object with the named properties. Whereas if I did it the other way, this wouldn't work because now MJS would assume that this is like a default export, right? So if I ran this, you can see I would get an error because there's no such thing as action, right? So if I got rid of this and executed it, I get the same thing. So the question is, can you do it? Yes, you can do it, but it's not as simple as just going in and changing everything to MJS. You have to figure out the right module syntax to interop between the different dependencies that you have across files. And depending on how many files you have, that can be very tedious. But there is a path there, it's just not automatic.
Is the MJS extension requirement? I mean, can we like use JS and still make it work, the ES7 modules?
Yes, so if you go into the package.json, there's a field you can add called type. And I believe if you put type module, it'll give you the ECMAScript module, or there's a specific word that you have to put there. And I'll look that up on the break and give you the exact one. I always just use MJS, so I like to be explicit. But yeah, if you don't like the MJS extension, which is kind of gross, yes, you could just opt in the entire project via the package.json and say everything is MJS. That way I can use .js and it still is MJS. Any other questions on modules? So the question is, if I'm like using some other modules, whether it's like NPM or maybe it's internal, something else, and they're using common JS, but I want to use ECMAScript modules, is there going to be conflict? The answer is it depends on how they export those modules. The real answer is it doesn't matter what the conflict is, you should be able to get around it if you can determine on how they actually export their modules. You can go look at the source code, you can see what they're doing. Like, are they doing with common JS, are they doing a default export? Are they doing a named export? Are they doing something like exports dot? When you use ECMA, there's a way around all of this, right? So I showed you that this is a default export if you don't put brackets around it. This is a this is a default import if you don't put brackets around it. And this is a named import if you do put brackets around it. So it really just depends on how that maintainer or the author of that package exported those modules and how you can interop with them. But there is a path for every scenario for you to do that. And then as far as like the ones that ship with Node that we'll talk about, they're already supported by ECMAScript modules, so they're good to go. We don't have to wait for them to update anything. We can just start using them right now without the common JS. All right, so far we've just been talking theoretical stuff, not a lot of hands-on work, but this is just some of the stuff that I really wanted to explain and really want everyone to get the hold of, to get their hand around. That way we can actually start doing some stuff. So the one thing I did want to talk about is some of the internal modules that ships with Node. So it's kind of like the globals that ship with Node. You can think of them as that, but just in the module form, things that we can import that's already given to us without having to install anything. So a few of the favorites you'll see, like file system, which is FS, we're going to use that. Path, which is great for interacting with file paths and transforming and manipulating them, which is extremely helpful. Child process is a really great one. It's used for spawning sub-processes that happen in the background that can communicate with a main process. to do like tedious tasks and CPU intensive tasks, things like that. And then HTTP, which is the foundation of pretty much any server interaction, any internet interaction with Node.js. It has access to the OS level, sockets and connections, and exposes them via a JavaScript API that we can find useful in Node.js. So you could experiment with these if you want, but we're going to go through a lot of them in the next exercises. Let's move on to file system, where we do have a couple exercises that you'll be going through. And this is where you're going to start to see just how strong Node.js is compared to, or how strong an OS level OS level language is compared to like a browser-based language and all the things you get access to. So file system, until Node.js, there really wasn't a great way to access the file system in JavaScript. I'm sure there was, but that it precedes me. By the time I started learning the program, there was Node.js. It was early, but it was around. So I don't know how you would have accessed the file system with JavaScript before Node.js, because JavaScript didn't really run outside of the browser. You can maybe click a button and upload a file if a user selected it, but you couldn't go query someone's file system in the browser. That would be a security risk. So I don't think there was a really good way to access someone's file system or a machine's file system with JavaScript before Node.js. And that's really powerful. But now that Node.js is here, just like any other OS level language, we do get access to the file system. And it's crazy because like when I first started learning about that, I was like, okay, cool. So I can do stuff with a file. I don't have any interesting files on my computer. Well, I don't understand why this is a big deal. But if you think about all the tools that you use, especially anything as far as front-end tooling, it's all just implementation or an abstraction around the file system. And that's how you get like some of those magical workflows, some of those things you can't live without, that it's just like, wow, I'm so glad that did that for me. It cleaned this up, it shortened this, it concatenated that, it joined this. Like those are file system projects, and it's a very powerful tool to have. So what we're going to do is we're going to create a simple templating solution with the file system. We're going to like render some HTML on the page, but not until we process it first, which is very similar to something you would do in Webpack or Babel or any other tool that you use to build your React or whatever front-end language that you have. So feel free to follow along. If you don't want to follow along, I do have all the code that we'll be using. You can copy and paste it directly from the course that I have here. So the first thing is we want to understand the FS module. So I'm going to go back to our project here, and I'm going to I'm just going to delete this stuff out of here. And I'm going to rename this to MJS because, like I said, I'm going to use MJS going forward. If you don't want to use MJS, that's fine. Just know that all my exercises are going to use MJS. I'm going to use the latest modules. If you like CommonJS, if you want to do it, go ahead and do it. I just won't be doing that going forward. So first thing I want to do is understand the file system. So if we import FS from FS, which stands for file system, we get access to this super awesome package here. Let's log this out right quick. Oops, if I can spell console.log, there we go. You can see we get a bunch of stuff here, a bunch of really cool methods. I always like to log stuff. You can see we have things like a pin file sync, access sync, chown, or I don't know how you actually pronounce that, but I always pronounce it like ch own or whatever, but it's it's a file manipulation permission handler thing. Close, copy, exist, all this stuff, and you can see there's always like a sync version of it. That's really interesting, and that really just comes down to like how Node.js works. So if you don't use the sync version of a file system method, it's going to be asynchronous, as in it's going to be set aside in the event loop to be processed on the next tick at some point because it's asynchronous. We're going to continue to accept input throughout this node execution while this thing is being processed in the background, and then Node will notify us via a callback when it's done. So that's the asynchronous version. If you prefer to block the process of Node, as in, hey, do not move forward, do not process any other code, do not accept any other input until this is done, then you would use the sync version. And in most cases, you probably would never use the sync version of anything in Node.js. There are some rare ones where you literally don't want anything to happen, typically like on a server startup or some initialization where you just want everything to be done before the next thing happens because it only happens once, that's when you would do it. But if you're already like executing a server or something like that, you probably don't want one request coming in and blocking your entire server so no one else can actually hit your server because you're trying to upload an image. So yeah, you probably don't want to do that. So you typically will opt for the async methods of these file system methods, which are the ones that don't have the word sync after them. So like I said, there's a lot of interesting ones here. The ones that we're going to be interested in are going to be the read file and the write file. And we are going to use the async ones. And actually, FS was just updated to include, not only do they have the async ones, but they actually gave us this nice path to the FS module that has the async ones that are already wrapped with promises. Because before they were actually, you had to use them with callbacks, which is cool, but promises are better because we can async await them, which is amazing. So we're actually going to import from fs/promises. That way we get the permissified versions of the methods that we want. So now that we got that, the next thing we need to do is let's just get our template file. So we're going to copy this HTML here. Looks like standard HTML, but it's a little different, and I'm going to tell you why. I'm going to make a new file, and I'm going to call it template.html, and I'm just going to paste it in here. So it looks like an HTML file, except if you go look at line 9 and line 10, you can see if you use any type of JavaScript framework, you notice that this looks like some type of interpolation. This looks like what JSX would have in the brackets. This is where you would insert some JavaScript. That's exactly right, because that's exactly what we're about to do. We're about to process this file, and we're going to replace these placeholder variables with actual JavaScript values using Node.js. So very similar to what you would have in JSX or Angular or Vue or Svelte or whatever framework you want. We're going to interpolate these values via Node.js without actually executing it in the browser. So in order to do that, we first need to import that, well, not import, we need to read the file. We need to get the string representation of that HTML file. That way we can find the variables that we want to replace and then replace them. So let's do that. We're going to use the read file method from FS. And I'm just going to go ahead and destructure up here because it's a named import, and I'm going to call it read file like that. So you can do that. And then what I'm going to do is I'm going to read the file. So I'm going to say const file, or let's just call it template, equals, and I'm going to await this because read file is a promise returning function. And in the latest version of Node, we do have access to async await. And I can actually use it on the root like this without having to wrap it in a function, which is also really cool. So I can say await read file. And then read file takes in this case, we're going to pass in 2 arguments. The first one needs to be the absolute path to the file that you want to read. Typically, what you would see in a common JS implementation is you would see something like, you would see someone import path from path, and then they would do something like path.join, and then they would say, I want to join from this directory name over to the template.html. And this would totally work back in common.js. So if we try to execute this now, you'll see it's not going to work. And that's because dir name is not defined. And I know I said that dir name is a global in Node, and it is. I didn't lie to you. It definitely is. But only when you use common.js. You actually don't get access to dir name or file name inside of module.js. I found this out a couple months ago, and it's caused a really big bug in my app. This is why I said, yeah, just switching over to MJS and just thinking it's going to work, it's not really. You got to go in and fix all the stuff on a case-by-case basis because you get stuff like this, like such a big variable that doesn't exist anymore. Like, yeah, you probably have to make some changes. And the change that we're going to make is we're going to use, fortunately for us, read file also takes in a URL object, and we could construct a absolute path using the new URL implementation. So we can say new URL like this. And what this is going to take is 2 arguments. The first one is going to be like basically like the relative, like it's basically going to be like the file name that we want. So it's going to be, what do we want? We want template.html. So we want to go there, but then we want to set the base, which is going to be, we're going to grab something from import. So it's going to be import.meta.url. That's just basically, if we log this, I'll show you what this is. of that. So let's say console.log that, and then we might as well also just, yeah, we'll just log that so you can see what that is. And you can see it's literally the path to this file. It's the absolute path to this file. So that's going to be like the base of where we want to load from. And then we're going to pass in template HTML here. So it's going to be relative to that file. And now when we run this, I'm going to get rid of that log. And I'm going to console.log template. We should see some strange output here probably. Exactly. So we see this thing called a buffer. A buffer is like, it's like the little individual bits of, in this case, a file. It's all the little bits that make up a file. It's not a string, it's an implementation. It's when you want to stream something. And in that case, imagine if this file was a gigabyte. If we read this file in Node.js and loaded it up, we would have to load up a gigabyte in memory. And I don't know if that's something you want to do, especially if you have multiple files. So it's better to just stream them, bit by bit. And that's what a buffer is. It's literally us streaming the file. But this isn't useful if we need to do some processing, unless you want to do a process on a buffer, which I don't. So we need to convert this to a string, and then we can actually look at those variables, those placeholders, and then we can interpolate them with actual values. So that's what we'll do. We got a couple ways to do this. We could just call toString on the template, and that'll actually just convert it to a string because buffers have a toString method, and that works. And you can see we get our HTML back just fine. The other way we can do it is we can just go over to the second argument of read file, and we can pass in the format that we want here. And I'm just going to pass in UTF-8 like this. I mean, sorry, I said format, the encoding that we want to pass in here. And UTF-8 just basically means turn that into a string. And now I don't need the toString, and it still logs the HTML here. So step one, we read the file. We have it loaded up. It's a string now. It's inside of our Node.js file. So it was an HTML file on disk. Now it's a string in memory, and now we can process it. So the next strategy is to figure out how to replace these with some actual values. In a real implementation, you would probably use some other templating language. You would use some regex-based thing. We're going to do it the cheap way, and we're just going to loop over this and do like a string.replace and keep it simple. So first thing is let's actually get the data that we want to swap out with these variables. So let's make an object here, and we'll call it data, and we'll have a title. And we'll call this learn Node.js. That's the title. And then I think the other one was a body. Yep. So then we'll have a body. And the body is, this is the final HTML. So we got our data now. And then the next thing we want to do is we can just loop over this data, and then we can just replace every single instance of the placeholders that match the key inside this, because the keys title and body match with the variables title and body. So we'll just match those using the replace method. We can do say, we can say for consts, let's just say key value of object.entries. If you've never heard of object.entries, when you call object.entries and pass in an object to it, it's basically going to return an array of key value pairs, so tuples. So it'll be an array of arrays, and each array in the big array is going to have a key as its first value and the value as its second value. So in this case, I'm getting the key and the value of each key value pair, and I'm looping over them. So for each one of those, what I want to do is I just want to replace the placeholder. So I'm actually just going to turn this into a let, and I'm going to say template equals template.replace. And if you look at the placeholders, they start with this bracket and they close with this bracket, and then there's a variable name in the middle. So that's what we'll look for. So we'll say replace these brackets followed by the key here, and I want to replace it with the value, and that should be K. So I'm replacing everywhere where there's a bracket, key bracket with the actual value. So I'm going to replace that. I'm updating the template all along, and then I'm just going to log the template to see if it actually worked. So let's do that. And you can see we actually replaced those variables. We replaced where there was a bracket title with learn Node.js, and we replaced the paragraph tag with this is final HTML. Don't worry about these little arrows. That's just my terminal. It prints these arrows out. I think it's the font that I'm using. I don't know. I kind of like it, but no, it doesn't actually look like this. You won't have an arrow here. It's kind of confusing. But yeah, this totally works. So we're almost done. The next thing we need to do is we need to write this file back to the disk because we do want this file to be loaded in the browser. We want to see it. We want it to be served by a server. We're going to deploy this somewhere, right? So we have to write this file back to the disk. Otherwise, what was the point of this? So the thing that we want to do here is we want to import another file called write file, which is pretty much the opposite of read file. So we're going to say await write file like this. And then it pretty much takes the same arguments as read file does. So we're going to say new URL, like, oops, nope, not that, this one. And we're going to pass in the name of the file that we want. In this case, let's just call it index.html, like that. And then imports.meta.url, which, by the way, I think there's a lot of different approaches to solve the fact that we don't have dir name and file name inside of MJS. This is just the way that I've settled on. This is the way that I've seen other libraries and frameworks approach this problem, and it's something that I've just settled on. But if you were to Google, like, well, how do we get around no dir name or file name in MJS files, you will probably find a lot of different solutions. This is the one that has been consistently great for me. So we're going to write the file, and then we want to, as a second argument, pass in the file that we want to write. In this case, it's the template string. So we're going to await, and we're going to write that file, and we should see it pop up here on the left when we execute this code. So let's give it a try. So I'm going to do that. There was no output here because I didn't log anything. Because the output was exactly this index.html being written to the disk. So if I go check it out, you can see we're all good here. And just to check to make sure it's valid HTML, I can open with, not that, I'm going to open, where is it? I'm going to, oh yeah, revealed in Finder. And then I'm going to double click that. And you can see it's a real HTML website. We just processed some HTML similar to what a build tool that you've probably been using for quite some time does. So that's really powerful. Obviously, Webpack is more than this. TypeScript is more than this. Babel is more than this. But at its foundation, at its core, it's reading your files as strings in memory, and it's processing them with complicated plugin systems and architectures and edge case protections and all types of crazy things. But at the end of the day, that's what it's doing to the file system. It's reading it and then it's writing it. Right? If you've ever used Webpack or Babel or TypeScript and you use a CLI and it's like, give us the input file that you want us to start with and give us an output directory to output to, they're writing to it. They're reading from it. That's exactly why they need those arguments. So that's a really powerful feeling. I know when I started reading and writing files, one of the first things that I built was a starter. Like I always built, at the time I built like everything in like Mongo, Express, Angular, and Node, so like the mean stack. So I built a little system that would basically scaffold out the start of how I like to build an app. So it's like a little scaffolding tool. And that was like the first thing that I built with the file system. And I thought that that was really powerful. So any questions on the file system or anything that I just covered? That's a good question. Aha. So await, let's talk about that. Let me go back to the code. So what is await and what is it doing here? Good question. So we have to understand how asynchronous code works in JavaScript. So I'm not going to go deep into that because there are so many amazing courses on front-end masters that can talk about that much better than I can in this course. But the short answer is read file and write file are asynchronous tasks, as in they actually execute in the background. So what I'm saying is, we'll get to await, but let's say I just remove this await. What's actually going to happen is when JavaScript looks at this file on line 3, or this line on line 3, it's going to initiate this function, but it's not going to wait around for it to be finished. It's going to task it to happen later on in the background, and then it's going to continue to move on. Now that's going to cause problems because, as you can see on line 11, I expect there to be something called template available. But if I don't wait for it, this would actually just be undefined, and my code's not going to behave the way that I intended it to. So there are different ways to get around that in Node.js or just JavaScript in general. The standard way is to use a callback. So if we didn't use fs promises and we decided just to use fs, I would actually pass in a callback here like this. I would say like error result. And this callback would be called when the read file was done. And then I would have to move all of this code into this callback because I don't want that code to be executed until a read file is done. And as you can see, that starts to get sloppy. You have callbacks inside of callbacks inside of callbacks. So we solved that with something called promises. So now if you have a promise, what you can do instead of doing the callback is you can actually just do something called .then right after this, which kind of looks like a callback, but it's not. And then I would just move everything inside of this .then, which it doesn't expand out this way. It stays flat, but it's still not the best looking way. It still doesn't read top from bottom. Like when we look at code, we read it from top to bottom. And when it stops behaving that way, it can get very confusing. And .then keeps it closer from top to bottom, but it's still not quite there. You still have these callbacks inside the .then. So we built another abstraction on top of that, and that's called async await. So now if you have a function that does return a promise, which these functions do, they do return promises, you could prefix the promise with a keyword called await, which will stop JavaScript from moving on until this asynchronous piece of code was done. It is the equivalent of moving all of the code into the callback like I just showed you. Instead, visually, we don't have to do that, and we could feel confident that this code won't execute until this is done or errored out.
Yeah, do we not have to provide the async keyword, or is it implicit?
Got you. Yeah, so that is a new feature in the latest version of Node. You do not have to apply the async keyword anymore inside of a function. You're good. You can use it flat globally now. It's pretty amazing. Yeah, if it's top level like I have here, you don't need the async because there's nowhere to add it. But if you do have a function, like for instance, if I have a function called, get users like this, oops, go away. I can't just say awaits something like this. I can't say awaits db.get user, not debugger, db.get users. Like I can't do that, right? That's not going to happen because you have to put async in front of this, like that. So yeah, it's only for top level, which is something relatively new and extremely powerful. But yeah, if you're inside of a function, you do have to put the async keyword before your parameters on that function. So I have just been writing Node.js code, JavaScript code, pretty irresponsibly just now. I mean, if we just look at the code that I wrote, at any point, this code could throw an error. Like for instance, if I decided to not put HTML and we tried to run this, you can see that I get an error. Maybe that is exactly what I want in this case. I do want it to error out if I didn't provide proper arguments to the methods and stuff. But in some cases, you probably don't want your whole app to crash and burn because there was a known error that you probably anticipated and it doesn't affect things. Something like, imagine if you had an API that needed to be, if you wanted to make a request to the API, you had to authenticate your request, as in you had to pass like a token or some type of API key or something like that. Now imagine your database throwing an error if that was an invalid token or if that user wasn't found. And if that error did what this just did, as in it crashed my entire app, that means if someone doesn't provide the correct credentials to your server, all your users will be punished. Your whole app will crash simply because someone just fat-fingered an API token or they're trying to hack you or whatever. So yeah, you don't want to give them that power. So sometimes you don't want the whole app to crash because there was an error. So you need some type of way of listening for errors, catching errors, handling errors, and Node.js has some pretty good ways to do that. So I want to walk through how you can do that with Node.js because I think it is very important to understand that. So that's what we'll do. So the first thing that I wanted to talk about when it comes to errors is really just understanding the process of Node.js, and what that is and how that runs. So when an exception is thrown in Node.js or an error, the current process will exit with a code of 1. In fact, we might see that here. Let's see. Does it say exit 1 somewhere? No, it doesn't. But this actually errored out, an exception was thrown, and the process exited literally with 1. So let's go into Node. I'm going to type in process dot exit, and I'm gonna say 1. And what this really does is when you exit with a number of 1, it's telling Node that it exited because something bad happened, it broke. If I exit with like a 0 or a non-1, that means like, oh yeah, it was successful. Nothing happened, we're just done. And that's very useful for when you're like looking at logs or trying to debug something to see why your code stopped running, what caused it, was it an error or did it just complete its job and we just wrote bad code, like what was it? And that's what that's useful for. It's also useful for like piping that information into another process or a log file or something like that. So that's how the process is going to work. And that's going to happen automatically if you don't handle your errors. As you saw, when I threw that error, it immediately crashed. Nothing else was executed. It broke. I mean, kind of similar to what you would get in the browser, I would imagine. If you threw an error in here, you know, it would also break, but it will continue to move forward depending on how you wrote your code, how you caught it, different things like that. So we kind of want to do the same thing here. Whereas except like on the browser, if a JavaScript error happened and it didn't catch, your whole screen's not going to go blank, I guess, unless that's what it was trying to do in the first place. But chances are you'll just have these errors in your console, and at least people can still see your website and they can, you know, still scroll through it maybe, depending on what the interaction is. But in Node.js, if your whole app crashes, it crashes. There's nothing left. There's no interaction with it. There's nothing other than the fact that it should be on. There's no UI. So you don't get the benefit of like, well, I guess people could still at least use it until we fix it. Nope, it's pretty much done. So you want to get around that. Let's look at these docs here. Here we go. So that's how the process exiting works. Now, I showed you that not because you should be using it. You should almost never be using process.exit ever. And I would say the biggest reason why you would not want to do that is because you just don't get the chance to catch the error. If you're literally exiting every single time, then you're not giving yourself the chance to, well, what type of error is it? Well, I only want to exit if it's this, or I only want to do that. You don't have to do it. Node.js is going to exit for you. You just throw an exception. That's really all you have to do, is you need to be responsible for what exceptions you want to throw and, you know, what exceptions you don't want to throw. So that's the only responsibility that you need to have when it comes to errors in Node.js. So let's talk about how we used to handle errors in Node.js, and maybe now we probably still do depending on your code, and then we'll kind of walk through like the different ways to do it with different scenarios. So the first one is async errors. So let's go back to our file here. I'm going to stay in here. Well, actually, I'm going to make a new file. We'll call this like errors.mjs. And I'm going to import, let's import read file again. But I'm not going to do the promise one. I'm going to read file from fs, not from promise. And I'm going to say read file. And I'm going to do the same thing I had before. So new URL. In this case, I will just get a new file this time. I'm going to read the app.mjs just to really toss it up, and imports.meta.url. I'm going to do that. And then I'm going to do the UTF-8 here for the encoding to give us a string. And then I'm going to pass a callback. And here's the error handling thing. So as you can see here, as I hover over this callback, you can see that it's saying here are the two arguments that you might possibly get. You could possibly get an error as the first argument, and then you could get the result, the data, as the second argument. And this is how we handled errors in the early days of Node. And like I said, we still do because it's still very popular. If you're not using promises or async await, you would use callbacks. And if you are using callbacks for asynchronous code, typically the pattern is this. You have an error that is either going to be there or it's going to be null. And then you will have the result or the data, which will be there if there is no error or if there is data. And that's how you would handle it. So then in this callback, you would say something like, well, if error, I want to do something, right? So this is where you handle the error. And when I mean by handle, I mean you decide on what you want to do with the error. Like, is this read file method so crucial to your app that if it doesn't work, you need to stop? Or is there some type of fallback that you can do? Or is this not that important or whatever? Do you need to report this error to some management app that you're paying for that like logs your errors that you can go attach them to GitHub later and look at them, something like Sentry or something like that? Then this is where you would do that. Otherwise, I don't have an error, so I got my data, so I'm doing whatever I want with my data here, right? So let's try to trigger this to see what happens. So I'm going to say error. I'm going to console.log the error here, or actually I'm going to say console.error the error, which doesn't really do anything different visually, but we're just going to be semantics here. So now I'm going to actually make this error out by changing the file name. And then we're going to run node against errors.mjs. And as you can see, we do get an error, no such file name or directory, because that's not a real thing. And I'm logging it because that's literally what's happening. We have an error. But if I didn't want this to crash, what I could do, hold on, there we go. Yeah, if I didn't want this to crash, I would, first of all, it's not crashing right now, it's just logging it. You can see that it's not actually crashing. It's just logging the error, but it looks like it's crashing. So if I wanted to do something with this, like let's say maybe I did want this to crash because this is a crucial piece of code, then I would just rethrow the error. So I'm like, oh, okay, cool. Actually, yeah, this is the code. This is the error that if it happens, I want it to crash, so cool. Yeah, throw it. And now you can see that the error was thrown. The code won't go on. Nothing's going to be completed. We are good to go. So this is why it's really important to be able to use the things that's built into Node to handle the errors versus just sticking with a process.exit on everything, which is what I've seen before, but you just don't get the opportunity to do anything. And then obviously there was no error. We would do some stuff down here. So this is how you would handle errors, async errors that used callbacks. Now, if we wanted to handle an error that was promise-based, it's pretty similar, to be honest. And it depends if you want to use promises or async awaits, but it looks something like this. So if I'm going to change this to fs promises, and we don't use the callback anymore because we got a promise. So we'll do that, and now we can get the results. And we can await this like this. So now if we have this and we run it, it's going to error out and it's going to break. And you can see that we do get this error here. But if we wanted to catch this error, because we don't know what type of error it's going to be, maybe we want to report it, we would have to wrap this in a try catch if we're going to do await. So we'd say try and then catch. Just like you would on synchronous code, because await is supposed to feel synchronous. So we treat it like synchronous code, and this is how you would catch an error for something synchronous. You would wrap it in a try catch. And now the error is going to bubble up to this catch right here without breaking the code. So just to show you, I'll say console.log error, E, and then you can see it will still move on to this next line, which means it didn't break. So you can see we did catch the error, we logged it, and then we moved on to the next line because the code continued to move on because we caught the error, we just happened to log it. And then just like before, if we was like, no, actually this error is important, we do want to throw this one, we can throw it. It won't move on to the next line, and the whole app actually crashed. So you get that choice, you get that power of determining on how you want to do it. With promises, it's pretty much the same thing. You just don't use await. I mean, it's pretty much the same thing as the callbacks, not the try catch. You don't use the await, and you just use the native like dot catch inside of a promise, which gives you an error like this. And then now you're doing the exact same thing you did with the callbacks. If it's this type of error, throw it. If it's not, don't do anything. It's already handled for you. So that's how you would do that in a promise-based workflow with error handling. So that is how you would handle the errors that you had control over, as if you were writing the code and you knew where errors were going to potentially happen. But let's say you did not have control of the code, as in you were using some type of library that you downloaded that's internal somewhere, and you just don't have the ability to catch it somehow, or maybe you don't want to. I don't know. Maybe there's a scenario where you don't know what's going on. You can't really get this error. Then you do have this catch-all implementation, which is going to be called process.on uncaught exceptions. So let's talk about that. So if you have an async error like this one, so I'm going to wait this. I'm not going to try catch it. But what I am going to do is, before I actually call this function, which will cause the error, I'm going to register a process. Not that. Process. Okay, I don't know why it's doing that. Don't autocomplete. Thank you. Sometimes the autocomplete is just like way too aggressively helpful. I don't even know what that was. I never even heard of that variable that it was kind of autocomplete. So process.on uncaught exception. Is that what it's called? Let me see. I'm just gonna copy it. Yeah, uncaught exception. There we go. I don't know why I couldn't spell there. Okay, process that on uncaught exception, and then we get a callback here. And you can see that we'll have some type of error. Let's log that. And we'll run the code. And you can see that, and just to show you that we're continuing moving on, let's see what happens. Let's see what happens if we move on here. So what's happening here is that the error was thrown, and there was nothing we can do about it, but it did not actually get caught because we didn't see line 9 move forward. It actually, we were able to see what error was thrown, but it's too late. The error was already thrown. We can't catch it. And this is why I said you don't want to use the process.exit and stuff, because you don't get the chance to catch the error. If this was an optional error that a user did or something, there's nothing I can do about it if I'm just registering for like on-caught exception or process.exit. You don't want to do this. So you do want to do the try catch. You do want to do the dot catch. You do want to do the callback error data pattern, and only save this for like, okay, someone didn't catch this error. What is going on? Maybe we need to log this somewhere. But by the time you get here, you can't catch it. It's already been thrown. That's why it's called uncaught exception. No one caught it. So this is just for helping you figure out what happened, why your thing crashed, and maybe do some cleanup logic, some things here like, oh, it's about to crash. Do this thing right quick. Do this right quick. You're able to do that. And I'm pretty sure you can't do async stuff in here. So if you want to, like, oh, I need to clean up the database before this server shuts down because an error was thrown, you can't do it. You can only really do synchronous things because the way the event loop works, you're pretty much on the last tick of the event loop before this application bottoms out. It's not gonna restart. It's not gonna queue up any more tasks for you because it's scheduled to be shut down. So you can't do anything that requires anything to be queued up. So anything asynchronous can't happen here. So you got to keep it moving. So yeah, this is just for like, if you're just lost and you can't figure out why something's happening, you would do this at the top of your app somewhere. Any questions on errors and error handling in Node.js? Good question. How are we able to use the process without importing it? Well, that's because process is an actual global variable inside of Node.js. It's one of the globals that I talked about here. If you go to the global slide, I think I talked about process here. Yep. So process is injected, it's given to you for free. It's part of the global space, just like the keyword import is there, just like the keyword module is there. Process is one of those things that you get for free. I don't know how Node determines what should be a internal module that you have to import versus what should be a global that's just there. But they decided that process was going to be a global that you don't have to import, whereas FS is going to be something that you do have to import. I think there's like a level of like importance. Process is very important. I would imagine there's really not too many apps you can use without interacting with the process at some point. So I think they felt that was so important that it should have been a global and not something that should be imported. Whereas FS, yeah, you could probably make a bunch of apps without ever using FS. So we'll make that a import, a module that you have to import. I'm guessing. I don't know the thought behind that.
What's the difference between an error and an exception?
The only difference is that an error can cause an exception. So if you have an error, as in some discrepancy, some miscommunication in your app, if you throw the error, that raises an exception. So an error alone is just an object. It's just an object about some metadata, like here's a line of code, here's where it broke, here's what happened, the type of error. Nothing happens until you actually throw that error, which causes an exception built into JavaScript. That's just how JavaScript executes. So yeah, you can think of an exception as like an error that was like escalated to the highest level. It's like getting on customer service and like speaking to a manager. That's an exception. Whereas the error is you just calling and complaining in the first place. So that's the difference. This is going to come in handy. So I want you to remember the error stuff. And the reason I wanted to talk about this one is because this one really messed me up for a long time, especially async errors. I just did not understand it. I went back and looked at some of the code that I wrote in like 2014 and I was just laughing. Like I wasn't handling anything. I wasn't doing anything. Like if anyone just mistyped one word, my whole app would crash. And I didn't even know it back then. So yeah, pay attention to the errors. Luckily for you, most of the frameworks and abstractions that you'll use will have really nice built-in error support, hooks that you can tie into that makes it so easy to format things and do stuff. But yeah, take advantage of that. watch your errors, and be cautious. The question was, is await blocking the thread? And if so, why are we using it versus just using synchronous? That's a really great question. And the fact that you asked that question tells me that await is doing its job. It gives you the illusion that it's blocking the thread. That's the whole point. The whole point is that it should feel like synchronous code. It should feel like it is blocking and nothing else is happening. But that's not actually what's happening. If you were to look at what await gets transpiled into, it actually gets turned into what's called a generator, which is like, you can think of a generator as like it's like an async for loop, basically. So it's the equivalent as if you basically put the code that comes after the async await inside of a .then callback or inside of a callback of an asynchronous function. It's the same thing functionally, but visually it looks like it's blocking because async await was really only created to solve a visual problem. Promises, or in fact callbacks, already solved the functional problem of like, well, I want this code to run after some asynchronous thing. Callbacks solved that years ago. Promises was an attempt to make it visually better instead of having all these nested callbacks. Thanks to Node and databases, we had these, you never would see this pattern on the front end. You would never see, 20 nested callbacks on the front end that were all asynchronous because you didn't make 20 API calls on the front end and 20 event handler calls nested in each other. It wasn't until Node came out where people started interacting with other APIs and databases where we saw this crazy async pattern. So promises were invented to keep them somewhat flat. You can do a .then followed by another .then and another catch, and it was somewhat flat, just one level deep. But it still wasn't top to bottom because you can put something after the .then and that would still execute first before the previous .then. So it was still not really solving that problem for people understanding to read from top to bottom like other languages that are blocking that have threads, like Python or something like that. So async await was created to solve the visual problem of, okay, you're just gonna read it from top to bottom, but it's still gonna work like callbacks, okay? It's still gonna work in the back, in the event loop. It's just that this code has been added to the callback. So yes, it does look that way, but no, it is not blocking.
So along with that, if you're awaiting something, can you continue to process other things?
No, because if you put await in front of something, the next line won't execute until read file comes back with a result or throws an error. It won't even be read. It won't even be seen because it's the equivalent of putting it in a callback. It just won't happen. So no, you cannot continue to process something. That defeats the purpose of the await. If you want to continue processing something while something else is happening in the background, then you won't use async await. You would use a callback or you use .then. And then now you can have code that reads from top to bottom, but then jumps back up when it's done, which is fine. Like it's not hard to follow that code until it gets crazy. But async await tries to get rid of that as much as possible. And me personally, I use async await for everything because I think it's amazing. Like it really, I write code in a lot of languages, and this just makes it feel like everything else, in my opinion. But it also keeps JavaScript, asynchronous, event loop based. The features that I like, it still has that part, but it makes it look like everything else. So it's less confusing for me. So we last left off talking about error handling in Node.js and the different ways that you can go about doing that. I emphasize just how important that is when it comes to deciding on how and when you shut down your app, depending on what errors. And that's going to be more obvious when you get into building things like servers, especially servers and other types of applications that require user input, because sometimes their input could cause an error, but not a show-stopping error, a game-stopping error that should crash your application. So that's why that was important. So this is probably the best feature of Node.js, and it's the community. Right? Node.js is a thriving community full of individuals who contribute and build and create like some of the most amazing things you can use inside of your JavaScript applications. So if you've been doing front-end development, you've probably heard of React or any other framework like that, or a library like Lodash or something like that. All of those are packages that you can consume inside your application. And even though those are front-end packages, they are still considered Node packages. They're still, because you're actually installing them with Node. they're being built with Node, things like that. They're being consumed by Node, even though the end target is probably the browser. But how they got there was through Node, the mechanism of how they got into your application. So you could think of packages as like a collection of modules or even just one module that is available to you, like it's shared, whether it's on a registry somewhere, whether it's locally on your computer. It's just a bundle of modules or some type of logic that's able for you, that you are able to use. And you didn't write it. It's its own application, it's its own entity, and you're bringing it in. Almost like the internal modules found in Node.js, like the FS file system that we use. We talk about path, different things like that. You can think of those as packages built internally into Node.js. So when it comes to Node, there is a very special tool that we use to manage those packages because, like I said, there's hundreds, thousands, millions of packages out there, and you need to have some type of experience around that to be able to get the packages you want, find them, make sure that they're right, different versions, different stuff like that. So there's something out there that's called Node Package Manager, or NPM for short. NPM actually is already installed on your machine if you have Node. You didn't have to do anything. It comes bundled with Node, although they're two separate things. So NPM is amazing because it allows us to search, install, build all different types of packages in our application much faster. A lot of OS level languages like Python and Ruby, they also have package managers. Python has like pip, Ruby has like Ruby gems, different things like that. This is just Node's version of that. It's called NPM. There's also other package managers out there as well. You might have heard of like Yarn and probably some others that are out there as well. They pretty much all do the same thing, and they're interchangeable with small features here and there. Going forward, we're just going to use NPM for everything because that's the standard, and up to the point that it is now, it's actually pretty good. So we're just going to use NPM. So what we're going to do is we're going to create our first package, and we're going to learn how to consume other packages. So let's do that. So what we're going to do is, first, we have to turn an ordinary Node code base, an ordinary Node app, into a package. And you've probably seen this and done this a bunch of times, but you probably didn't know what it was for and what it was, the meaning behind it. So I'm going to walk you through it. We need to create a package JSON file, and we're going to use NPM to do that for us. So let's head over to our app here. I already had all this stuff. I'm just going to make a new folder and toss all this stuff in there, and I'm going to call it like intro. And I'm just going to say, let me just grab all of these things, drag them all, I guess. I don't know. I'm just going to put all these in the intro folder. Then I'm going to make a new folder here, and outside of this folder, I'm going to make a new folder. And I'm going to call this package, like that. It's important that we make a new folder here, or you can treat your root folder as the folder that you're going to work on. Regardless, we need a folder to put something in. So if you're following along, just make a folder. And then what you need to do is you need to make sure that you change directories into that folder from your terminal. So I'm going to change directories into package, like that. Now I'm inside of package. And what we're going to do now is we're going to initialize a package JSON file, which is basically telling Node that, hey, this is a package. So we're going to say npm init. And once you run that, you're going to be inside of this interactive prompt that's going to be asking you questions. You can just hit enter repeatedly to go through the defaults, but we're going to walk through so we kind of understand what these field names are and why some of them are important and why some of them aren't. So the first one it's asking you is like, what's the name of this package? This is important because if you ever decide to publish this package to a registry, and we'll talk about that, this name has to be unique. That way, when someone npm installs your package name, it's guaranteed to be that package and not something else. We don't want any conflicts on names, so there's no miscommunication or misunderstanding about which package you're actually getting. So if you are going to publish it, it has to be a unique name, and as you would imagine, like anything else that's unique, like URLs, all the good names are already taken. So you can namespace these if you pay for like a private account. You can namespace them, or maybe it's free now. I don't remember. But if you get an account, you can namespace them, and that's a whole nother thing. But yeah, you do want to give it a name. I'm just going to call mine app, because we're probably not going to publish this. It's totally fine. And that's only if you publish it. If you're going to keep it locally, you don't have to give it a unique name. In fact, this name doesn't even really matter. So I'm just going to say app. I'm going to keep it on version 1.0.0. If you've never seen this version syntax before, this version syntax is called semantic versioning, or SymVer for short. And basically, it's just a 3-digit system that like tells you what the major version is, what the minor version is, and what the patch version is. Whereas major is every time you see a bump in the major version, that's a really big change. It's probably going to break your app if you upgrade to that. A minor is like, oh, we fixed some bugs. You know, everything pretty much works the same. We're just fixing some stuff behind the scenes, or maybe we added something new that doesn't break anything. And then a patch is just like, yeah, we like changed some documentation, or we changed how this thing works, but you use it exactly the same. So that's symver. So that's why you'll see those 3 digits. So I'm just gonna keep that at 1.0. The description is exactly what it sounds like. Whatever you put here is gonna show up on like a registry's website, like NPM website, or if it's hosted on GitHub, or if it's hosted on Yarn, or whatever registry, some internal registry, the description field is here so it can be read and presented that way. And then the entry point is, if I were to require or import your module, what file would I be importing? What is that file? That's the entry point. The entry point is what is the door into your module when someone imports it. So that's it. I'm just going to default to that. And then the test command is what command should we run when someone tries to test this thing? And I'm just going to keep that blank for now. The Git repository is exactly what it sounds like. Where on Git is this hosted, if anywhere? And keywords we don't need. Author, don't really care about right now. And the license is okay. So as you can see, I went through all of that, and it generated this JSON object here, and it added it to a file called package.json. So I'm going to say yes, that's okay. And then I'm going to go check it out. So you can see I have a package.json here, and all the stuff that I filled out is right here, ready, good to go. So now we are officially a package. We are an NPM package right now, and now we can use NPM and we can do all different types of things. So let's go back over to our website here. We talked about some of these, like the name and the version. We talked about the main here. One thing we didn't talk about was scripts. So scripts is really powerful. We're going to use them here in a little bit, but they basically just allow you to teach NPM different commands to run, like little shortcuts that you can do. Test was one of them. It asks us what was the test command. That's a test script, but you can make a script any name and you can make it do whatever you want. So they can be pretty powerful. Next, we're going to use NPM to actually install some stuff and see how that works. And I just want to walk you through that process. So some of the commands that we want to use are going to be npm install. So if we go look at npm install, if I type in npm install help, you can see that it pretty much says you can run npm install with no args, and it's going to try to install everything in the directory. We'll talk about that. Or you can run npm install with like a name, and that name could be, like I said, a scoped thing if you have a paid account or something like that, or an alias to something, a folder if it's local, even a git URL, a username / project. Like you could pretty much install anything at this point with npm. It's pretty impressive. Then there's just a couple flags here that we're going to talk about and how that works. So npm install is one. It's exactly what it sounds like. It installs packages. And then we got npm tests, which is the test script. And then we got npm uninstall, which is the opposite of install. It uninstalls things. So those are the 3 main commands that you'll probably be using on npm, and until you run into like caching problems and deduping and versions all messed up, then you got to start looking into all these other crazy npm commands. But we're not going to do that today. We're just going to focus on these 3. So it is going to be just fine. So what I want to do is, before we get into like installing things and using them, I want to show you how to find them in the first place. And this is something that I think is actually a really important skill. Like I'm in the boat of a good developer is someone that knows how to use their resources. They know where to look, they know when to look, and they know how to try things to determine the value really quickly. Like they can look at something and determine if this thing is valuable or not without wasting a lot of time. And I think that's a very important skill to have that no one really talks about and you don't really train for. And it's something that you develop just along the way. But if you don't have a lot of interaction with this, if you're not responsible for installing things at your company, you don't get this interaction. You don't get to build these reps. So I really pride myself being able to like go on NPM and see what's good and what's not good and try it out and move on with my day and try something else out. So I want to show you how I do that. So NPM registry is, you can think of it as like a database of published NPM packages, and like that's basically it. So we're going to go look at the NPM registry, npmjs.com. It has a search bar up top, and you can type in pretty much whatever you want. So let's say you're working on an API and you need to get a database. So if I type in database, there's literally something called database. It's an exact match. It's probably not what you were looking for, but there is something called database. And as you can imagine, there are over 500 pages worth of hits that contain the word database. So it would take you a very long time to go through and figure out what's what. So you probably want to come out with a bigger question. So like maybe not that type of database, but maybe you're looking for a specific database. So maybe you'll type in Mongo database and trying to see what plugins they have there. Okay, a little less, not so many pages. We're getting closer. So let's say we check this out. We look at, oh, hey, I'm using Express. Let's check out Mongo. So when you click on the package, you'll notice a couple things. One, you'll see the README here. This is the same README that's probably on the GitHub repository. It's the README.md that's on the root. You can also see how many packages this package has, because packages can have packages, and that's where it gets pretty crazy. You can see what is using this as a package, so what's dependent on this, and how many versions it has, and when they were released, which is also really cool because that tells you how active or inactive this project is. You can also see when it was last published, which is a good sign. So what I like to do is when I come here, I try to find the thing that I like. I try to see that, make sure it was relatively updated. Like if it says 2 years ago, unless there's literally nothing else, I probably won't use it. If it was updated 2 years ago, if there's other things, this is probably the last thing I'll try. I'll go try something a little more recent, the last couple months or something like that, the latest. You can also go check out the GitHub to see the source code, to see the open issues, open pull requests. These are all good signs. If I look at an issue and I see that, okay, this issue was open 15 days ago, this is a pretty active project. So, this is a very good sign that you have some support here if you need it. Because at the end of the day, this is created by some developer just like you, some engineer on their free time who just happened to do this. They probably have a full-time job and a family, and they're not getting paid to do this. So but you also need this to work. So you can't demand that they fix it. You're not a paying customer, but at the same time, you do want it to work. So you got to work with them. It's open source. You can create issues, you can fix them yourself, you can make pull requests, different things like that. But at the end of the day, you do want a project that's at least maintained and has some type of maintainer behind it that's keeping it up to date and things like that. So that's what I would do once I find the thing that I want, and then I would install it. So one I know that it's really good is Lodash. If we go here, we can see Lodash is pretty good. Updated 4 months ago, which is honestly pretty crazy because I don't know what else they're adding to this, but yeah, Lodash is one. They even have the copy and paste commands that you can use here, which is really cool. And that's what we are going to do. So that's pretty much my process of how I figure out what I want. So if I'm going to use something like Lodash, this is how I would do it. I would go into my terminal. I would type in npm install. Then I would type in the name of the package that I want, which is Lodash. And in fact, actually, before we install it, you can do this. You can say npm info Lodash. And it pretty much gives you the same stuff that we just saw on the website. So that way you can see it here in your terminal. You can see keywords, GitHub URLs, maintainers, when it was published last, all different types of stuff. You can do that. I think there's also like an npm search. You can search through here in your terminal too, but nah, I don't know about that. I don't think I would do that. So yeah, now let's go on to install it. So I'm gonna say npm install. I'm gonna say Lodash. But instead of hitting enter, I'm actually gonna pass a flag. This is a flag, by the way. When you do dash dash like that, that's a flag. And you can think of flags as like options that we pass into a command line tool, which you will be making soon, so you'll know exactly what that means when you make it. But we're gonna pass one that says save, and I'm gonna hit enter. So you can see it went and downloaded it. You get a couple things here. You get some notices, you get some warnings. You can ignore the warnings, you can ignore all of this. This is not for you, it's not to mean anything. Sometimes you'll see errors here and you should maybe look for those. Even sometimes it's not that big of a deal. And then you can see we added one package, Lodash version 4.17.21. So major version 4, minor version 17, patch 21. We added one package from 2 contributors, and that audited one package in half a second. 0 vulnerabilities. So they're really checking for everything. Now if we go back to our code, we have 2 new files now. Well, 1 new file in 1 folder. We have a package lock JSON, and we'll talk about that. And then we have node modules. So this is what I want to start with. Node modules. If you open it up, there is a lot of code in here. Well, what is all of this? Why is all this code in here? How did it get here? I didn't ask for any of this. I just installed Lodash, but What is all of this? Well, these are probably the dependencies on which Lodash depends on, because packages have packages. And I know Lodash recently kind of like broke everything up to be their own individual packages. And I would imagine if you install Lodash by itself, it just pulls in all the individual packages and like bundles them for you. So these are all the dependencies that Lodash actually needs. So that's what's inside of here. And if you install something else that has a similar dependency and there's a conflict, NPM tries to resolve that conflict by like going to like the most common version, and it keeps everything flat and not nested and different things like that. So there's a lot of work going on behind the scenes of NPM to make sure that your modules are like conflict free, you have the right versions, you don't have duplicates, different things like that. And it's all inside of this node modules folder. So you should never touch this folder. You should never be coming in here and adding files and trying different things and stuff like that, because it's just going to get wiped out every time someone runs npm install. This folder is also not meant to be checked into source control. So what you would do is you would make a git ignore dot git ignore, and you'd add node modules to that, because let's just be honest, you don't want to send up a bunch. Let me put that there. You don't want to send up a bunch of third-party code that's not yours into your source control to be processed by whatever CI that you have, or code reviewed by someone. Can you imagine a pull request of all of these files when all you did was install Lodash and use it on one line, but now your pull request has all of these in green? That would be crazy, right? So you don't check this in the source control. So how does someone, like someone on your team or another machine on the CI somewhere, how do they know what modules that this app needs if you don't check it in? Like, how do they know to get that code? Well, that's where that save flag came in. So when we did the -- save, what we actually did was we told npm to save the name of these dependencies into the dependencies object in the package.json with the current version. So when anyone else pulls this down from GitHub, minus the node modules folder, all they would have to do is just run npm install with no arguments, and that's going to look at the package.json to determine what packages need to be installed, and then they will be installed there. Now, to make sure that they install the exact same versions as that you have, or what's supposed to be there, the package.lock, the package lock JSON was introduced. This does exactly what it sounds like. It locks the packages into the exact resolved the exact resolved version that npm decided was correct. So if there's any like conflicts between versions, if there's any duplicates that were resolved, whatever they resolve to will be saved in this package lock JSON, so that everyone on your team guaranteed to have the exact same dependencies with the exact same versions, and there should be no discrepancies between that. So that's where that comes in. So all of these work together to do that. That was a lot. Any questions on packages and npm before we move on? So yeah, the question was, how do we know if the code is malicious? Well, I'm gonna say this: you don't. You literally don't know. There's no way of knowing. So I'll tell you how we've gotten to this point where like that's been, even though you don't know, how that's been almost entirely avoided. It's because of the community. So typically, one, just because you make a package, that doesn't mean a lot of people are going to install it. So that's why you should probably only install packages that, like I said, are being used by a bunch of people that kind of vets the fact that, hey, it's not malicious, it's on GitHub, you can see the code, people are making issues, there's multiple contributors, it's being sponsored by big names, so that's a good sign. So don't just install something that no one else, didn't install. And if you have to, go on GitHub and look at the source code. If you cannot find the source code, you can install it, just don't run it, and then go look at the code in the node modules folder, don't run it, and just see what it's doing. You can see what it's doing and kind of figure out for yourself. But at that point, it's probably not worth it. You should just go find a better alternative, or just whatever you're trying to install, just make it yourself. Because if you got to go dig in the node modules folder to see why this thing or how this thing is safe or not, it's probably not worth it, in my opinion. But yeah, it's mostly the power of the people that prevents that from happening. Whereas like I can't think of like one big event where there was something malicious, but I can think of plenty of events where like someone changed something in the code and it broke everything downstream. Like someone changed this parentheses to this, and now every package that depends on this is broken. That has happened a lot. Yeah, so the question is, what's the difference between npm and yarn? and why do people choose one over the other? So Yarn was created by Facebook some time ago because at the current time when it was created, NPM was in this state of just basically not being updated. It was really slow. It didn't have this feature of like deduping. It didn't have a package lock JSON at the time. So there was just so many issues around NPM, and it was the only thing around, so people just dealt with it. I guess the folks at Facebook got tired of it, so they made Yarn, which was exactly like NPM, but it like did caching, and it like resolved versions, it deduped things, it stored them flat. And so people started using Yarn because of that, because it was literally the same thing but better. It was exactly what they wanted from NPM. And then soon after, because of just how competition works, NPM was like, well, we're gonna do that too. So now NPM just does the same thing as well, just as good as Yarn, if not better. And so now it's like, well, whatever one you want to use is probably the one that you're gonna use, because they all kind of really do the same thing. And as far as like where they get the packages from, that's a sweet thing about these managers. Either Yarn or NPM allows you to basically point to whatever registry you want. NPM is gonna default to the NPM registry, and I wanna say Yarn defaults to the Yarn or the NPM registry as well. I would have to check on that depending on what version of Yarn you're using. But you can point to whatever registry you want. I mean, even GitHub, who owns NPM now, well, I guess Microsoft owns them now because Microsoft owns GitHub. They have their own registry as well. So you could point to that and download from a GitHub registry. It really just, as long as the registry follows the way that the package manager is expecting to interact with it, or if someone makes a plugin for it, then the package manager doesn't really know what it's talking to or who it's talking to. And you can pretty much pull from anywhere. Is the package folder name important? No, I just called mine package because I couldn't think of a better name. You can name this whatever you want. It has whatever you name this folder has nothing to do with anything other than, I guess, the name of what's going to be in the import statement if someone were to like drill into it. But the only thing that's really important is the main field. This is so like, if I were to import this package from inside of another app, the way it would look is, because the name is called app, it would look something like this. It would be like, I would be importing, something from app. It would look like that. That's exactly what it would look like. And you can see I'm only using the name of the package, not the name of the folder that the package is in. It's just that name field. And if it's like scoped, it might be something like, my GitHub name or my NPM name / my thing. That way it's scoped. You'll see stuff like that. Companies use that a lot. Companies will have something like, some company here / app or something like that, or / lib, utils, whatever. You will see that. So yeah, it's a little different when it's a little different than like what you would normally think. But yeah, it's just the name field that determines how you import it, and not the name of the folder that the package is in. Now I'm going to talk about how to consume those packages that you installed inside of your own modules. So let's do that. So I'm going to head over to my package folder. I'm going to make a new file, not a new folder, a new file. I'm going to call it index.mjs, and I want to consume that Lodash package that I just installed. So what you would probably want to do is go look at the documentation on how to do that. So in the sake of following my own advice, I'm going to do that. I'm going to look at the documentation and see if maybe they're up to date with ES modules and they have a really great thing. Wow, that's so many files. Oh my goodness. Here we go. So the documentation is basically using common.js, it's using the require statement. So I'm going to see if I can get lucky and try out these ES module imports instead. So I'm going to say, Lodash is usually used as an underscore, and that's a play on another library called _JS, which Lodash replaced. So usually people use the underscore variable name for Lodash. So I'm going to do the same thing, import from Lodash. So we'll try that, and let's just see if this import actually works. Let's see what happens. So now I'm going to run that code, and it looks like it worked just fine. So the interop here was just fine. The creators of Lodash must have anticipated this and made sure I was able to import it with no problems. So a couple things to notice here. Let's go back to what we were working on earlier. Before, when we were importing modules that we created, notice that I put this ./ here, right? This is very important. This is not optional. when you put a dot / or if you got to go up a couple levels or whatever that is, as long as there's a dot there, this is telling npm, this is telling Node that, hey, I want you to resolve a module that I created locally. This is a local module that I created. It's on the file system. It's in this project. It's in this directory somewhere. Go get it. It's a file. But when you don't put the dot in front of it or a slash like that, it's telling npm and Node that, hey, this is either an internal module like fs, or it's something that I installed via npm and it's in the Node modules folder. So what Node is going to do and npm is going to do, it's going to first check to see if this is internal. If it's not, then it's going to recursively start walking up your directory tree and checking every Node modules folder until it finds the matching thing. If it can't find it in the current working directory, then it'll error out. I mean, it'll literally go all the way up to like the global folder of your computer looking for it. So if it doesn't find it, then it'll like, oh, I can't find this module. Like for instance, if I change this to something else and I try to run this code, it's going to say module not found. I literally cannot find that module right there. So it's going to keep looking. So if you have multiple Node modules folders above this folder and then something exists in there, it'll find it and use it. And that may or may not be what you want. So just be cautious of that it's going to keep looking for the closest one until it resolves this package. You can change that behavior if you want, but it's not worth it. Cool. So that's how we use those packages. And then as far as like if we wanted to uninstall this package, we could say npm uninstall followed by the name lodash, and as you can see, it'll remove it. If I check the package lock, it's no longer there. If I check the package JSON, it's no longer there. It's gone. So uninstall completely removes it from the Node modules folder as well, which as you can see was deleted because I don't have any more modules. So npm was smart enough to just delete it for me. It just seems like nothing was ever there in the first place. So that's how you uninstall. Now we did have a question about npx. So I want to talk about npx. But before we talk about npx, I want to talk about global installs of packages. So far we've been installing packages locally to a project, as in it's going to exist inside of this app that I'm making and nowhere else. If you're not in this app, you can't use it. But sometimes you want some packages to exist globally on your machine, and that's useful for things like a CLI. For instance, npm is a CLI. And did you know that you can install npm with npm? Yeah, I know, it sounds crazy, but you can, because npm is a package itself that can also be installed with npm. So can Yarn. You can install Yarn with npm if you wanted to. And both of those should be global because we want to be able to use them from our terminal like this. If they were not global, we couldn't use them. So if you want to install something global, you would do npm install followed by the name. Let me try Yarn this time. And then you would say -g for global. And then you would try to install it. So you can see right now, I just installed Yarn globally. So if I say which Yarn, you can see I have Yarn now. And I used npm to install that globally. Now, sometimes there are some global CLI, some global tools that you don't want to install, but you need some functionality out of them for this one-off thing. Maybe it's a scaffolding tool, maybe it's a deployment tool, but it's just something you don't really want to keep around, but you do need to run it right quick. That's where npx comes from. So npx was also installed when you installed Node. It's already here. If I type in which npx, I should see that, hey, I had this thing called npx. npx is basically like running one-off global installs. So instead of installing Yarn, I could have just said npx and then Yarn, and then whatever command that Yarn can do. So in this case, Yarn has like a Yarn add. Then I'm gonna say Yarn add lodash. So I'm telling npx to tell Yarn to install lodash for me. So it's very meta. And this, you can see it executed pretty quick. So it basically just runs that tool for us, whatever this tool is, in this case it's Yarn, and whatever functionality that command has, it runs that without actually installing Yarn. Even though I have it installed on my machine, if I didn't, npx will still work the same way. So it's great for one-off global tasks that you don't want to install. So CI environments or CLIs that you just know you're not going to use other than for like this one thing, it's perfect for that. And then to uninstall globally, you would just literally do the same thing as before, the uninstall, but you would just say that -g, and it will uninstall it. And it's that simple. It's gone. So npm came up a long way. It didn't used to be this good, but now it's pretty good. I've used Yarn pretty much the whole time it's been out, and I just recently switched back to npm because it's amazing. But it doesn't really matter which one you use; they're both really, really good. Any questions on any of that so far?
Does it make any difference if we use dependencies versus using dev dependencies in package.json?
Good question. Yes, I was going to talk about dev dependencies. Yes, so where was I talking about dev dependencies? Yes, I was going to talk about dev dependencies in the testing section, but I'll hint at it just now. There is the only difference when it comes to dependencies and dev dependencies is how and when they're installed. But as far as functionality, there's no difference. You can use a dev dependency the same way you can use a regular dependency. It just comes down to how and when they're installed. Yeah, good question. Question was, is there a problem if we use npm and Yarn in the same project? I would say, yeah, there would be a problem because now everyone else has to do the same thing. Because like, okay, now there's a yarn lock file that says, here's the package of the version that we need. And now there's a package lock file that says, well, here's a package of the version that we need. So which one's the source of truth? I don't know. I guess it depends on which one you installed with. Yes, they both will write to the package.json file, and at least your dependencies will be in there. But if any of those dependencies required a conflict, like for instance, if you had a mono repo that had like React in it, and then there was another React app living next to it that was meant for like Storybook, or I don't know, whatever your configuration was, then how do you know which version of React to resolve to? And how do you know which tool did the resolution? Was it Yarn or was it npm? Well, you don't. So you'll just end up with probably the wrong version compared to everyone else. So if you are working on an existing project that's already using something, use that. I highly recommend using that. And if you made a mistake and you use something else, delete it. Do not check it into Git and just get rid of it. One thing that I've done in the past is I've always added like a script to the package.json. So if you go to package.json, you can add whatever you want here. And sometimes it might make some sense to like make a script here that like does something, right? So this is npm. So now if you run like, now it doesn't really matter what you do. It can be very confusing if you try to put 2 in there. I highly recommend just use whatever is in the project and don't try to do anything else because everyone else has to also change as well. So yeah, just delete it. Did I mention that? I don't think I mentioned this, but you can also do multiple installs at one time. So I don't think I mentioned that. So if you wanted to install npm install Lodash, Express, React, TypeScript, Jest, all these things, you can do them all at the same time. And this is where you'll get these long npm installs. I mean, I've literally had npm installs where I'll just walk away, go watch some anime, come back, check on it, walk away. Like sometimes it takes forever, depending on where you're installing from, some internal thing, some proxy, or whatever. This case, it was really fast. I'm on a really fast internet, and things are going really good. But yeah, you can install as many as you want, and the same goes for uninstalling. So I'm gonna uninstall all of these, and it works pretty much the same. Yeah, and I think that's pretty much really all you need to know about installing and uninstalling npm. Now, when it comes to like running the scripts, so let's say we have this test script here. Right now, it just says echo, no error, no test specified, exit 1. So if you want to run the script, you can type in npm, followed by the run keyword, followed by the name of the script. The only one that doesn't have to be prefixed with the run keyword is test. So you don't have to put run on test. You can actually just say npm test. And as you can see, it echoed out error, no test specified, exit 1, right? So, because that's exactly what's here. It exited 1. Remember I told you about how the process could exit with a 1? That's where this came from. Exit 1 means error. That's what this is. It's an error. So if you were to like listen to the standard error, the standard out, you would see an error there. You could pipe into that and write it to a log or something like that because it's an exit of 1. Obviously, we can change the test script to be whatever we want, and we will get into testing, so you'll see how that works. But yeah, you can change it. So we can also add other things here. So if I wanted to add, I don't know, I wanted to add something that like removed a file. So I'll say, I'm gonna add a script called remove, and it's going to Actually, let's make one called serve. So I'll make one called serve. And it's going to open this index.html and serve it on the browser, right? So first I need to find a package that'll serve. I know one off the top of my head. It's literally called serve. So I'm going to npm install serve. And I'm going to save that globally, actually. So I'm just going to say serve like that. So while that's installing, I'm going to go back here and I'm going to say, I'm going to use the serve CLI, and I'm pretty sure I can point it to a folder, and it'll find the index.html, it'll serve it for me. So I'm going to just do that, and let's see if that's done. That seems to be done. And now I can just type in npm run serve, and boom, localhost 5000, and it could not be found because I clearly didn't set it up right, and I didn't look at the documentation. But that wasn't the point to get the serve right. It was just to show you that you can pretty much customize how this works. You can literally do whatever you want. You can write bash script here. You can put a JavaScript file here and have it execute a JavaScript file if you wanted to. So you can literally do whatever you want. And these scripts are very powerful. So if you like hop into like a big repo at a big company, don't be surprised if you see like 20 scripts here that are doing like a whole bunch of crazy stuff, because that's just how it is. npm serve. Let's look at that right quick. We got here. So the way serve works is serve a folder name, which
I think it was the wrong folder name. I think this was intro to React and not just intro.
Yeah, it's just intro. Let's do it the long way. So we'll say serve like that. Let's see what happens. Run that. Let's see what the network says. Network says, come here. No request. Oh, there we go. 404 not found. Okay, let's try. Let's just literally load up that thing like that and see what happens. So we'll say that. Oh, you know what? It's because I'm in the package directory, right? So I got a cd out. So there we go. Now that should work. Let's try it now. So do npm run serve like that. Yeah, see, the problem is I'm in a package.json that's in a package folder, but I'm trying to run it on a sibling folder, right? So this package.json would have to exist on a higher up. So what I'm gonna do, I'm just gonna bring this over here like this. There we go.
Or you just do //
Or I could do // Yeah, I guess that would work too. Yeah, yeah. Obviously that's the easy answer. But all right, so we just did that. Let me go back into package, and then we can do npm run serve. Now we can go here, and it still doesn't want to work because I put the wrong folder. It should just be serve now. Now we run serve. We go back. There we go. Okay. So now you can see how you're able to create pretty much whatever script you want in the package.json and just prefix it with npm run whatever you want, and it works pretty good. And you can also see how important it is to read the documentation, even if you've already used the thing 1,000 times. And I use serve all the time. So cool. I think that's pretty much what I wanted to cover with packages. Any final questions on that before we move on? The question was, can you specify additional parameters to like commands inside the scripts?
Yes.
Yes, you can. So let me write another one. So if I say, what's a good one? I'm trying to think of a good one. Yes, you can totally do it. I'm trying to think like what's a good example off the top of my head. Let's try this. So if I make one called remove, and I use rm-rf, and then it takes a argument, like what folder do you want to actually move? Or actually, let's just do a file. Like what file do you want to remove? So I can say, because rm actually removes a file. That's what rm is going to do. So I can say npm run rm, and then followed by the file name. In this case, let's remove this index.html. Let's do that. So we'll say remove index.html. So if I run that, you can see I was able to pass in index.html to the rm command here as a argument, and it was actually able to execute and remove it from here. And the same thing goes with flags. So if you had like a flag that you wanted to pass in here, like rf, obviously this is going to break now. Let me make a folder so we can see that. So we'll make a new folder, call it hello. Now if we want to remove that folder, I could say remove rf, which means recursively remove this folder, and I'll call it hello. Hello is a directory. Okay, so I think you actually have to do like that. So let's check that out. Okay, now the problem is if I do that, I can't pass in an argument. So now I'm starting to remember. Yeah, you can't pass in an argument with a flag unless you hard code the argument here first. So it's either or. So there's not a lot of flexibility in it. So if I wanted to do that, I would have to say, I would have to put the name of it here. So like hello, and then now I could use a flag because I have this / here, which tells us, hey, whatever other flags they want to pass in, do that. But if I prefix that, then now I'm not able to pass in an argument, which would be, in this case, would be a folder name. So in this case, what I like to do when it gets that complicated is I would point to like something like this. I would say like some file JS here, like run that thing, do that thing. And then in that file, I'll do the stuff that I want to do. And you can use whatever NPM module you want to use, whether it's shell.js or custom bash scripting, a child process, whatever you want to do to run a bash script if you want. And that's what I do. I like to keep these pretty simple when they start getting complicated with all the arguments and things like that. So you should feel pretty comfortable searching for and installing packages to try out and use in your development. And I encourage you to do so. I think especially for someone new to learning to code, there's always this misconception that you need to know everything. Everything needs to be created from scratch. You have to just know how everything works. Well, I don't think really anything works like that in the world, especially in engineering. Like we all piggyback off of previous knowledge and people that have come before us, or even that are just better than us at something specific. So you don't have to recreate the wheel every time, and you should be leveraging the community by pulling it down and trying it, but also giving back and creating when you do find something that's useful for yourself. You know, you might not understand or you might not know who else it could be useful for. And you know, I really encourage you to try both of those things. So use NPM, it's amazing. Don't try to do everything from scratch because someone probably already solved it. Just install it. The next thing I wanted to talk about was CLIs, or command line interfaces. So we've been using CLIs pretty much this whole time. NPM is a CLI. Node is a CLI. Pretty much any program whose interface is on a command prompt, like a terminal or wherever you might be writing this code, that's a command line interface. It's just a fancy name for an app that runs in the terminal, and you interact with it through like a command and some text and prompts and different things like that. I would say that there's no visual representation or visual interaction with the CLI, but like these days people create like some crazy stuff with CLIs. I've literally seen like someone render like a 3D floating donut in a terminal with a CLI. So it's like, I feel like I can't even say that anymore. But for the most part, there is no like, you know, UI here for a CLI. You're just interacting with the box. So we are going to create a CLI. So if you've never created a CLI before, you're going to have fun doing this. I promise you. I try to make this one pretty fun and relatable and usable. So I'm going to walk you through how to do that so you can get your own little custom command inside of the terminal. And you can see how Node makes that easy compared to a lot of, well, you know, I wouldn't say that it's easier than everything else. Like pretty much every language is pretty easy to create a CLI. I know Dino makes it super easy to create a CLI. That's one of the biggest features I like about that. But Node.js is no slouch either. So we're going to figure out how to do that just now. So the only difference between a CLI and like a typical Node.js app is you just need to add a little bit more information to be able to have it consumed in the correct way when someone installs it. So what we're going to do is we're going to create a CLI that interacts with Reddit. I want the CLI to be able to go to Reddit and open up a random Reddit post that's on the front page. It'll open it up in the browser for us. All we have to do is just run the CLI, and we shouldn't, have to worry about what's going to happen. Like if you like Reddit, you'll probably like this. If not, welcome to Reddit. So let's do that. So the first thing we're going to do is let's create a folder in our little app here. So I'm going to make a new folder, not here, but here. And I'm just going to call it Reddit CLI. And then because it is a package, we need this to be a package for many reasons. One, that we're going to be installing other packages, and two, we're probably going to eventually, have other people consume this CLI as a package for their own. So we needed a package for both ways. So we're going to change directories into that, and we're going to run npm init. And I'm just going to hit enter on everything, get the defaults. Good to go. You can also skip that if you do npm init, and I think you do -- yes or -- y or something like that. It'll do the same thing. It'll just skip all of it. So we got that. We got our package JSON here. I'm gonna add a get ignore because it's just a habit at this point. Node modules, and there's a bunch of other stuff you should be adding here, but we'll just do node modules because that's the important one. I don't want that being tracked, slowing down my computer and my terminal and all that stuff. So we'll do that and put that in there. And then what we're going to do is we need to figure out what dependencies we need to install. But before we do that, we just want to get the CLI set up. Before we even do the logic of interacting with Reddit, let's just see if we can get a CLI to work. So the first thing we have to do is we need to just figure out, we need to create a file where the entry point to our CLI is. What's the file, what's the entry module, what's going to be executed when someone runs this command line. So we got to tell Node npm where that is. And then we have to make sure that it's executed in the correct interpreter. So in this case, the interpreter will be Node. We don't want this file being executed against Python or Ruby or Java. We want it to be executed against Node. And because we don't know how you're going to install this on your machine, we need to make sure that we're explicit about that instruction that, hey, this needs to be installed in Node. So we're going to use something called hashbang that's going to sit at the top of the file. It looks just like this. And this is going to tell your computer, your OS, like, hey, this file, this command needs to be executed against the Node interpreter. And here is the path that it's usually installed into. So it's the location to the node on someone's computer, and it's going to try to execute it against that. So the only reason this wouldn't work is if this person didn't have Node in this section. If you use NVM actually puts it here for you. It creates like a symlink, so you're good. If you use the native installer, that's exactly where it goes, so you're definitely good. So we're going to do just that. So we're going to make a new file here. I'm just going to call it Reddit MJS. So, and I'm going to add that hashbang like this. I'm going to copy it. Don't forget the hashtag. I don't know why didn't it copy that hashtag, or I guess I didn't copy it. There we go. And if you did it correctly, you'll see it kind of looks like a comment because it's not really code, right? This to show you that this is actually a comment. If I were to execute this node Reddit MJS, nothing happens. I don't see anything breaking or anything like that. Whereas if I just get rid of that, you can see that it's obviously going to break because that's not valid JavaScript. It thinks it's like a regex or something. So this gets treated like a comment. Like Node is very much aware of this. This is not like a hack. This is a real thing. So now that we have that, I'm just going to do a console log. So we're just going to get the hello world going. Hello from Reddit. CLI. So we got that. So we're almost there. Right now, we could execute this in the Node runtime and it works. But the whole point is that I want to be able to come in here and say Reddit and hit enter. I don't want to type in Node Reddit. Like, that's not a CLI. That's gross. I want a nice CLI. So we could do that. We can go to our package, JSON, and then we can add a new field here called bin. A bin on an OS is basically, in fact, we can just look back here. You notice that the Node interpreter is installed in some folder called bin. You can think of bin as like the folder where all your CLIs get installed. All your global commands, they get installed in a bin folder. So we need to register a new command in the bin folder. And we can instruct npm to do that for us when someone installs our Reddit CLI by putting something in the package.json, and that's going to be on the bin field. So if we go to bin, we put an object here, not like that, but like this. And then it's just going to be key, which is the name of the CLI that you want. In this case, we want to be able to run a command called Reddit, so we'll put Reddit here. And then the path to the entry file to it. So in this case, the entry file would be reddit.mjs. So like that, we'll put that there. So in this case, because this is a CLI and it's not meant to be, this application is not meant to be consumed by like an import. You know, I wouldn't expect you to npm install my CLI and then import it into your app, unless I explicitly said like, hey, you can also use this CLI programmatically by importing it. Most of the time, that's just extra work for a developer, so they don't always do that. So it's usually just only consumed by a CLI. So in that case, this main field probably just gets ignored, right? This main field is only for when someone's importing or requiring your application, whereas in this case, it's a CLI and we don't plan on having programmatic access. So this is, you can think of this as like the main field when it comes to CLI and not this. So you can kind of ignore that. So I just want to clear that up. So now we have the bin here. And then the last thing we need to do is we need to install our own CLI on our computer. And no, we don't have to like publish it to the NPM registry and then install it back down. That would just be ridiculous. Although sometimes I've had to do that for like conflict and version reasonings, and it's just really, really bad. But we can actually just do npm install -g. As long as we're inside of the directory of this package, by putting no arguments at the -g, it's going to install the package that you're in globally. It's going to install that globally. And during this installation process is when npm is going to see that bin field and register that command for us that points to that file. So let's give it a try. So looks like I already did this earlier, so I'm gonna try to uninstall this, or let me see. Let me just delete this actually. I'm gonna remove -rf that, and I'm gonna try to do it again. Okay, cool. So looks like I installed it. Everything looks good. It's in my, because I'm using MVM, it's going to create like a symlink and all that stuff is good to go. So I was able to do it. If you're having trouble with global install locally, what you can do, because I've had this problem before, is if you delete all of your, or not delete, but if you uninstall npm uninstall -g, if you run that and just uninstall all your globals, then try to reinstall this one, it usually clears up a lot of errors. But I have run into some errors before, as you just saw, with installing globally with npm. So, and then like with Yarn, it doesn't happen sometimes. So I don't know, if you're having problems with npm, if you have Yarn, try that. If not, just uninstall all your global stuff with npm uninstall, if I can spell that right, uninstall -g, and uninstall all the stuff and then try again. So once we got that installed, we should be able to come in here and say like which, if I can spell, Reddit. And you can see I do have Reddit here confirmed, everything's good to go. So I should be able to type in Reddit, and you can see right there, hello from the Reddit CLI. And that's it. That's how you create a CLI. It's not a good CLI. I mean, it's not something I would ever use. It doesn't even have a help command. I mean, it just does the same thing over and over again. So I wouldn't say you could go raise funding just yet, but yeah, you got the gist of it. It's just 2 small lines of code. You add a bin, and then you add a hash bang to the top of your entry file, and then you're good to go. So you just got to be a little clever about how you name the CLIs. Like, you never know who else also has that CLI installed on their machine and how that resolves and different things like that. So you kind of got to be clever with the name. There's really no right way of getting it right. On to the part of making this actually do something, we're going to need some help, because I said we want to be able to hit the Reddit API, and then we want to be able to process that information and then open up a random post from the Reddit API into our browser. So that's a lot of work that I'm probably not going to reinvent from scratch. I'm definitely not going to use the native HTTP module and open up like socket connections and manage that. And like, I'm not going to do that. I'm just going to rely on some people smarter than me who already created some really nice packages that I can install, and we're going to do that. So I have the packages listed here, and what we're going to do is we're going to install one called Open, one called Node Fetch, and one called Yargs. So I'm going to talk about these right quick. So open literally takes a URL and it opens it up on your default browser on your computer. So that's what's going to open it for us. It's really cool. Node fetch is exactly like window.fetch, if you've ever used that before. It's just a Node polyfill version of that, so it works the same way. And then yargs is basically a function that's going to interpret and process, I don't use that word because I'm going to use it twice. It's going to interpret the process objects for us so we can get access to things like flags and arguments to our Reddit CLI. Because I do want to pass an argument, I want to pass a flag to it that's going to allow us to bypass opening the browser and instead just print it out on the terminal. Maybe I don't want my browser to be open because my boss is over my shoulder, but I just want to print it out on the terminal so I can see it. So we can just pass the flag that says like print instead of open, and then that's what we want to do. So we want to be able to interpret that a little easier. So we'll use yargs for that. So follow along with me, but I also have all the code here that you can copy and paste. But I'm pretty much just going to go through this and then we'll figure it out. So first thing is, let's get our imports going. So we're going to import, what did I say, fetch. Well, actually, before we import, let's actually do our install, right? So let's say npm install. And by the way, you can do I for short for install. So you can say install, or you can just say npm I, which is less characters. So npm I node fetch, we have open, and then we have yargs. And then I'm going to save those. And remember, save puts it in our dependencies, which we have here. Boom, we got our dependencies, we're good to go. And now I'm going to import them. So I'm going to say fetch from node fetch. I'm going to say open from open, and then yargs from yargs. And I think yargs, I did have a problem with the interop between CommonJS and ES6. I'm going to just go look to make sure I got that one right. Oh, I guess it was fine. It must have been something else I was doing. Okay. The next thing we want to do is let's try to process any potential arguments we might pass in. Like I said, I did want to pass in a print flag that's going to bypass the opening of the browser. And depending on whether that's passed or not, that's going to determine what other logic we have. So we should probably process that first because we need that information. So I'm going to do something called, I'm going to say yargs, and that's a function. And I can pass in process.argv. And basically what this is, just to, wonder if I can log this. Yeah, I can log this. I was trying to think if there's going to be anything sensitive on there. Yeah, I'm going to just log this for you so you can see what it is. So process.argv. And then I think you'll get the idea. So we don't have to install our CLI again. It's already linked. It's a live file. So we can just run the Reddit command again. So you can see process.argv. It returns an array. The first two things are always going to be the path to the interpreter, which is Node, and then a path to the CLI, which is Reddit. And then everything else after that is going to be like arguments and flags. So for instance, if I want to say Reddit, and then I want to say print, like that, you can see it's passing as a third index number 2 into this array. Or if I wanted to pass an argument like hello, you can see that it literally goes in order from left to right, right? That's how it works. What yargs is going to do, it's going to process this and put it in an object for us in a key value way. That way we can use it a lot easier. But there's nothing stopping us from just doing RGV, bracket, split everything split everything after these first two and just grab the stuff here. That works just as fine as well. I just want to show you a really nice package that I use all the time. So we're going to process that. We're going to get the argv here. Like I said, this is going to be an object with whatever flags was passed in. So we got that. The next thing we want to do is we want to make a call to Reddit. So if you go to reddit.com and if you go to /.json, you actually get the JSON output of the entire front page of Reddit, like that. It's really cool. So we should look at this. Let me make this bigger. We should look at this for a little bit because we need to understand the data structure because we're going to query this. So we get back an object with a data property that has a children property that's an array of children, and each child has a data property. And on that data property, there should be a URL that we want. And I want to say it's called, I have it somewhere. There's so many things on here. Permalink, yeah. So I want to get the permalink of, yeah, I want to get the permalink of each, of whatever child we're going to open. And that's what I want to get. And I'll pin that to reddit.com/that subreddit / whatever. So that's how we're going to get our random thing there. So let's make a call to the Reddit API. And the way we're going to do that is using fetch. So I'm going to say fetch, or I'm going to say res for response equals await fetch. And fetch is going to take that URL here. So reddit.com/.json. And if you've never used fetch in the browser before, it actually doesn't return the data. It returns a response object that has like status codes, error messages, different things like that. And if we want the data from that, we have to resolve the promise of turning it into JSON, which is permissified. So then we can get the data, which will be data equals await res.json. So we'll get that. And just to make sure we are kosher, we will log this. So we do that. And boom. What did I log? Oh, I logged res. Sorry, it logged data. OK, so you can see we got the same data that we had in the browser. Obviously, it's not going to print all the objects here, but you can see it's hidden Reddit. It's good to go. And just to show you just how quickly we were able to do this, we imported 3 things, and we're already hitting the Reddit API and getting data. That's really impressive because we were able to leverage the community and different things like that. If we had to do all this ourselves, we'd be like close to 100 lines of code right now, especially hitting the API. Well, I'm exaggerating a little bit. Not that much, but still not as clean as this. Cool, so now we got the data. The next thing that we want to do is we want to get a random post. So we'll say posts, or let's just get a random index. And a random index would be, so data.children bracket. OK, let's do this first. Let's save this in a variable. Children equals that. And then now we can say, let's get children, what is it, math.random, children.length. No, it's math.random and then like math.floor, children.length times, you know what, I already have this. Why am I trying to do this math right now? Just copy this. There we go. So this is what we want to do. I do the random stuff all the time. You think I remember this, but I don't. OK, so we want to say, there it is. I was way wrong. We want to math.floor, math.random times our children.length. There we go. So this will give us a random child in the child array. You could do ceiling if you want to, but floor is fine. So now we got our random index. And now what we want to do is just, or actually this is our random post. Now what we want to do is decide if we need to open this post in the browser or if we just want to print out something about it. So what we can do is we can say if rgv.print. So if someone passes in the print flag, then what we want to do is we just want to console.log that post. So we'll do something like this. We'll say title is random post dot title. I'm assuming there's a title there. We'll look if it's not. And then link would be, let's make a link variable here. The link is going to be https reddit.com/ or actually I think the permalink has a leading slash and I don't feel like cleaning all that up, so we'll just trust it. So it'll be that. That'll be the link. And then we'll just say link like that. And then else we'll say open the link like that. So let's try it out. Let's see if we can get this to print with a random post, and then we'll try to open it up. So we'll say hello. We don't need that. Get rid of that. But I'll say print. And boom, title's undefined. Like I did guess on that, so that wasn't going to work. And then obviously this needs to be permalink. Oh, it's data. That's why. Permalink. And this is data.title. So let's try that again. There we go. So we have title. You can see there's the title of a random post from the front page of Reddit, and here is the URL that is messed up because it's not permalink. It must be something else. It is, oh, it's not camel case. Okay. There we go. Let's try that again. There we go. So we got our link here, and then we got something about adult lions pretending to be hurt. Okay, that sounds pretty cute. And it's random every time. So if we do it again, we get another one. Now let's try to open this up in our browser. So how do we do that? Just don't pass the print flag, and we should be able to do that. So I'm gonna exclude the print flag, and I'm gonna do that, and bam. It just opened it up in my default browser, which for me is Firefox. Don't judge me. And I'm not gonna scroll down and hit play on that, but you get the point. It opened it up to it, and it works. So really good CLI if you like Reddit and you don't feel like going to Reddit, you just wanna see something random. There you go. You can just type in Reddit and get a random thing today and check it out. So let's just go back and reflect on the code that we wrote a little bit, just to try to understand it a little more. So we have this hash bang here that tells us to interpret this file in the Node environment. We installed these 3 Node modules, and then moving on, we were able to use yargs, which was able to process the options and arguments passed into whatever CLI is being executed, in this case, the Reddit CLI. We used the fetch function here to communicate with the Reddit API and get some data. We processed that data, did some random indexing here that I struggled with, and we created a link to that random post, and then we just did a check to see if someone passed in the print flag or not, and if they did, just do a log. If they didn't, open it up in the browser. And that's it, and then the process was stopped. It exited down here with a process of exit of 0. There was no other code to run. There are no more background tasks. There's nothing scheduled. So it bottomed out, and there was no more ticks to be ticked, and it just stopped, and our code was done executing, even though the browser opened. And that's basically what happened. So as you can see, you can get pretty powerful here with a CLI, knowing what you know about file systems and the fact that we did that interpolation on the HTML file, knowing what you know about CLIs now, you could probably start putting together how some of the really good front-end tools that you use work. Webpack is a CLI. It also uses the file system. You just did both. So you're really starting to see how these technologies work together and how powerful they can be. And this is just a glimpse. If you really want to make a good CLI, you probably want to use a CLI framework. Just like there's front-end frameworks, there's frameworks for everything else on Node too. There's CLI frameworks, there's API frameworks, there's testing frameworks. Just like React is a front-end framework, there's frameworks for stuff here as well. So I would encourage you to see if there is something out there before you try to build something from scratch. I personally wouldn't build an API or a CLI like this. I would use a framework that has way better support and handling and help message and automations, all types of really nice stuff. But just to let you know that even if you did do it, it's not so bad. So any questions on the CLI? The question was, if you have an object and it logs object, how do you see that? Well, let's first talk about why it does that and then how we can get around it. So I'm just gonna make a new file here called test.js, and I'm gonna make an object, and I'm gonna make another object, and I'm gonna make another object like this. And then we'll put something in here. Okay, and then what we'll do is we'll log this. So node test.js. Okay, oh wait, that logged all of it, of course. Of course it did. Let me make another one. Okay, let's try that. There we go. Okay, I knew I had to get deep. So as you can see, I tried to log it the first time to get it to do the object, and it didn't. And then I added one more layer, and then it did. So at some point, the logging mechanism in Node is okay, you're just going really deep on all these objects, so we're just not going to log all of them. We're just going to paraphrase for you. And that's basically what's happening. When you have a certain level of hierarchy of data, Node.js tries to simplify the output of your logs by just paraphrasing that, hey, there's an object here, there's a sub-object. And it's actually really helpful, especially if you're streaming these logs, which you can stream logs from Node and to some provider that you're paying for. A lot of big companies pay millions of dollars per year to have their logs stored. Some even per month, big budgets to store logs. So the less logs there are, the less things that are being logged, the less you're being charged and the faster that they are. And also it's just less noisy. When you're really building an application and you have your development server up, you got a lot of stuff just streaming and piping in, and you're really only concerned about the thing that you logged and not all the sub things about it. So it's just a nice way to clean that up as well. But like you said, sometimes you do want to be able to see it. So how do you get around it? Well, there's two options. Well, you just log a little closer to what you want. So instead of logging O, I might log O.U.L. And then now I'm able to see that because I logged a little closer. So that's one way. The other way is you can do JSON.stringify and then pass in O, and then pass in null, and then you can pass in like how many indent spaces you want. I like to indent by 2, so I can do that. And then it'll print it out like that, the whole thing. It won't be nice and beautiful and colored, like the rest of the output is, because you're technically just logging your string, but it'll be formatted and it'll show every single thing all the way down to the closest child. So those are the two ways you can get around that.
You were passing flags, right? Like using double hyphens. Can we pass parameters using just one hyphen, and does Yarn recognize that?
Absolutely. Absolutely. So we can do the same thing. So I can say rgv.print or rgv.p, right? So let's try that. So if I say, we can do that. And I think it maybe capital P. There we go, yeah. So yeah, if it's a capital with the shorthand, then it'll read it for you. Cool, let's hop back on to the next thing that we're gonna talk about, which I think is a reason why a lot of folks are here. Servers, APIs. How do we do the thing in Node? Like, show us the promised land. Okay, this is it. I wanted to save this one to close to last because obviously there's a lot of stuff you need to know before you can take advantage of it. So we are going to talk about servers and how you could build servers in Node and the many different ways you can do it, and then pretty much my recommended way. But we won't be going into detail how to build like some ridiculously nice CRUD API that talks to databases and stuff like that, because we already have courses for that on Front-End Masters that I highly recommend you check out after this course if you're really interested in how to build a modern API in Node.js today. So check those out if you're interested. But this course, in this section, we will be talking about at least the fundamentals behind it, how you could do it natively, and how you should do it with something else. So Node.js has access to OS level functionality like networking tools. So when you're starting a server on a machine, whether it's your computer, whether it's Amazon somewhere, whatever machine it's on, it's accessing the network tools exposed from the operating system to whatever language you're working with. So in this case, it's exposing it to like C++, which is exposing it to JavaScript through, in this case, something called the HTTP module. So we're actually interacting with the operating system through Node. And I think that's just really interesting if you think about it. Like you're literally talking to the operating system through JavaScript. And if that's just not powerful, I don't know what, especially seeing where JavaScript started as like, changing colors of hyperlinks and things like that. Like, it's just crazy to think that you can do that now. But yeah, so it has access to stuff like that. And that's why a lot of people use Node, because like it is JavaScript, right? But it does have access to the OS level things. But also because when it comes to like APIs and stuff, Node is, and I talked about this a little bit, it's single threaded. And if you don't really know what a thread is, you can think of a thread as like, it's like a block. So if you have a CPU with 8 cores, right, you could think of like one thread taking up 1 core. So you can do like 8 different things at once if you took up all 8 cores. Whereas JavaScript would only ever take up one of those cores, one of those threads, and it won't, it basically uses an event loop, which has like a different worker thread separate from the thread that your code is working on. And it will schedule different things, and it will just keep looping over and over to see if some work needs to be done. And when that work is done, it'll basically notify you when it's done with like a callback, which can be translated to a promise, which can be translated to async await. And that's where all that stuff comes from. So this basically allows us to continue receiving requests from our users and our customers at the same time we're scheduling more work to be done and processed in the background. Whereas other languages, it's blocking. So you might have requests coming in and they're being processed in kind of like a serial manner. That doesn't mean they're slow. They're not slow. They just are blocking. They have to have access to multiple threads. The other thing is Node can have access to multiple threads. It's just by default it doesn't, but you could use the, I forgot the name of the module. I want to say it's the OS module, maybe the core module. I can't remember, they changed it. I could look it up. But you can use that module, or even a third-party modules probably are better than using the internal one to actually spawn different amounts of work into different threads, which is perfect for something like load balancing when you're deploying a server somewhere. So you can access multiple threads. Just by default, it won't do that for you. It's a manual thing that you have to set up, and you have to manage that yourself. It is not managed internally via Node like other languages are. So just keep in mind of that. That was a lot, but I needed to get that out. So let's talk about servers now that we know why servers are good in Node. Node does ship with an HTTP module, like I said. It's an abstraction around OS level networking tools. But even, some people might laugh when they hear this, but HTTP module is low level. And I know the reason I say some people might laugh because it's like literally nothing in Node is low level compared to other languages. But compared to other stuff in Node, yes, the HTTP module is very low level. And you should probably never use it. I can't think of any good example why you would ever use the HTTP module. But I'm going to show you how to make a server using it, not because I want you to, it's because I want you to see the difference between using this versus installing something and how better it is to leverage something from the community versus doing something from scratch. So what we're going to do is we're going to build this HTTP server here from scratch. So let's do that. I'm going to make a new, let me get rid of this thing. Go away. I'm going to make a new folder here. We're going to call this server. And I'm going to make a index.mjs. And I'm going to import HTTP from HTTP. This is included in Node, so I don't have to install anything. We're good to go. And if you were to look at that, you'll see that there's just a bunch of stuff on there, networking things, like stuff you would pretty much never use. But that's why I said it's pretty much low level. So you can follow along with me, or you can copy and paste this code here. But I'm going to walk through it so we can kind of see how it goes. So the first thing is we need to just make some variables here. I'm going to make one for the host, which is going to be localhost. If you don't know what localhost is, it's your machine. It's a reference to the IP address of your machine, which is usually something like 127.0.0.1. That's pretty much the IP to your local machine, but you can reference it as localhost. The local DNS lookup on your computer understands that localhost points to that address that I just put, that IP address. So localhost is great. The next thing we want is a port. If you don't know what a port is, you can think of a port as like the doorway to your host. It's like, how do you get to the host? Most websites that are deployed on the internet have a host of like 8080 or like 8000, mostly 8080 or 80. It's just that the browsers don't show them, but they're there. They're all there. You just don't see them because they all have the same port, so why even show it? They just exclude it from the URL, but it's definitely there. But locally, we have to specify a port. So you can think of it as like every time you make a server on your local host on your machine, you need to put each one on its own port, because a port can only be occupied by one server, not many. So if you try to start another server on the same port, you'll get an error saying like, this is already being used, try something else. And then sometimes you'll have different programs on your computer that open up ports without you knowing. So if you download, I don't know, some taskbar app up here, it's probably using a port on your computer, you don't even realize it, like Dropbox Sync or Spotify, who knows? It could be using a port and you might not know until later. So most time ports are like 4 numbers, sometimes they're 5, but we're gonna use 8000 for now. Sometimes you'll see 3000 and things like that. We'll just use 8000. And then the next thing is we're gonna create a server. And that is, we can say HTTP.create server like this. And it takes in a callback function, which is going to be the handler. Like, how do you handle the incoming request from the server? So we're going to say, okay. And then that callback receives 2 arguments. The first one is going to be the incoming request. I'm just going to put rec for short. And the next one is going to be the outgoing response. I'm going to put response for short. Because the way servers work is that they handle requests and then they respond to them. I guess that's why they're called servers. I don't know if they modeled the name after restaurants or whatever, but it's a server. It serves the clients. So you receive a request and then you respond to it in the fastest way you can. So we have our request and response here. And then the next thing we want to do, if you think about a server, there's typically different paths. So if you ever went to a URL like somewebsite.com/something, and you go to /somewhere else, it shows you two different things. You get two different pieces of data, whether it's a website or an API. Those are two different paths. But you also have different verbs. So you might have the same path to like /to-do, but one might be a post and one might be a get. So you can think of a route on the server as a combination of a path and a verb, and that would be a route. So you can have many routes on your server. So what we're gonna do is we're gonna create some routes and do different functionality depending on what those routes are, and we'll try to figure it out from there. So what we'll say is if request dot, what is it? Path? See, I don't remember. Now I gotta look. Oh, method, there we go. So request.method is a post. So if someone's doing a post request here, that means they're trying to send some server to the data. We want to grab that data and we want to like put it somewhere. So let's do that. First, let's like create like a little, I don't know, database, I guess, of things. No, actually, no, we won't. We'll do that on the next one. So we'll say post. And then what we need to do is, because this is like very raw, and even if you send JSON up, we're not going to receive it as JSON. We're going to receive it as like a buffer. Like when we were reading the file and it was all those little bits, that's how we're going to receive the data. That's not very useful for us. So we need to, and it's not going to come at once, right? It's being streamed to us in little bits. So we have to collect all of them and then put them together. And then we'll have the data that the user intended to see, the client intended to send us. So we need to do that. We need to collect that. So I'm going to say body equals like a string. Then I need to register some events on the request object that fire whenever a new piece of data comes in, and I need to send that data over to the body to be collected, which we could then look at. So I'm going to say request.on data, and this is going to get a what we call a chunk, literally a chunk of data. And I'm going to say body plus equals that chunk. So we got that. The next thing I'm going to do is say rec.on close. So when it's done, there's no more data coming in. We should be good to go. I am going to, this is where you would like insert into a database, right? Like, oh, we got the data. We're good to go. We can insert into the database. I'm just going to log this so we can see what it is. So we'll say body. So if it's a post, we'll see that. And then else, if it's not a post, if it's just a GET request, then we will just do a res, or I'm sorry, actually before the GET request, we need to close this response. Yeah, I was about to run into a big mistake. If you don't respond back to the client, your server is going to be hanging, as in it's going to be stuck in this state of like, I received the request, but I don't know what to do with it. And then the connection is going to be stuck open, and the client's going to be like, I'm waiting, you know, to hear back from you. You haven't gotten back to me yet. And then depending on the client, whether it's a browser or whatever, there's a certain timeout limit. Eventually it'll just time out. So if you ever seen like a timeout error, it could have been someone who forgot to send back a response, or more probably what actually really happens is what the response is just taking too long. But sometimes, yeah, somebody probably just forgot to respond back. And that's what would happen here if I would have moved on. So we do need to close off this branch here by responding. So I'm just going to say the quickest way is to do like rest.end, and then you can send back like something like that. But I'm also just going to say rest.set header, or no, I want to say set, no, which one do I want to do? Set a right head. Is it? I think it's right head. Yeah, I want to do a right head. So this is like writing the header, the status code. So for a successful post, it's usually a 201 status code. If you don't know much about status codes, it's totally fine. You can look them up whatever you want. But in today's world, especially with like GraphQL, status codes are becoming less and less of a thing. But it is very helpful to understand the different status codes. Probably will take you 20 minutes just to read them and figure them out. But a 200 status code means successful. Get 201 means successful post. So we're going to do a 201. And then else, if you didn't post, you just did a regular get, we'll just say rest.end, and it will say hi, like that. And I'll also just say rest.set write head 200 for a successful get, like that. So now we have our server. The next thing we need to do is we need to listen for the server. We have to turn it on to the actual ports and stuff like that. So we'll say server.listen, and you can see here it takes a port. We have a port. It takes a host. We have a host. And then the last thing we could do is we could put a callback here to do something, and then we'll just say console.log server on, and then let's do some template strings here. We'll say host port. There we go. So we'll try that, and if I didn't mess anything up, we will see this server run. So let's give it a try. So I can say node, and where did I put this? Server index. So I can say node, server. Oh, I got to back out. There we go. Actually, I'm just going to go into that file. So that folder, there we go. And then I can say node index, index.js. And as you can see, we are on localhost 8000. So that log worked. It's logging server on localhost 8000. And notice my Node app is still running. Up until this point, we would run a command, it would execute, and then it would stop, and it would exit, and we'd be back in the terminal. Right now, it's just sitting here, it's just waiting. Because we're connected, we as far as Node's understanding is, there's still some work to be done. There's still some work to be processed. So it's just continuing along and waiting. And that's the difference between like a server and like a CLI, where we ran one command and it was done. Or when we did the file reading, we ran one command and it was done. A server just stays on. That's the whole point. So unless you're doing something like serverless, which is like something that doesn't stay on, but still operates in the server context, you probably want your servers on all the time. So that's what this is doing. It's just sitting here until it errors out, or when we stop it manually, which you could do with Control-C. So I'm going to keep that running. And then now I'm going to interact with this API to see how it works. I have something on my machine called HTTP. I use this all the time. I talk about it in a lot of my courses. HTTP. It's basically, it's like a, if you ever heard of curl, it's like curl, but easier to use. You can install it if you want. You don't have to use this. You can use whatever you want. You got Postman, you got whatever API client you want to interact with the APIs. But I do recommend getting something comfortable, whether it's a GUI like Postman, whether it's a terminal thing like HTTP, whatever. Finding your tool to interact with APIs is going to be helpful, because if you're developing on the back end, you're developing APIs, you need to be able to test them. You need to be able to just like execute them right quick to see what's happening. Yeah, so highly recommend doing that. I'm going to use HTTP to do that and show you how that works. So we're on localhost 8000. So I know with HTTP, I can just say HTTP. If I'm going to be on localhost, I can just emit the host name and just put the port, which is 8000. And if I don't put anything else, it'll just do a GET request to the blank URL. So let's try that. So I'm gonna do a GET request, and you can see I get hi. And that's exactly what I thought was gonna happen, because it wasn't a post request. So it went down here to this else. It did a 200 and it said hi. So if I go back and look, I get a OK 200, 2K, 200 means OK. And I get a hi. That's exactly what I thought. So let's try to do a post now. So now I'm gonna say HTTP, I'm gonna say post 8000. And then I'm going to post some JSON. So I'm going to say color equals red, and then food equals pizza. So this is basically creating an object with a color field and a food field. That's what this is doing. So I'm going to post that, and then I get OK, right? And then I get this 200 that says it was created. But if I go back and look at the logs, I'm pretty sure I logged this. If I go back over here, you can see, aha, there's that object we sent up. And that was after we chunked it all together, right? Because if we go back and look at our code, I had to chunk this together, as in that JSON object that was sent up from HTTP was broken up into little bits of data. And every time one of them came in, I appended it to this body string. And then after it was all said and done, I was able to log it, which gave me that JSON object, right? So if I want to turn this back into actual object, I can say JSON.parse this body, and then we can get some nice color output going. So let's stop this, start it again, run that again, and then boom, you can see it's an actual JSON object now, and not just a JSON string. It's an object, and that's the difference. So you can see that's, I mean, yeah, that's pretty cool, but who wants to do this? I don't want to do this. I don't want to set all this stuff up. And I mean, sure, this is cool if I'm just doing one little, well, if it's a post or not, but what if I have multiple routes and sub routes and dynamic paths and different things like that? It can get pretty complicated. I mean, can you imagine all the if statements in here trying to be like, well, if it's a method post and if the URL contains this and it has, like, that would be crazy. Like, especially if you're building like an API-based product, like I can't imagine. So there are tools for this. And I'm gonna walk you through how to use those tools and those packages. But before I do, are there any questions on creating a low-level server in Node.js? Do I have any CLI frameworks that I recommend at the top of my head? I think I can think of two. One is Caporo CLI. I'm gonna type that in. Yep, this one is pretty good. I've used this one before. You can kind of just see the syntax, how different that is. So you literally get the program, you give it a version, you make a command, you define some arguments, some options, and then you run the callback when someone calls that command. It's literally that simple. And it creates like a nice help script for you when someone calls help. It collects all your commands and prints them out for you. It's really cool. So this one's really good. I think the standard that a lot of people use is Commander. Yeah, Commander. A lot of people still use this one. I think this was like the de facto one back in the day, and it still might be. I forgot why I stopped using it, but it is pretty good. You can see it's very similar. Everyone's pretty much got their opinions based off this one. This was like one of the first ones created by some guy named TJ Holloway-Chuck that you probably will never hear of now, but was pretty much like a legend in the Node industry back in the day, and still is. The dude's amazing. But I'm pretty sure he created this. So yeah, these two are pretty good. And I think there's another one from Heroku CLI framework. Forgot the name of it. Oak Cliff. It's called Oak Cliff. Yeah. I've tried this one before, but I don't have a lot of experience with it, but I've heard good things. So Oak Cliff is another one that you can check out. But yeah, those are probably like these are the ones I can think of off the top of my head. So yeah, good question. Anything else? Yeah, so the question is, do I still build servers with Node.js? Yes, I do, because there's sometimes not, okay, how to describe this? It's not that there aren't better tools, there are, but sometimes you need a little more flexibility on what you're doing, and just having a nice open server is great for that. Sometimes I just go serverless and I'll just use something like, functions in Next.js. But maybe I don't need a front end. I just need some API routes. And I need to keep it long running because of the type of database that I'm connected to. If you ever try to connect to, I don't know, a Mongo database in a service environment, it's hair pulling. It's ridiculous because it's not meant to be installed in an environment that's going to be shutting down all the time. It's meant to be open the whole time with its connections being pulled and everything like that. So sometimes the servers is a little more convenient. And then also, if I'm doing like some intensive stuff, I want a server. So it really just depends, but it's never at the point where it's like, well, it's either this or it's that. It really just depends on what you're making and what is going to be best for your job. Like I wouldn't build like a crawler in Next.js. I would probably put that in Node or maybe a service function, but I wouldn't like add it in Next.js along an app. And also, if my product was an API, if I was a SaaS company, a developer tools company, and my product was an API, I probably wouldn't put that, I wouldn't have that product be sitting next to Next.js and service functions. It would be its own thing behind a gateway, behind a proxy, behind all this other stuff. And really the only way you're going to get there is with an actual API, an actual server. So yeah, because sometimes you need access to those things. So it really just depends on what you're doing. But I would say for most cases, if you're just like, I just need something to send back JSON, yeah, you can get away with that without having to build a full server. But if you're asking that because this seemed kind of scary, well, wait till I show you how to do it the easy way. And then, maybe it won't seem so scary. One more question, okay?
Yeah, I don't know if you can speak at a high level about Node as a backend versus like Java or Ruby.
Yeah, I can. At my current job, we have a lot of backends in a lot of different languages. So I've had some experience with that. And actually, the first language that I ever learned was Ruby. Then I learned Python. And then I did learn Java, but not for servers, but for like Android. So I don't really have any server experience there other than my current job now, which does use a lot of Java. Yes, I would say no, I would always choose Node high level when I don't have any high CPU intensive tasks. So things like arithmetic, AI, machine learning. Yes, you can do it in Node, absolutely, but it wasn't meant for that. And if you tried to do that, it's like trying to squeeze a size 15 shoe in a size 15 foot in a size 10 shoe. It's gonna hurt, but you could probably do it. So you're better off using Node for things like, I need a JSON API. I need to query your database, I need to send back some data. That's it. It's a CRUD API. That's all that I'm doing. It's not doing crazy stuff. That's what you would use Node for, because it's able to handle a lot of requests out of the box without any tweaking. That's what it was built for. So if you're going for more requests per second and you're going for low CPU intensive task and you know JavaScript, Node's a really good choice. In fact, the thing is, like, you don't really need to, unless you're like a $1 billion company, where like a fraction of performance could cost you hundreds of thousands, if not millions of dollars. It doesn't really matter what language you pick. Pick the one that works the best for you. It's going to get the job done. No one's going to like not use your app because you decided to use Node. I mean, most people don't even know what Node is, especially your customers who probably aren't technical. So just pick the thing that allows you to get done faster, because at the end of the day, it's about being productive and not about what framework or tool you use until it actually does become a problem. Like if you're literally Dropbox and like, well, we can't literally use this language because we need this one feature and it's costing us money, and like, okay, then yeah, you should probably go figure that out. But most people aren't in that position. So high level, for me, it's always just come down to, well, I know JavaScript the best, so I always choose Node. That's it. It can do everything that anything else can do up until I'm making $1 billion. And I haven't made $1 billion yet, so I'm gonna keep using Node probably. We left off creating this manual low-level server, which is, yeah, pretty good, pretty impressive. I like it, but you're not gonna ship this to production. So what you want to do instead is use this amazing tool, probably one of my most favorite packages in the whole NPM ecosystem, the whole Node ecosystem. It's called Express, and it's such a fitting name because you literally can create a server super fast, like you're on an expressway. So the way we're going to use this is we're going to npm install Express, followed by these two other packages. So let's talk about these for a little bit. Express is a framework for building servers, short and sweet. Body parser is a middleware that parses incoming requests, and Morgan is a middleware for logging incoming requests. So what is this word middleware? Well, middleware is basically, if you think of a request coming in on the server, let's look at this. So request coming in on the server, here it is. That means this callback is going to be called every single time a request comes in. You can think of middleware as like a little piece of functionality that sits in between what you eventually want to do with the request and when it came in. It's like a pipe of plugins that can manipulate the request, it can inspect the request, it could do whatever it wants to the request before it eventually sends it to another middleware, or in this case, the controller. It's like, if you had a sandwich, the one side of the bread would be the client, the other side of the bread, one side of the bread would be like the incoming request, and the other side of the bread would be the response. And then like somewhere in the middle is like the middleware, like all the stuff that's in the middle, and then the piece of meat is the controller, right? So the middleware is like all the toppings that just adds all the extra stuff to whatever meat or veggie patty you got going on there. That's the middleware. So body parser and Morgan are those two. We're gonna use body parser to basically give us access to the incoming request, so we don't have to do the chunks anymore. We can just look at it like a JavaScript object. It'll be great. And then we use Morgan to just give us some logs so we can see the request being logged on our server. That way we know an actual request came in. It's great for debugging. It's great for recognizing if and when someone requested you. You should never go to production without having some type of request logging mechanism, because one of the most common debugging things you'll have to do as a backend engineer or a full stack engineer is looking at the logs to see when or what or how something happened. And if you're not logging, you're not winning. I don't know. Like you need to be logging. So we're gonna log here. So let's get started. We're gonna make like a simple little to-dos API that like creates to-dos and sends the to-dos back. Very simple. So like always, I have the code here. You can copy and paste, but you can also just follow along with me if you would like to. So we're gonna do just that. So I'm just gonna keep this one here because why not? Let's make another file. And I'm gonna call this one server.mjs. And I'm gonna add it to our server file. And we need to do some installations. So we're going to stop the server. We're gonna npm install express, Morgan, and body parser, like that. Oops, I wanna save that. So I stopped the install by hitting Control-C, and then I came back and ran it again and saved it. So we got that. Looking good, looking good. And so I just noticed I clicked on this node modules folder, and you see that there's a .bin folder here. That means that there's something that I installed from Node or from npm that has like a CLI shipped with it. If I go look at it, looks like there's a MIME CLI. So, but I didn't install MIME. I'm guessing Express did, or one of the tools that Express uses has a CLI associated with it, because that means this package somewhere, whatever is creating this MIME thing, has a bin property on its package.json whose key is called MIME. That's why that's there. So this is what it looks like when your CLI gets installed on someone's machine. It looks like this. It gets added to a .bin folder with the name of that field that you put on bin. So that's why that's important. And it happens during installation of npm, when npm installs your package. Anyway, let's go back to our server and let's import Express from Express, and we'll import, what was it? Oh yeah, body parser. I'm just call it BP from body parser, and then imports Morgan from Morgan. So we got all of those. Now with Express, we need to create an app. So we'll say app equals Express, like that. So now we have our app. And then we want to go ahead and set up our middleware first, and then followed by our routes. And then lastly, we will open the server, we'll listen, and we'll be good to go. So let's set up our middleware. So we want to, the way we can do that is we can say app.use. That's a method. And we can pass in an array of middleware. We can pass in one middleware. We can make one inline right here with an anonymous function. We're gonna use body parser. I'm gonna say BP. And I'll actually want to use something called URL encoded. And I'm gonna pass in the option that says extended true. Basically what this is going to happen, what this is going to give us is if someone passes some data on a query string, it's going to parse that for us, and it basically just makes sure that we can parse the query string and whatever's in the URL pretty easily. We probably won't be using this in this example, but it's useful. And then the other one we want to do is app.use bp.json. This one we will be using. This one allows us to parse the JSON body of a post request, so we can actually see it as JSON and not like bits of chunks that we have to add together like we did in the HTTP server. And the last one we want to do is Morgan. So we say Morgan, and we're passing dev. It's just a type of logging that you want. I think there's different options here. Let's see. So you can pass in, I don't know. There's like different formats you can do. We're just gonna pass in dev here. Maybe if I take this away, it'll show me. Let's see. Yeah, there's like combined, some other options. I always just use dev because it's the shortest one. Just give me the simplest amount of information. So now that we got our middleware, we need to set up some routes. Before we do that, let's like create a little database so we can store our to-dos. So I'm gonna say db equals an array. And now we're gonna set up some routes. So I want to route to where if I post to /to-dos, it'll create a new to-do and add it to the database and then send that back. And if I do a GET request to /to-dos, it will just send me back all the to-dos. So I'm gonna say app dot followed by the verb that I want. So in this case, I want to do the post. So app.post, that's a method. First argument is going to be the path that I want to receive. I said I want to-dos, so I'm gonna say to-dos. And then I'm just gonna say to-do actually, keep it singular. And then whatever controller, you could think of this as like what callback do you want to run when someone does this post request, okay? And just like the HTTP server, because guess what? Express uses the HTTP server underneath it, we get this request and response object. And you'll see this pretty much in every single Node.js server implementation, whether it's Express or Happy or whatever server framework you use, they pretty much all use request response. That's because they're all using the HTTP module, which uses request and response. So it's very common to see this pattern. So we're going to say, okay, cool. We want to first grab this to-do and add it to the database. So let's do that. So we'll say new to-do, and that's going to equal an object. We'll just say the ID is, I don't know, date.now. So I don't like incremented IDs. And then the text is going to be whatever is on the request.body.text. So that means someone's going to post an object to this server, and that object is going to have a text property on it. And the value of that text property is going to be whatever is going to be saved here in the to-do. And that's it. So now we got our new to-do. I'm going to say db.push our new to-do here, like that. And I'm going to say res.json new to-do. And that's simple. I was able to create a to-do, push it in our database, and then respond back really simply. So we're going to do the same thing before a GET request. So I'm going to say app.get/to-do. Remember, a route is a combination of a verb and a path. The verb here is a post. The path is to-do. The verb here is get, but the path is also to-do. So although they're both the same routes, they're different paths because this has a GET verb associated with it. So it's going to only be activated when someone does a GET request to this route or to this path. So request, response, and then for a GET request, all we want to do is just say res.json db. Let's just show all the to-dos. That's pretty much it. And the next thing is we want to start our server so we can listen on it. So we'll say app.listen. Looks familiar, right? If we go back to here, isn't that what we did here? Server.listen. It's really, like I said, an abstraction around the HTTP module, which already does this. So we'll say app.listen. We don't have to pass in a host here. It'll default to localhost for us, or whatever host you're on. And we just need to give it a port. So I'm going to just give it the same port of 8000. And it does take a callback optionally if you want to use that. And we'll just pretty much do the same thing. Console.log, server on HTTP, localhost, 8000. So we'll do that. And that's going to be our server. So let's give it a try and see what happens. So we will come here, we will run server mjs, and you can see we still get the same output, server on HTTP localhost 8000. So I'm going to, first I'm going to do a GET request to 8000. No other route, no /to-do, just a GET request. And I should get a cannot get. I get a 404 not found. Why is that? I'm pretty sure we just created a server. It seems like it's working. So why is it saying it isn't found? Well, that's because I didn't register for a route of the verb get and the path /. So it just 404'd. So if I wanted to get rid of that, I would make a route for app.get/ and that would handle that. Or I could do like a catch-all somewhere down here that says, if someone tries to make a request to anything that's not the stuff that I just put above here, then show that. And that's how you can handle errors without your app crashing and stuff like that with Express. So there's many ways to do that. It depends on whatever logic you want, but that's why that's there. So it's actually a good sign that we see that, because that's what we intend to happen, because we don't have a route registered for that path and verb combination. So what we'll do is we will actually hit one that works. Let's do a post request. So I'm going to start the server again. I'm going to use my HTTP Pi, and I'm going to do a post request to /to-do, and I'm going to post the text property. So this text says I need to eat more food today. I don't eat enough. I should eat more than I actually am. I have to be too busy. I don't know. So we'll do that. And you can see I get a 200, and it sends back this JSON object. Says, here's the ID, which I put date.now, and then our text. So I'm going to add some more. Clean up my closet. I just throw my clothes at the bottom of the closet sometimes, so I need to clean it up. There we go. So we got 2 to-dos now. The server is still running. If we look at these nice little pretty logs we have, this is Morgan. This is that middleware that's logging this for us. So you can see we had 1 request come in. It was a post to /to-do, status code 200, and it took 3.60 milliseconds to function. I have no idea what this number is with Morgan, but I'm guessing it's some time or something. And then the other one took even less. So super fast, as you can see, and this is just a local machine. It's, doing really good here. Now let's actually see if we can pull those to-dos down with the GET request. Before we do it, the server hasn't stopped. It's been running this whole time. And I was pushing those to-dos to an array. So that means I'm anticipating that because this server is still running, and because I pushed them to an array, that those objects should still be floating in memory right now. They should still be sitting around waiting for me to pull them down. And that would only happen if the server was still running and it didn't stop, like our other Node programs did. So let's prove that theory. And let's do a GET request to /to-do. And you can see here we get an array of both of the to-dos that we have because we're still running the server, they're still in memory, and everything still works. And you can see we do get a GET to /to-do, 200, good to go. I think this number is like how much data was sent back. That makes more sense. So maybe that's what that is. I am going to stop the server and start it again. And then I'm going to do that. You'll see that nothing comes back because I stopped the server and there was no data in memory. Yeah, so as you can see, let's just kind of compare apples to apples here. So I'm gonna try to, I forgot the shortcut to open this up in a new thing. It's like Command K. I don't know the shortcut anymore. How do we do this? Oh, there we go, split right. Here we go. So let's close this. I think this is like Command B. Yay, okay. So we got the server here, which is an Express, and then we got the HTTP server, which is in just regular old HTTP. So, I mean, if you look at the amount of code, it's about the same, to be honest. But in my opinion, this is just a lot easier to understand and a lot more expressive, and it's actually doing more. So although there's about the same amount of code, this is way more efficient. It's doing a lot more. We didn't even register any routes up here. We just had like a handler for a post and that was it. This thing has a database, a couple routes, it's doing a lot more with the same amount of code. So as you can see, it can get pretty crazy if you take advantage of something like Express versus trying to build this out yourself. It would be a lot more code to get the same functionality. Any questions on Express and the plugin, the middleware that I added here to get this working? The question was, can we customize the response codes in the Express controllers? And the answer is, of course you can. So for the post, we can say rest.set header, which is pretty much the same thing, but I think the one we want is status. So if you say rest.status, I can say 201, save that, stop this, start that, and let's do another post here. And you can see I got a 201. Right, so yeah, you can do rest.status to chain it. I think you can also do like, you can chain this. So you can see like rest.status.json and then just do that. I think that works too. We're about to find out. Yeah, that works too. Well, I know everyone was excited to get to the APIs and stuff, so I kind of just want to leave a little information about how you can go further with this, because I would imagine this is probably what you want to take advantage of. As far as like databases can go, I purposely didn't want to connect to a database and do stuff like that because I think it gets a little complicated. But it's not much. It really depends on the ORM or the implementation of the database that you're using. That's going to determine how you use it in Express. But for the most part, if you have an ORM, that has models or whatever implementation that you have, you would just use those same things exactly where I'm using my database, except these would just be async. And you can these handlers are async. You can put async in front of them and you can await them, and it works totally fine. So you can do all the things in here that are async. So this is where you would do your database stuff. And sometimes you would put them in middleware too. You might make your own custom middleware that checks the database if the incoming request's API key actually exists, or if it's valid, or if it's not expired. You make middleware for that before it even gets here. So you can pretty much do a lot of stuff with Express when it comes to building APIs. And I mean, just the combinations of the routes here, just to give an example of another one that is Probably something that you would want to see is like a dynamic one. So for instance, if I wanted to be able to get a to-do by a specific ID, I could do something like this. I can say app.get /to-do / some parameter here called ID. And then now I can say, well, give me the to-do where to-dos dot find the to-do whose to-do dot ID triple equals rec dot params dot ID. This is going to be a string where I know this is a number, so I'm going to like convert this to a number, or yeah, I'll convert this to a number like that. I think that converts it to a number, or we're going to find out. So we'll get the to do, and then I'll just do something like this: data to do. So now this is a dynamic parameter that can be anything, but it's referred to as the ID because that's what I called it here. If I called it something else, that's what it will be called here as well. So we're gonna call this an ID. I'm gonna close this one. And now if we go back here, we start the server. I got, I'm missing a parentheses, or what am I missing? I don't know why that thing's freaking out. Unexpected token, okay. Maybe the plus sign doesn't like it. Let's try this. Okay, there we go. So we got that, and now I need to post some to-dos right quick so I can get some IDs. Okay, cool, I got an ID. And then now I'm gonna say, let me do a get to-do / that thing. You can go away. And this thing freaks out because it says, oh, I put to-dos, it should be DB. Let's try that again. Posts, get that ID. Try that again. There we go. I was able to get the to-do back by the ID with a dynamic path. So you can see it gets really powerful. You can put as many of these one in here. You can even do regexes in these paths if you want to. Express is ridiculous. You should check out the documentation if you want to learn more about it. So if there's no other questions about Express, we will move on, unless there are some questions.
What is the use for the body parser, or what happened if we didn't include it?
Yeah, it's a good question. So I'm gonna get rid of this one, the body parser JSON, and then I'm gonna try to post. I'm gonna try the post and see what happens. I think that will give us the error that I'm looking for. So I got rid of the body parser, and I'm gonna try to do a post here. And you can see right now, instead of it creating a to-do that had an ID and a text property, it only created a to-do with an ID. Like, why did it do that? Well, let's think about it. Rec.body.text is now undefined. There's nothing there. So if you add an undefined field to an object, it basically just gets deleted when you turn it to JSON. So this was basically undefined. And this was undefined because the body parser did this. The body parser takes whatever is posted on the body and it attaches it to an object called body on the request object as an object. Without the body parser, we wouldn't have this, and we would have to do the exact same thing we did here. We'd have to say request.onData, build the chunk, collect the chunk, and then we have it. And that's just really gross. So we don't want to do that. The body parser, at least the body parser.json does that. URL encoded, we're actually not using, but this does the exact same thing, but for query strings. So if someone sends up a URL with a query string that had, I don't know, an object on it or a couple variables that are comma separated, the URL encoded would parse that and give us access to it via, rec.query. So there'll be something called rec.query here, and it will give us access to that. So that's why we use the body parser. So it's a very fundamental piece of middleware. In fact, a lot of this stuff used to be included in Express, and then Express started to like decouple and was like, we're just gonna be a little more fundamental and you can add whatever you want. So that's how it is. But then there's frameworks that sit on top of Express because Express has become so universal that pretty much every framework is built on top of Express now. So you'll see things like Nest.js, or I can't think of them. I don't really use them. But most of the GraphQL stuff, like Apollo GraphQL, Apollo Express, a lot of stuff is built on top of Express because the pattern is just such fundamental to Node these days. So yeah, you'll see a lot of stuff like that. Any questions?
This person says in their VS Code, it says body parser is deprecated.
Body parser is deprecated. It's hard to say why someone's VS Code would say that. I mean, the best way to confirm that is to go to body parser, npm. We can look it up. Published 2 years ago. It very well may be deprecated. So we can go look at the GitHub. I don't see any deprecation notice here in the docs or anything like that. But 2 years ago, it could have been. Who knows? I can look at some issues here. Yeah, it's hard to say why that would say that. But I mean, VS Code is VS Code. So it's not actually running your code. It's just doing static analysis. So if it works, it works. VS Code is just trying to be helpful before you actually attempt to run the code. So remember that. It's not actually executing it.
Yeah, on Stack Overflow is just saying that the body parser constructor is now deprecated and you need to call URL encoded in .json separately.
Yeah. Oh, yeah. I remember that. They did do that a couple years ago. It used to be the fact that you just had to use body parser and then you would pass in like JSON, true, or extended. But now they got rid of that and you actually just use these independently from each other. Good question. So is res.end not mandatory? Well, actually we are doing res.end. You just aren't explicitly doing it. When we do something like res.json, that's actually ending it for us. It's basically saying, hey, I want to end this response with this request that's going to be JSON. It's the equivalent of doing something like this. Res.json is basically saying like res.end, but not before you do something like res.writeHead. You say writeHead, and then you put, what is it? Content type. So it's like content type, application, JSON. So res.json is the equivalent of doing that. Passing in a JSON string here and then writing the head. So who wants to do all that from scratch when you can just do res.json? Could
you compare Express and Happy?
I can try. And that's only because I've only used Happy once in my entire life. And so I'll give you the comparison that I know that I can speak with the most experience about. And that would be that the community for Express is just much bigger. The support for Express is just much bigger. I don't know if Happy is better or more performant or overall in general, just you should use it. All I can say is that Express just has the most support, the most plugins, the most middleware, the most framework sitting on top of it, probably the most active community of any server framework in Node.js. And I can't say that about any other framework, even Happy. Yeah, although Happy is obviously very well known and is a big framework, it's just not as big as Express. It's like, I guess, the difference between like Vue and React. They're both amazing. I love Vue. But React's community is just overwhelmingly huge compared to Vue, even though Vue's community is pretty big too. So it really just depends on what you're looking for. You can't go wrong with either. The support there for both is pretty great.
Then someone's saying body parser is actually built into Express with v5, and so you can just do app.use express.json.
Yeah, I have yet to use Express version 5. I haven't even looked at it. Last time I checked it out, they were still working on it. So it sounds like maybe they haven't figured out. I don't know if that's the final version or if you're looking at a beta, but I have to check that out. That's pretty cool that they, because I mean, I would literally just said, hey, everyone uses body parse. I don't know why they just don't include this. So the fact that they did it is pretty impressive. But yeah, I'm on the 4X train right now, rocking that Express 4. So yeah, I would check that out. Good to know. Thanks.
I would recommend that people check out your API design and Node course if they want to go further.
Yeah, definitely recommend checking that one out. It's like up to V3 now, and I go pretty deep on building APIs with Express and Node. And although it's using Express version 4, it's pretty much the same thing. So highly recommend checking that one out. And if you like GraphQL, that's what you're doing. I also have a backend GraphQL course on Frontend Masters as well if you want to check that out. And that sits on top of Express. So it's just Express all the way, top to bottom. There's no way around it. I promise you they're not paying me to say this. I just like Express. It's a good tool. So yeah. All right, so let's keep it moving, and we will go on to everyone's favorite subject, testing, right? Everyone here loves testing, I would imagine. So we're gonna talk about that and how, honestly, Node.js is like the perfect tool for testing. It's so good with testing that I was trying to remember the last time I've written tests and like ran tests in a browser. That wasn't like an end-to-end test, but it's like a unit test, and I don't even remember. I know I did it at one point. I just don't remember when it was, because that's how long ago it's been since I've been using Node to write tests. So yeah, like I said, one of the most common use cases for Node is writing tests for Node.js and front-end apps. So you can do kind of all of it. It's really versatile. First, let's kind of talk about what unit tests. So if you haven't written tests before, the different types of tests, let's talk about unit tests. So unit test is basically, it will test like a little chunk of your code, a unit. It could be a little function, it could be some constant variable somewhere, it could be pretty much whatever you define as a unit, but it's basically testing it in isolation and not how it works with something else, right? So you won't be testing like how this system works together or how this API call, handles everything in the middleware stack all the way down to the response. That wouldn't be a unit test. That would be like an end-to-end test. You're testing everything from end to end and how they all relate to each other. You give it some output and you give it some input, and you run it through a bunch of stuff and you want to see what the output is and what will happen along the way. Whereas a unit test is like, I just want to see how this one thing works by itself without anything else interacting with it. So Node.js is really perfect for that. And I'm going to show you how we can do that. And just like the HTTP in the server section, I'm going to walk you through how to do this the manual way that's built into Node. Then I'm going to show you how you should actually do it. But by learning it this way, you'll see how it's all working. Because sometimes it can kind of feel like magic. So there's this really cool module built into Node called assert. And assert kind of sounds exactly like what it is. It's going to be used to do assertions against different truthy statements, right? We can assert that this statement must be true, and if it's not, it's going to throw an error. That's basically it. And most of the testing frameworks are built on top of the assert module. So we're going to use that to write some tests. So I'm going to make a new folder here. And I'm going to call it I'm going to just call it lib. So we got lib here. I'm going to make a new file and call it my lib.mjs. And then I'll make a new file and I'm going to call this lib.spec.mjs. So let's do that. So for the lib, we can pretty much do anything. I'm just going to we just need to write some code that we can test. So I'm just going to say const add. It's going to take some numbers. And it's going to return num1 times num2. Right, I know it's an add function and it multiplies. I get it, but we're gonna see how the test fails and then we can try to fix it. So we got that. In order for me to test this code, this unit, I have to export it. Otherwise, I can't import it. So I'm gonna export this. And now I can actually import this into some other file, which then I can use and test. So in my other file, which is gonna be the spec file, I'm gonna import that method from, not this file, but my lib.mjs. So one thing, I don't know if I mentioned this, but when you're importing MJS files, you do have to explicitly put the extension. If you don't put the extension, I don't think it'll work. Whereas .js files, you don't have to. And or if you went into the package.json and said, hey, I want to use ECMAScript modules, type module, then I don't think you have to do the extension. But we do. I'm being explicit. That way people don't get confused. I've seen some people get confused with this, so I just learned to just be explicit about it. That way it works. Maybe one day when Node.js finally is like, all right, everything's just ECMAScript modules and we don't have to do this, then I'll figure it out. But for now, I'm just going to be explicit about it because you can't go wrong. There's no confusion. So we got the add, and then we need to import assert from assert because it's built in. And then we can assert to see if this add function does what it's supposed to do. So the first thing I'm going to do is I'm going to console.log that we're running the add function, and I'm going to say, we'll make a little break line here, and I'm going to say should add to numbers. So I'm going to just log that. And then I'm going to assert. Actually, I'm going to try catch this one. I'm going to try catch the assert that add that takes in 1 and 2 should equal 3, because 1 plus 2 equals 3. If that fails, I'm going to catch the error. And I'm going to console.log fail. That. And then I'm going to console.error the error. But if it passes, I'm going to say success. So here's our little test using the assert library. So let's give it a shot, see what happens. So I'm going to go over to our terminal. I'm going to back out of this, go to lib. I'm going to run node. What was it? lib.spec. Run that. And for some reason, it says success. Did I not do that right? How would that say success? Hold on. My lib add. Wait. Why did that do that? Hold on. I think I might have used assert wrong. Let me get back to my notes. Dot strict equal. Okay, sorry. Okay, so let's go back into it and do dot strict equal. I'm not used to that change because I don't really use assert. It's too low level. But yeah, strict equal to see if those two things equal each other. And as you can see, we do get a fail here, assertion error. We say expected value to be strictly equal. 2 does not equal 3. And then you can see it logs out the assertion, which has the code, the actual, the expected, and then what operator we use to perform the comparison. It's pretty detailed. And yeah, it's not bad. I mean, you could go in here and write a bunch of unit tests for a bunch of code with this. But I don't know if you would want to, because one, the reporting mechanism is not that easy to read. Could you imagine if you had like 20 tests fail and this was just like what you pulled open times 20 inside of a log file on your server somewhere? Like this would be terrible. Or in the CI on GitHub, you wouldn't want to see this. It'd be really hard to parse through. So the reporting is bad. And it just really wasn't that flexible. What if we, like right now, I don't have like any formatting up here about what I'm actually testing, like what piece of unit, and then what I'm testing that unit for. Like I logged it here so we can see it, but it doesn't really stand out, so it's really hard to see. And I don't really get any indication of like how many tests I ran, how long the test took to run, how many failed, how many passed, just like the statistics on that. That's not saying we can't make it. Like using the assert lib module, like we could totally make all that stuff. But again, why would you reinvent the wheel when there's already good stuff out there? So we're going to use one of those things. And there's so many of them, and they pretty much all have been piggybacking on a really popular one called Jasmine. I think that was the first one that really kind of took this approach. So Jasmine came out a long time ago, and then Mocha came out and sat on top of that, and that was my tool of choice for a long time. But now everyone's kind of converging on a tool called Jest, J-E-S-T, and that's what we're going to use. We're going to use Jest, again, created by Facebook. They seem to just be on a roll with this open source JavaScript stuff, right? So let's do that. Let's install some Jest. So we'll say npm install Jest, but we're going to say save dev and not save. That's because Jest is going to be a dev dependency. So a dev dependency is exactly like a dependency, but it's meant to be for development, as in it is not, your app does not depend on Jest being installed for it to operate. If Jest was not installed in this application, the add function would still do what it's supposed to do because it doesn't import Jest. It doesn't use Jest. Jest consumes our app, so therefore it's a dev dependency. Our app doesn't need to, when our app is executed by the Node interpreter, it's not going to include Jest. It doesn't need it, so it's a dev dependency. And the reason that's important is because when you deploy or you publish to NPM, and someone's pulling in your code, they don't need your dev dependencies because they're never going to run tests. They're never going to run the build script. It should have already been built, and you should have already tested it. So you don't want to ship those extra dependencies on someone's machine. Same thing if you're deploying. If you already built inside of a CI or something like that, you don't need a lot of those dependencies to be sitting up there, so don't even install them. So dev dependencies just basically give you another Boolean to install on. So you can tell npm install just the dependencies, or install just the dev dependencies, or install all the dependencies. So it really just depends on how you want to do it. It's just another flag that you can, basically Boolean off on when you do an install. All right, so now that we have Jest, we can switch this over. Actually, we'll leave this one and we'll just write some better tests. That way we can kind of compare. So we'll write some more code here. I'm going to open up a new file. And I'm going to call this one utils. And I'm actually going to do a JS here. I know we said we're going to do MJS this whole time, so this might be confusing. But as of right now, the current version of Jest does not support MJS files out of the box without some type of configuration that I think is a little out of scope of this exercise, so I don't want to cover that. But the next version of Jest that you can install, which is beta, does support it with some small configuration, but I also didn't want to inflate and confuse anyone with that configuration. So we're just going to just switch to JS and use CommonJS for the course of Jest. But that's not going to determine how you use Jest. It's still going to work exactly the same. It's just determining what type of modules we can use. So we'll be using CommonJS here for Jest, so bear with me. I do have some code, though, that I want to test. So we're going to go grab that code. It's really not doing anything. And it is this code right here. So here's the code that we're going to test. I'm literally just going to copy and paste it because this is not the important part. The important part is the test that we're writing. So I'm going to paste that in here. And just to go through it so we kind of know what we're doing, I have a delay function up here that I'm using just to simulate asynchronous program. We won't be testing that. I have a users array that's basically a database. And then the two functions that we will be testing will be the get new user function, which is asynchronous. It's an asynchronous function that queries the database for a user that has this ID. And it tries to, if it doesn't see that user, it'll throw an error. If it does, it'll return the user. The other function that we will be testing is going to be map object to array. It takes an object and a callback, and it basically maps over that object and puts all the results inside of an array. So those are the two functions we will be testing with Jest. So now I'm going to make a new test file here, and I'm going to call this utils.test, or you can even say spec. I like spec.js, like that. And we can get started by writing some tests. So the sweet thing about writing tests with something like Jest is how we're going to execute this. And that's really important because it means we don't really have to import a lot of stuff. So what I'm saying is if we head over to the package.json, which I don't have, I need to actually create that. So I'm just going to say npm init like that. There we go. And what's crazy is that even though I created the package.json later after I already installed, you can see npm was smart enough to add the dependencies that I had. It wasn't too smart. It put Jest in the dependencies and not the dev dependencies. But there's no way it could have known that it was a dev dependency when it wasn't here already. So it kind of got there. I should have init before I installed, but it is what it is. So the sweet thing is we can just hijack this test command, and we can just put Jest here like that. And because we're executing the Jest test in the Jest environment with the Jest CLI, we don't have to actually import any of the stuff that Jest has. It's just injected to us globally because it's executed in the Jest context, which is really cool. So what does that actually mean? Well, let's write some tests. So typically what you do when you write a test in something like Jest is you import the code you want to test. So in this example, I want to import from utils. Oh, I'm sorry, can't do that. We got to do this one. We got to do some required stuff. I want to import from utils. And I want to get new user and then map object to array. So we got that. And then what you would normally do here is you would do something called describe. And you can see it tried to autocomplete from yargs. I don't want the yargs one. I want the Jest one. And typically the way describe is like you're describing the piece of code that you're about to test. In this case, let's test the map object to array first. So map object to array. And I'm gonna do that to let you know that it's a function. So we're gonna test that. This is what we're describing. And then each thing that we want to test, each assertion, if I must, we write a test function for it, not to be confused with, you can see it tried to include the test global from Jest, which is the same thing, but we don't need to do that because it's injected for us. So now we can say test, and then I can actually write, like, what do I want to test? Well, let's look at the code. I want to, here. I want to make sure that this puts the, I'm going to make sure that it calls, no, I want to make sure that it actually just does what it's supposed to do. It returns an array of all the map values. So I'm going to pass it something, and then I'm going to see what the output is. And if it doesn't match, it didn't do its job. So either the code is wrong or my test is wrong, and we'll have to figure it out. So I'm going to test that it maps values to array using callback. So that's what we're going to test. And then now what we can do is we can say result equals map object to array. I'm going to pass in an object, and we'll call it, you know, this is a food order. So like, was there a shake? Yes. Did we have fries and were they good? No. And was it fast? Yes. So we have these objects here. We want to map them to an array. So if my code is doing what I think it's doing, well, I guess now I got to pass in a callback. Let's do that. Let's do a callback over here. So if we do a callback, I can take each one of these, it should be like a K and a V here, a key and a value. And I'll just basically, actually this is not a good one. Let's do some numbers here. Numbers will be better to test. Let's say age 30, height 65, whatever. So we got that. So now if I map over these and I say return value times, or value plus 10. There we go. So I should get back an array of two things, and it should say like 40 and 75. So that's what I expect. So I'm going to say expect, which is another global from Jest. You can see it try to auto import. I don't need it. So I can say expect result. And then I can say to equal. And I want to do equal because I'm about to compare two arrays that are two different arrays in memory but have the same value. So to equal is a deep equality check and not a exact match. If I want to do an exact match, I would say to be. And that would say, is this array exactly this array? And that's not what we want. We just want to make sure they got the same values. So I'm going to say it should be an array of 40 and 75. So let's try that. So now what we can do is we can run the npm tests. I think we're going to get an issue because we have this other test file here. I'm going to just get rid of this right quick so it doesn't interfere. Or I'll just rename it. Let me just not put a spec in there. There we go. So now I can just say npm test. And you can see Jest says, cool, this passed this file. Here's what you were testing. Here's the actual test. Check mark means it passed. One passed of all the test suites. One total tests. Snapshots, what they were already snapshots, what we're not doing. And just how long it took in general. And then it ran all test suites. So as you can see, the output is just a lot better. If you can imagine just a bunch of these with green check marks on them or red X's if they failed, it's just a lot easier to see and visualize than anything else. So it's not that like it's doing anything different. It's just, one, it gives us a better output. And two, it's a little easier to develop with, in my opinion. Although assert's really not that bad. It's just, there's a lot of setup here that I had to do. Whereas Jest, yeah, there's a lot of ceremony with the describe and the test, but I think it's necessary ceremony. It kind of works. So that's how you would write just a basic test here. We can move on to doing something like a spy. So for instance, we know that we have to pass in a callback here, but I want to test to make sure that the callback actually gets called. I'm not sure that if it gets called, I want to make sure that it does. So callback gets called. So we'll do this. And we'll just copy this right here. But before, I'm not going to actually add this callback here. I don't really care what the callback does. I'm just going to call this a mock callback, and I'm going to make that. So const mock callback is going to be jest dot function. So that's just going to create a mock callback. And as you can see, I'm using this jest keyword here. That's also injected into the global space because we're running it in the jest runtimes. Pretty amazing. So now I can say expect mock callback it's like expect mock callback dot, what is it? I can't remember. I have it here in my test. We want to see, oh yeah, mock callback dot mock dot calls. There we go. It's so hard to keep up with. So dot mock dot calls dot length to be, well, I know this callback is going to run for as many key value pairs as in this object. Right now there's 2, so it should be 2. It should have been called twice. So I'm going to check that out to see if that works. But let's make this fail so we can see what happens. So let's make that fail. And you can see right there, we got a fail on map objects to array. Callback gets called, that failed. Expected 33, but received 2. And you can see where it colors that. So here's the expected, and here's what it actually got. And it even points to like where you wrote the code. And then you get all this really cool stuff. So it's really great how this works. So now you would go back like, well, no, this test is right. It should have been called 33 times. So now the code is wrong. But more realistically, it looks like my test is wrong. So obviously I would change that to 2. And now my test will work. So now we get all these green check marks, which is like the best feeling. It's so good when you do a pull request and the CI says you're good to go with all those green check marks. It feels so good because then like you'll be out, you'll like do a PR and then you'll walk away. You'll go like fix a grilled cheese. And then you'll look at your Slack from the bot that messaged you and it says your test failed. And you're just like, dang, I can't even eat this grilled cheese now because you know everyone's going to hit you up. You got to do a rollback or whatever. So it's just really nice to see those green check marks. Now let's try to test some async code. This is all cool. You could imagine all the different types of assertions you can do. You can look at the jest documentation. But let's try some async code. So we'll say another describe here. And we're going to say, let's describe this get new user like this. And we're going to test that it's, let's go look at the code. What does it do? Oh yeah, we're going to test that it actually, I want to test that it finds a user, and then I also want to test that it throws an error if it doesn't find a user. I want to test both cases. I think a lot of people, when they write tests, they only write tests for like the best cases. Like, so in this case, they would only write a test to see if it would get a user, and then they would ignore everything else. But it's like, well, you also want to test when it doesn't get a user. Whenever there's a branch in your code, as in an if statement or a switch, if there's a branch, you should test that branch. In fact, there's a tool that you can install in Jest or any other testing program that will literally highlight the code that you did test, and it will highlight the code that you didn't test, and it'll give you a percentage of how much test coverage you have. And some companies won't even allow you to merge a PR in unless you have a certain amount of test coverage. So if you don't know about that, that's a thing. So yeah, there are tools that will statically analyze that for you and let you know how much code you tested. So test your branches, not just the success pass. So we're gonna test both of them. So let's head over to our test here, and we're gonna write a test to make sure it gets user. This is gonna be async, so I'm gonna prefix this with async, like this. And now what we're going to do is, because this is async, and I like to use async awaits, I don't like promises or callback. There's a couple ways we can do this. I'm gonna do this the way that I like to do it. And what I like to do is I like to say expect dot assertions, and then I can tell just how many assertions I expect to happen. Oh, I'm sorry, no, this is get user. That's for the errors. Let's just do the get user. So let's just check to see if this gets a user. I'm going to say user equals awaits get new user with the ID of 1, because I think that's like the only one I have in there. Yeah, ID of 1, Goku. So we'll get the user, and then I'll just say, I just expect user to be truthy. like that. So I'll say expect user to be truthy. Let me get rid of that import. And then I'll also, there's nothing stopping you from doing multiple, I wish it would stop doing that, auto importing. There's nothing stopping you from doing multiple expects in, inside of a test block like this. So we could do that. So I'm going to say expect user to be truthy. I'm also going to say expect user.id to be 1, like that. So we'll run this code, run the test. And you can see I get a test pass, get new user. We did get a user, and it did get an ID of 1, just to make sure if I change this to something else. Obviously, that is not going to, oh, what? Did that work? Oh, I didn't save it. Okay, I was about to say. There we go. So this fails because just, oh, I put a 0 there. Let's get rid of that. That was like a different error. Okay, there we go. That's the proper failure. So received 1, expected 90. So obviously my test is wrong, but just to show you that that works with async. But now if I want to test to see if an error was thrown, what I can do is I'm just going to copy this. And I'm going to test that should. Or I'm just going to test no user found. There we go. So before that, I need to say expect dot assertions to be 1. So I do expect one expect to be called. And the reason I have to do that is because I'm about to wrap this in a try catch. Okay, because we talked about error handling, async await, and the best way to do it is with a try catch. And I have to tell Jest that I'm expecting an expect to be called. Other than this one, I expect another one to be called. And I have to say that because if this did not error out, this catch would never happen, and then this test would pass. But that defeats the point of this test. It should error out. That's what I want to see. But because it may not error out because the code could be wrong, it will never hit this catch block. And then according to Jest, it's a pass test. But by adding this at the top, I'm saying, no, this fails unless at least one expect actually runs. So that means this catch block has to run, and this catch block is only going to run if this throws an error. And if it throws an error, then our test will pass. So that's how that works. So now I'm going to say expect error to be truthy. We'll just start with that. And then I'll pass in something that's definitely not going to be there. And we will run this code. And we'll see what happens. And obviously, that worked because this throws an error. And we expected the error to be truthy. So that worked. So if we do this, now this is going to fail because it doesn't throw an error, right? So now it failed because like, hey, we expected one assertion to be called. Well, the catch never triggered because this never threw an error because there is a user with the ID of 1. So then that means, well, either my code is wrong or my test is wrong. Well, in this case, my test is wrong. I didn't pass it the right input to trigger an error. So if I wanted an error, I need to pass in the right input to actually get that error. And then we're back to business with all green check marks. So this is how you would run tests. Typically, you would see, every file has its own test if that's how you're doing things. And you would hook this up to like a CI, pull request flow, deployment flow, different things like that. Run it. Some people put them on hooks before they push up to GitHub or before they do a commit, different things like that. They're all really good scenarios and whatever works for your team. But yeah, this is how you would write tests. And this is really just the beginning. With Jest, you can add different reporters. So right here, this is a reporter. This is something that reports to our terminal. But you can have different things that report to HTML files. So you can actually get like a website built for you of all the results, of like code coverage and things like that. Or you can change the output of this. I used to have reporters that would I was building curriculum for like some custom classroom that tracked how many times you would fail, and then it would send you answers from Stack Overflow, and then it would show the teachers what you were struggling with, so they knew what you were struggling on because they saw you failing it a lot. You can get really crazy with the reporters and do some really amazing stuff there. So yeah, this is Jest, and pretty much every other testing framework works very similar to this, since Jest was heavily inspired by those frameworks like Jasmine and Mocha. So yeah, that's how you write test in Node.js. And again, this is unit tests. Jest also supports snapshot testing, which is great for UIs. And basically what that is, it'll take the string representation of your UI, so the HTML, the classes, all those things, and it'll just write that to a file with the exact spaces and everything that's rendered out, it'll write that to a file. And then when you run it again, it'll write it to a file again, and it'll compare the two. If those two strings don't match exactly, then the snapshot failed. That means someone changed something in this DOM that resulted in the HTML looking different. That's called a snapshot test. But if you purposely did make a change, then you gotta tell Jest to update to new snapshots because you actually did want to make a change. So that's a really great way to test UIs. There's other ways you can do it, but those require browsers, like taking screenshots and putting them on top of each other or doing an end-to-end test. Those require a browser, but for the most part, you can get away with snapshot testing with Jest. Okay, any questions on testing with Jest? So how do we test internal features, like code that's internal to a module that we don't have access to? Okay, first of all, you should not be testing code that you did not write. You just shouldn't. I'm just gonna say that. There's just no reason why you should test to see if something works. Whoever wrote that should have already written tests for it. So the test should live in that repo. If it's an internal module, then you can just trust that the Node team already tested it. If it's an NPM module that you installed, then they should have tested it. You don't want to write tests. Now, if you're saying that your code consumes those modules and you want to, like, I don't know, how do you mock those out or handle them? Well, yeah, you could do something very similar to what I did here with like mocking calls. Jest also supports mocking full-blown modules. You literally can, I think if you make a folder called mocks, and inside this folder, you make another folder that is the exact name of the module that you want to mock. For instance, if I wanted to mock Lodash, I can do that. And then inside of here, I put a file. Jest will read this file instead of reading the Lodash from Node module. So you can mock out the entire module if you want to. But again, that's not for you to test it, obviously. That's just so you can like get around this code being in your code and it being in a way. For example, like if you've ever written a backend and had to use something like Stripe, and there's like all these Stripe calls around you, or any API where it's like you don't want to hit the API during testing, especially if they're charging you for it and there's like latency. You probably want to mock out those API calls to like these third-party services that you're using during your testing. There's no point. You don't need to test to see if Stripe's API works. That's not your responsibility. They do enough of that. You just need to test everything that interacts with that. You want to make sure you're passing it the right parameters, and you can do that with the mocked function. And you want to test that you handle the output correctly, and you can do that with another mock function. But you don't need to test their code specifically because they should be doing that. We just finished talking about testing, or unit testing in Node.js with Jest, and how amazing of a tool that is, and just how easy it can be to write tests. And also just want to emphasize how important it can be to write tests. So write your tests and use Jest. What I want to get to now is I want to talk about two things I think are important to really leave you with. One of them is going to be debugging, and the other one is going to be deployment. So I want to tackle debugging first because I wasn't sure what order I wanted to do this, but I want to do debugging first because it's really important. I think it's really powerful in Node. So if we actually go over to the site, I didn't put any information about debugging because as I started thinking about it, it would have just been a bunch of screenshots of how to do the debugging, which there's already so many great resources on how to debug in Chrome and stuff. So I was like, all right, I'm not about to just compete with Chrome's debugging documentation. So I'm just going to show you how to debug, or at least how I do it, and how other people do it and how they recommend it. So the first one, obviously, is to just use console.log. Whenever you log to the console in Node, you see it output in the terminal. You can do that, and that's going to get you far. It's about as far as console logging in the browser. It's great for figuring out common things. But for like really big bugs, I do recommend using the amazing DevTools debugger that's built into like Chrome. It's an amazing tool, and you should be taking advantage of it. And although Node.js is not in Chrome, because it uses the V8, it can be actually inspected into the Chrome's debugger, which is really powerful. Also, VS Code took it upon themselves to have the same debugging experience in the editor built in, because VS Code is built with some type of cross-platform code that has some similarities and everything. It's basically built with Node, right? So it has it. So I'm going to walk you through how to do it in VS Code, And then we're going to see how to do it with Google Chrome and how we can attach it. So let's pick something that we want to debug. I'm going to pick the Reddit CLI. Or no, you know what? I'm going to pick, where's the one we were writing files? Here we go. I'm going to pick this one. So the one we were writing files with the MJS, let's try to debug this. So what we could do here is, if you're in VS Code, and if you're not, don't worry, we'll get to the Chrome non-VS Code one in a minute. If you hover over a line, you'll kind of see like a dot that goes next to it. This is for debugging. Yeah, so we'll set a breakpoint right here to just basically stop right here. And then all we got to do is, if you go over to this play debug thing or hit Command Shift D, you should have this option that says run and debug. So I'm going to click that. I'm going to launch this in Node.js. So I'm going to click that. And then boom, you can see that the code actually stops right here. I get these controls up top that's very similar to the Chrome tool, so I can continue on with the execution. I can step over a line of code. I can step into a function to see, you know, what's happening inside of this function. I can step out of a function to zoom back out, and I can restart this whole execution from scratch. And then I can just say stop. So we get all access to that. And then obviously over here, we can look at the call stack. So if I just get this up a little bit, let me drop that down. So we can look at the call stack of what's being called so far. You can see here's our file and a bunch of internal stuff because we haven't really done anything other than importing a module so far. And then you get to see a bunch of whatever is injected into this file. So you can see a bunch of stuff here, the actual read file function. So it's pretty helpful. You know, you can come in here and let's see. If you wanted to like click on watch, you can watch an expression. So if I wanted to watch results, like I say, I want to watch that to see what it is. Right now it's nothing because we paused it right before it executed, but on this next line, it might be something. So let's hit play. And I guess I got to run and debug it again because I didn't catch that one. So let's try that again. Okay, I guess it just doesn't like the fact that that's async. I would expect that to stop right there, but I guess it just doesn't want to. Maybe just try to step over. Okay, that didn't work. We'll go back. Okay. All right, yeah, I don't know what's going on with that async thing. I would expect it to stop here so I can see this, but oh wait, let's try this. Let's see. It doesn't want to. So this is why I use console.log a lot, because it's like, okay, when this wants to work, it works. But as you can see, it's pretty powerful if you needed to check some really detailed, intricate bug that you can't find. I mean, it was literally just 2 clicks. I had to click here, and let's just stop this right quick. And then I had to click here, and then Node. So 3 clicks, not so bad. 2 clicks if you use the keyboard shortcut, super powerful. So what's actually happening is VS Code is tapping into a feature that Node.js has, which is called inspect. So if I go into Node.js, here, let me back out, and I want to inspect the intro. So I can say node, and I'm going to run the index.njs. So intro index.njs, but not before I run --inspect -brk, which is for break. So this is going to run the inspector like we just saw, and then break immediately as soon as it opens. Otherwise, it'll just like run through it and execute and be done. So we want it to stop immediately. So we'll run break. So we'll run that. And you can see we get debugger listening on this. Go here for help. That's really cool. So we're going to open up Google Chrome. I'm going to click on my face, and then we're going to go to like Chrome inspect. There it is. So we're going to go to Chrome inspect, and you should see that you have a target here for that file that we're inspecting. So you can see it's Node version 14.7.0, and I can click inspect, and it just opens up the debugger here inside of Chrome. Same experience. You may or may not see files here. If you don't see any files here, you can click add folder to workspace, and then you can go look up the folder that's supposed to be here, and you can just click select, and it'll add it. I already did it, which is why mine is here. You can see the intro folder is highlighted, and you see that the green file is right here because that's what's paused, and here we are. We're right here. I could do the same thing. I could set breakpoints. I could do all the same stuff that we always did, and I could execute this and continue to go on. So as you see, I get an error because we left this code off in a broken state, so that's why the error is looking for an HTML file, not an HTML. So that's expected. But as you can see, the debugging experience can be pretty cool. A lot of people don't really reach for this tool, and I really think they should. It's getting better every day, especially since when I started using it 7 years ago. It's so much better now. So I highly recommend using the debugger and saving the console.logs for emergencies. Use the debugger to really flex on people. So use the debugger. Any questions about debugging in Node before we move on to deployment and publishing? Deployment. Now that you can basically develop with Node.js, we built APIs, we built CLIs, we built things that interacted with files, which are arguably the top 3 most use cases of Node.js. You need to learn how to get your apps off your local machine. You know, if you're building a front-end app, you deploy it to CDN. You build it. If it's a server render thing, you throw it on Heroku or Vercel or Netlify or whatever. You get it off your machine. You deploy it to some other machine somewhere else. Well, whatever you're doing with Node is going to determine how you deploy/publish it. So let's talk about, let's say you're making a package. So if we go back and look at some of the things that we worked on today, some of the packages were the CLI, that's a package. Maybe this file reading thing, that's a package. Pretty much everything here is a package except for the API, that's a server. So you can't deploy a package, it doesn't run, it gets executed on demand. There's a command you run and it gets executed and it stops. It's expected to be executed by a human. That's why there's a CLI. There's no programmatic interface between some of the stuff that we did. They're little scripts. So you can't actually deploy that to a server and have it hosted. That wouldn't make any sense. So instead, you would probably publish those. So that way someone can npm install your thing, right? So I'm going to walk you through how you can do that with npm. And there's a lot of ways you can do it, but I'm just going to walk you through how you can do it with npm. So if you want to publish something, you want it to be available to be downloaded, this is how you would do it. The first thing is, obviously make sure you have npm installed, which at this point I hope you do, because I don't know what you've been doing if you didn't. So I hope you have npm installed. The next thing is you need an npm account. So if you go to npm.js and sign in, you know what, I don't even know what mine is, but I know I got an account somewhere. So you need an account. And then the next thing is you need to log into your account via the npm CLI. So you can type in npm, log in. Hopefully I'm already logged in. Of course I'm not. Now it's going to ask me for the password that I don't remember. Okay, you want my email too? Okay. Okay, yeah, obviously, I don't know what my password is. Let's try this again. Okay. I don't want you guys watching me try to get into npm right quick. Let's see. You know what? I'm going to try to do this without the login. Let's see what happens. That way we can at least run through it. And then I could reset my password if I need to. But let's try to just do an npm publish on one of the packages, and we can at least run through the reps. So let's try to deploy this Reddit CLI. So it's got everything we need. It's got the git ignore. It's got the package.json. It's got this Reddit CLI. I bet that name's already taken, so I'm going to change this to Scott's Reddit CLI. If someone has that name, they deserve it. I'm just going to give it to them. The main is going to be index.mjs, and which obviously doesn't matter because it's a CLI, but whatever. And we should be good there. So now I'm going to cd into Reddit, and I'm going to say npm publish. And just like that, it published it. So it went ahead and published Scott Reddit CLI. We are good to go. You should actually be able to install that on your machine right now if you want to. Go ahead and npm install Scott Reddit CLI, and you can get access to it. In fact, I'm going to do it right now. Npm install Scott Reddit CLI. And it breaks out because I'm already inside of a package called Scott Reddit CLI, right? So let's go into another one like intro and run that again. And boom, I just installed the CLI into Scott's, into the intro file, and I can verify that. There should be like a bin folder in here, there is, and it should say Reddit, it does, and it should be my code, and it is. So I was able to install that. That's simple with NPM. The whole world has access to it now. So that's how you publish to NPM, and you should be, and the reason I wanted you to log in so you can go in and you can kind of manage all your different things, but apparently either I'm already logged in or it doesn't really care. I don't know, but yes, that's how you publish on NPM. You can't take down versions you already published, but you can just publish new versions. And I do recommend using the NPM CLI to do your versioning, so you can do something like NPM version. Let me go back to the Reddit CLI. You can do like NPM, or what is it? Is it version? No, it's like NPM bump. No, what is it? Let's see. I don't use this one that much. I use a bunch of automations that make this not as easy, or a lot easier. I'll just show you the one that I use. So I use something called semantic CLI, semantic release CLI. So I use this tool to help me with the versioning of my packages. It basically will look at my commit messages, like whatever type of message I wrote, to determine what the new version of my package is. So I do have to write my commit messages in a very strict way, but I'm used to it because I do a lot of open source and they make you write that stuff anyway. Like if you ever contribute to like Angular or React, they have like a very specific commit format that they want you to follow with the messaging and everything, because they use tooling as well. So if you do write your commit messages in a certain way, you can have a tool like semantic release, look at those commit messages and determine, like, do you need a minor number upgrade, a patch, or a major? It'll look at those things to determine. It'll generate the new version number for you, change it into package.json, and then you can just publish it. So that's pretty much what I use to get my packages published, although I haven't really published any packages in a couple months now. But when I was, that's what I did, and it was amazing. And then because all that's automatic, you could put that in the CLI. So you could just, if you merge something into the published branch, then whatever gets merged in there, the CLI or the CI will take care of that for you, so you don't have to publish on your own machine. So, automate all the things. Why not? So yeah, highly recommend looking into some flow like that if you're serious about publishing on NPM. Now, when it comes to servers are APIs. They need to be hosted on a machine, just like they're hosted on your local host. They have to be hosted somewhere else. So there's a lot of places you can deploy servers. There's really, we could talk for days about which one's better, which one's this or that, but at the end of the day, they're pretty much all the same. They have different trade-offs. We're gonna use Heroku today because it's just the easiest to do. It has the simplest UI, and you don't need to be a DevOps person to understand half the options in the dropdown. So we're gonna do Heroku. If you've never heard of Heroku, it is the best way I can describe Heroku. It is a really nice UI on top of AWS. They use AWS as their infrastructure, as do a lot of other competitors to Heroku do. It's just a better UI on top of it with better features, and well, I wouldn't say better features, simpler features. It's an abstraction around the complicatedness of AWS. So we're going to use Heroku for that. And to get started, we just have to do a few things, and I already done all these things, so I'm just going to walk you through some of the things that I didn't do, and then we'll get to it. The first thing is we need to get our application ready to be deployed. It has to be, deployable on another machine. Right now, there's a lot of stuff that's hard-coded that only works on our machine, specifically like the port. We hard-coded the port to be like 8,000. That's not gonna work. When we deploy this, we have no idea what the port's gonna be. It's gonna be assigned dynamically to whatever Heroku wants it to be. So we have to find a way to make that a dynamic variable because we don't have access to it yet. So those are some of the things that we need to do. We also need to teach Heroku about what type of app this is and how to start this app. You're not always gonna have the same start script. Sometimes you need to do this or do that. So you have to specify to Heroku how to start it. And then we actually have to create a Heroku app and push it up there. So we're gonna do just those things. The first thing, like I said, is create a Heroku account. If you don't have one, it's free. Doesn't cost any money to create an account. They're pretty generous with their free tiers. So highly recommend creating a Heroku account. It's great for just prototyping service that you want to deploy. Unless you're like really serious and you're making money, yeah, you can just get away with a free account for a long time. And then you want to install their Heroku CLI. This is just one way to create an app and deploy it. So we're going to follow this path, but you can also just go through their GUI, do a couple clicks and get it deployed that way. But for the sake of Node.js, we're going to stay in the terminal. We're going to try to do it this way. So install their CLI. And once you have that, you just need to tell Heroku what type of app this is. So the first thing we can do is we can add a start script to our scripts inside of our API. So I'm going to go to our API here, which is going to be the server. I'm going to go to the package.json that I don't have. So I'm going to make that. And I'm going to say npm init like that. Am I not in the server? Oh, there, one more. Forgot that last enter. So we're going to go here. We're going to go to scripts. I'm going to do start. And I'm just going to point this to the entry to my server, which in this case is going to be, I want to run the Express server, which is server.ms. So I'm going to point to that. So I'll say node server.mjs. So we're going to point to that. So that's how you start our server. So now Heroku knows how to do that. And the last thing is I need to tell Heroku like what version of JS that I'm using. And this is important because we are using a relatively new version of JavaScript that supports modules. So I need to say engines, and then you can say node, and then you can put the version. Mine is like 14.17, or what version am I using? Let me see, node. Version, yeah, 14.17.0. You could probably also just do like literally the number 14. It will probably work as well. It'll just find the latest 14. So it's going to do that just to specify we're on the same version, because the last thing you want is like, well, it worked on my machine. Well, yeah, your machine is using version 14, but on Heroku we're using version 8. So yeah, I'm sure it did work on your machine. It's a common thing. This is why something like Docker was created to like help with these problems. But we're not using Docker. We're just going straight to Heroku. Okay, so now that we got that, we do need to clean up our code a little bit to not be so hard-coded. So the one specifically is this port. I said we need to make this dynamic. It needs to be a variable. So we're going to say process.env.port, capital P-O-R-T. And I know this to be true, not only because I've deployed to Heroku so many times, but because this is honestly the default environment variable that every single hosting provider uses. They use the port, all caps. So we're going to do that. And I'm not going to put local. I mean, we could leave this here. This log is fine. It's not going to be accurate because we're not on localhost 8000 anymore, but you should change that as well. And I'm sure Heroku does inject like a host name variable on the environment that you could put here if you wanted to, but it's not hurting anybody, so we'll just leave it. And the next thing we want to do is we want to, we have the Heroku CLI. We should say Heroku like login. Okay, press any key. Okay, they want me to go update my terms of service on Heroku. So I guess I'll do that. Got this password manager here. I don't think I have npm here, otherwise I would have used it. So, ooh, I don't know if I want to use this account. Okay, let's do it. We're already here. Okay, looks like I updated my stuff, so we're good here. The next thing I want to do is, let me just update this along. Aha, I want to make sure I have the proper get ignore. I don't want to check in these node modules, so I'll do a dot get ignore, and at the very least, I'll check in these node modules. But you should also check in pretty much everything that I have here. It'll be very helpful. According to Heroku. So, but yeah, you don't want any error logs. You don't want dsstore, which is like this floating ghost file that floats around on Mac. It's kind of annoying and it's really big. And then any .env files, which are probably full of secrets. So ignore all those. And we did the login. Now we have to do a create. This is going to create an app on Heroku. Like I said, you could also do this in the GUI. It's totally fine if you want to do that. I'm just going to do it here from the command line. I'm going to say Heroku.create. It's going to make us a nice app. Get that nice Heroku spinner, that nice Zen name, Hidden Savannah. That's our URL there. And I need to add this Git URL to my Git repository. So this is not a Git repository yet. So I'm going to say git init like this. And then I'm going to say git remote add. I'm going to call this Heroku. I'm going to paste that to there. So now that I got that, I can say git push Heroku main. Did I not? Oh wait, did this already do this? Let's check this out. So, oh wait, hold on. Filter push and run. Oh, is it not called main? Hold on. Let's see, git remote -v. Yeah, it's right there. Git push Heroku. Maybe they still call it master. No. Git push Heroku. Let's just say git push Heroku. They want a branch. I'm pretty sure it's master or main or yeah, git push Heroku main. Guess it doesn't like that I did that. Let's just create a new app and I think it'll set it for us now that I have a git. Okay, now let's look at git remote -v or git remote Heroku remove git remote remove Heroku. And then let's create another one. And hopefully it added it for us. There we go. So it looks like it added it. So then I'll say git push Heroku main. Maybe that was it. So let's try to commit some code. I thought it would still try to push. Whoa, 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 whoa. What happened? Whoa. Sorry, I don't know what happened to my terminal. Okay, let me open it back up. What? Okay, that was weird. That was really weird. What was that? Okay, let's try to push this now. Git push Heroku main. Okay, let's just go to the GUI then. This is why you have a GUI. So let's go to Heroku. And I have a bunch of apps in here somewhere. Let's see. Personal. Looks like it was all of these right here. So I'll take let's take this Hidden Savannah one. And I'm going to deploy, and I can deploy from this thing. Says, let me try this. Okay, looks like we're good here. Then I should be able to do this. Let's give that a try. Hey, look at that. Gotta love that copy and paste documentation. So as you can see, it's building. This is the output of the build. It's like transferring to Heroku, and it's trying to detect what type of app I have and all that stuff. So it says Node.js app detected. Here's some environment variables that we put in your app, installing these binaries, blah, 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 a bunch of stuff here. Build succeeded, that's what I wanted to see. Default types is the web process. So in Heroku, a web process means this is an API, because you can also have background like job processes, which are background jobs and not web process. It defaults to web if you have a start script. And it says it deployed. So let's see what happens. So if we try to go to this URL, let me just confirm what we had in our API, which was a /to-do post and get. So I'm gonna try this from the terminal. I'm gonna say HTTP that thing /to-do. Let's do a GET request. And look, it returns an empty array. That works. So let's try to do a post and put a something in there. I think it was a text field that we wanted on the object. So we'll say clean kitty litter. My cat poops a lot, so we got to clean a kitty litter. And we're gonna do that. Looks like that worked. And we can get it back with this, and boom, there we go. Our app is deployed. We can confirm. If we go back to Heroku, and I can look at activity, or not activity, I'm sorry, it should be view logs. Here we go. And we should see some logs here. You can see that I did a get request to /to-do. I did another post and another get here. So everything seems cool. And then here's our outdated localhost 8000 log, which isn't relevant anymore, but like I said, it's not hurting anybody. And that's how you would deploy a server. So Heroku allows you to add like databases and different things like that. And they have documentation on that, much better than I could describe. So if that's what you're looking for, you can go much further with that. Well, that's pretty much all I wanted to cover today as far as the curriculum and walk you through Node. The stuff I want to leave you with is what I recommend doing next and how to like take advantage of the community and really how to get the best of it. So we did talk about on front-end masters, Node API design. I guess I should have just looked up my name. That's what I should have did. Front-end masters, Scott, there we go. So I do have a course on here for, right here, API design in Node.js v3. If you want to really get into it, you can see I'm talking about a whole bunch of APIs, databases, routes, caching, CRUD, automations, authentication, pretty much everything. So this is a really good next step if you want to just focus on building APIs. There's also a really nice course on here. Forgot what it's called exactly, but I think it's by Jim Young, and it's about like DevOps or backend for front-end engineers. That one's really good. I actually took that one. It was really nice. And then I also have an introduction to MongoDB, if that's what you're interested in, if you want to learn how to do Mongo. So check that one out as well. So I recommend doing one of those. There we go. Learning paths, and then you go down to Node. Bam. Here you go. Look at that. Look at that guy. Who's that guy? Oh yeah, Will Siddons has a really good one. Yeah, look at this. This is a really great path. That's the one that I was looking for. Full stack for front engineers, V2, the capstone project. So yeah, highly recommend going through this if you're really interested in Node.js. I've taken a lot of these courses myself. The instructors here are super talented. So yeah, check those out if you want to know more and if you want to do a deep dive. But at this point, you know, you pretty much know more than the basics of what it takes to build something. Something that I like to do is I like to take like a small chunk of time, whether it's like 60 minutes or 90 minutes, especially in Node, and like pick a technology that I'm just not familiar with in Node, whether it's like streams, WebSockets, HTTPS, a different database, and I'll like, all right, 60 minutes, build the smallest thing you can make with this, whether it's following a Hello World tutorial on the documentation website or watching a video. I try to build the smallest thing that I can, and I try to do that multiple times. And usually within a week, I really understand that technology to the point where I'm comfortable talking about it, and it's no longer like foreign to me. And I might not be great at it, but I'm no longer foreign. And that's kind of like how I develop my knowledge, and that's kind of how like I move through things. And then when I come across it in the real world and I use it at work, that's when I develop a deep knowledge for it. So that's just some of the tips that I wanted to pass on to you. And you know, I don't know if that'll work or not, but that's just how I do things. Other than that, I can leave you with some really cool JavaScript projects or Node.js projects that I think are really cool. So we have like Nest.js, which is a progressive Node.js framework. They have a cat. I mean, if that doesn't sell it for you, I don't know what will. There's more cats. So yeah, try out Nest.js. If you ever use Angular 2, you'll feel at home with Nest.js. It's a really good framework. And then you have something called, we talked about Happy. So Happy with an I. This is like another framework that's serves the same purpose as Express, but just built differently. So Happy is a very good one. And I would say another good one would be looking at just serverless functions. And those are pretty much everywhere. You have those in Netlify, Vercel, AWS, Google Cloud. I mean, everyone has some type of flavor of serverless functions. I highly recommend checking those out. I wouldn't say that they're great for doing like APIs, but they're really great for doing like one-off things that someone isn't waiting on. So I would recommend it for that. Other than that, one thing that helped me out a lot was I would go into the source code of projects like Webpack or Parcel or Rollup just to see how these things worked, because they always seemed so magical to me, and I wanted to understand how they work. They're just written in JavaScript, and they do so much with the file system. I highly recommend just going through the code and observing some of the patterns and see if you can make sense of what's actually happening. And even if it's confusing, you're going to see something that I think might enlighten you onto how this works and might give you some inspiration on how you can make some plugins or things like that. And that's usually how I like to start when I want to contribute. And speaking of contributing, if you find a package that you want to contribute to, whether it's React or something like that, did you know that if you go to GitHub, and for instance, if I go to React, which obviously is not going to give me what I wanted because it's like Facebook React, and you click on issues, and if you click on label, and if you type in like good first issue, a lot of them really put really good issues on here, and sometimes they'll even put like the answer that you can copy and paste. When I say answer, the solution that you can copy and paste, because they really want to invite more people to come in here and contribute. So if you want to get that nice badge on your GitHub profile, go to some of these big projects, see if you can find one with a good first issue. It might be something as simple as fixing a typo in a README, and it says you're a contributor. So it's a really good way to get started in the community. It's something that I did a couple years ago, and I don't regret it. So highly recommend doing that to contribute to the community and give back and start making your own stuff. So other than that, does anyone have any other questions about anything that we covered today?
A question about upgrading NPM packages. What's the best path forward?
Every time I upgrade a package, I'm always scared what's about to happen. So I would say don't just upgrade a package because there's a new version. Only upgrade the package if there's something in the package that you need. So if you identify the fact that like, oh, this new version of this package that we use came out and we need this feature, because you got to think about it. It depends on what type of upgrade it is. If it's a major upgrade, like a major version, went from version 7 to version 8, that means there's a breaking change. So you need to identify what that breaking change is and determine how bad it's going to be for you to refactor in your app. Like for instance, if React came out tomorrow, it's like, oh, we don't use JSX anymore. We use this other thing. Okay, imagine how many components you would have to refactor to use this other thing. So you probably wouldn't want to upgrade, right? So you just don't want to upgrade all the time simply because there's a better version. So yeah, identify if you need it, and then if you do want to upgrade, you can actually just type in npm updates followed by like the package. So let me say express. So if you do like npm update followed by the package, it'll update that package for you, and it'll save it and do the config file and all that stuff. But again, that's only if you've identified that you need the update. That's what the lock files are for, to make sure you're always on the locked in version. And that way you guarantee that there aren't any bugs, because the last thing you want is an update causing you a bug that you didn't find out until after your user found it when you deployed it. So be cautious of that.
I believe you covered this earlier in the course, so you don't need to repeat yourself, but in case you didn't, what's the best way to import ES module package into a common JS one?
The best way to import an ES module into a common JS one is, in that case, it wouldn't be any different. You would still use require, and you would have to determine if, was it a default export? So if they did, where am I doing some of this at? Here. Here we go. So you can see right here, the FS promises, these are named exports, so we can wrap them in brackets. So if I were to import this inside of a non-ES file, so it'll look something like this, right? It'll literally look the same. It'll be like this, like that, except for it'll say equals require. So this should work the same as the non-ES equivalent, because that's a named export. Now, if this wasn't named and this was a default one, as in like if we just did FS, which also works, then this will also be the same. It would be FS. So it's pretty much the same. You just swap the import with a var, a let, or a const, and you swap the from with the require. Everything else should stay the same when you're coming from ES modules to common. It's the other way around that you have to watch out for. It's like, oh, well, hold on now, there's no concept of default exports and, you know, in CommonJS. So if you try to import a default, it might not work. So you got to figure that part out. But yeah, that's how you do that.
For this next question, I will say that we do have a WebAssembly course by Gem, so you should check that out. But this person's asking if you personally have experience with importing a WebAssembly module from like compiled from a different language into Node and using it, and what's your thoughts on that?
That's a really good question. Unfortunately, I have no experience importing WebAssembly into Node, and that's simply because I just haven't had a reason to yet. Like, don't get me wrong, it sounds interesting and amazing, but I'm one of those people where like I'm very problem driven, and I just haven't ran into a problem yet that WebAssembly is going to help me solve. And that's mostly also because I'm a product person. I like to just focus on building products that people love, and the technology behind it is not that important to me. It's mostly just something that I can use really fast to get things done really fast and really quick to test them out. So yeah, for that reason, I haven't tried WebAssembly, although I am up to date on like what it is and how to use it and why it's here. But yeah, I think Jim Young's course would probably be better, and I would imagine he would have a way better answer to that question and give a better opinion than what I currently just did.
What's your opinion on TypeScript in Node? Have you used TypeScript?
Yeah.
Do you think there's a lot of value in it on the back end?
I believe TypeScript is the future, to be honest. I mean, Dino is literally TypeScript native. So I literally write everything in TypeScript. It actually feels weird right now writing something in JavaScript. I haven't written non-typed files in a long time. So yeah, I love TypeScript. Using it on Node is amazing. It's not native, so you would have to compile that with like the TSC command line, which is the TypeScript compiler command line, and set up a config file, tsconfig file, to do that. But other than that, yeah, it's really cool. I mean, you can actually use Babel now. Babel supports TypeScript, Babel 7. So you could do that as well, either of which you would need to compile it. But yeah, there is just as much value on the back end with TypeScript as there is on the front end, and maybe even more, because there's no visual representation of what you're getting on the back end. So at least on the front end, like you can go like, oh, I'm using a React box. What does it look like? You can just use it and see what it looks like. It's a box. Well, you can't really see what it looks like on the server. So having that TypeScript kind of like be your eyes about what is the IO between this method and yours, it's really nice. So yeah, highly recommend using TypeScript whenever you can, in my opinion, because you could use TypeScript and not use any types, and it's still just like the latest JavaScript. And also on that point, I just remembered, so I talked about using like MJS files and JavaScript files, but that's only if you want to use ECMAScript modules natively in Node. If you use something like Babel or TypeScript, then you can use the ECMAScript files without the MJS and all that nonsense, because those tools actually fix that for you, right? Like they handle the modules and stuff for you and the interop. So this is just if you don't want to use it with a compiler. But if you use or transpiler, if you use a transpiler like Babel or TypeScript, then no, you don't have to worry about, MJS versus JS. No, you can just call it JS, and you can use the module syntax, because it's not Node that's processing that. By the time Node reads it, it's going to be the output of that, which will probably just be CommonJS. Awesome. I appreciate everyone coming to this course. I'm glad I got the chance to come in and update it. I hope you got some value from it. If there's anything else I can do, hit me up on Twitter at ScottUps. I respond on Twitter all the time if I can spell my own thing. Yeah, so hit me up on there if there's anything I can do for you. Or even on LinkedIn, I'm pretty responsive on there as well. And yeah, I hope you continue on with your Node stuff. Let me know if this was helpful for you, if you got some value out of it and what you've done in your job, and how I could potentially make this better for the next one, or maybe I do an advanced course on Node. Who knows? Let me know. Any feedback will be great. And again, thanks for coming.